according to the documentation of this function only, 1 is the first set of parentheses, and 2 is the second set, and onward from there. Just a different convention here. Other questions?
What if we write nothing, like white space, comma, white space? How we check true of condition?
Before I answer directly, let me just run this and make sure I've not broken anything further. Let me run python of format.py. Let me type in David space Malin the right way. Let me run it once more. Let me type in Malin, comma, David the wrong way that we're fixing, and we're still good. But I think it will still break. Let me run it a third time with Malin, comma, David with no space. And now it's still broken. Why? Because I'm still looking for comma space. Now, how can I fix that? One way I could do that is to add a question mark here, which again is 0 or more of the thing before. So if I have a space and then a question mark literally, no need for any parentheses, then I can literally tolerate both Malin, comma, space David or Malin, comma, David. So let's try again. Before this did not work. Let's do Malin, comma, David with no space. Now it does actually work. So we can tolerate different amounts of white space if I am a little more precise with my formula. Let me go ahead and try once more. Let me very weirdly, but possibly, hit the spacebar a few too many times. So now they're really separated. This, again, is not going to work quite right because it's going to consume all of that white space. So now I might want to strip left and right any of the leading white space on the result. Or what I could do here is say this. Instead of 0 or 1, I could use a star here. So space star. And now if I run this once more with Malin, comma, space, 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 David, enter, now we've cleaned up things further. So you can imagine, depending on how messy the data is that you're cleaning up, your regular expressions might need to get more and more sophisticated. It really depends on just how many problems we want to solve at once. Well, allow me to propose that we forge ahead further just to clean this up even more so using a feature that's actually relatively new to Python itself. It is very common when using regular expressions to do exactly what I've done here, to call a function like re.search with capturing parentheses inside such that you get back a return value that I'm calling matches. You could call it something else, but I'm calling it by default matches. And then notice on the next line, I'm saying if matches. Wouldn't it be nice if I could just tighten things up further and do these all on the same line? Well, you can sort of. Let me go ahead and do this. Let me get rid of this if. And let me just try to say something like this. If matches equals re_search and then colon. So combining my if condition into just one line instead of those two. In C or C++ or Java, you would actually do something like this, surrounding the whole thing with parentheses, sometimes double sets to suppress any warnings, if you want to do two things at once. If you want to not only assign the return value of re.search to a variable called matches, but you want to subsequently ask a Boolean question. Is this effectively true or false? That's what I was doing a moment ago. Let me undo this. A moment ago, I was getting back the return value and assigning it to matches, and then I was asking the question. Well, it turns out this need to have two lines of code presumably rubbed people wrong for too long in Python, and so you can now combine these two kinds of lines into one, but you need a new operator. You cannot just say if matches equals re_search and then a colon at the end. You instead need to do this. You need to do colon equals if and only if you want to assign something from right to left, and you want to ask an if or an elif question on the same line. This is affectionately known, as you can see here, as the walrus operator. And it's new to Python in recent years. And it both allows you to assign a value, as I'm doing, from right to left, and ask a Boolean question about it, like I'm doing with the if or equivalently elif. Does anyone know why this is called the walrus operator? If you kind of look at it like this, perhaps, if you're familiar with walruses, it kind of sort of looks like a walrus. So a minor detail, but a relatively new feature of Python that honestly you'll probably continue to see online and in source code and in textbooks and so forth, increasingly so now that it does exist. It does not change the logic at all. If I run python of format.py and type Malin, comma, space David, it still fixes things, but it's tightened up my code just a bit more. All right, let's go ahead and look at one final problem to solve, that of extracting information now as well. So at this point, we've now validated the user's input by checking whether or not it meets a certain pattern. We've cleaned up the user's input by checking against a pattern whether it matches or not. And if it does match, we kind of reorganize some of the user's information so we can clean up their input and standardize the format in which we're storing or printing it in this case. Let's do one final example where we're very specifically extracting information in order to answer some question. So let me propose this. Let me go ahead and close format.py and create a new file called twitter.py. The goal of which is to prompt users for the URL of their Twitter profile and extract from it, infer from that URL, what is the user's username. Now, why might you want to do this? Well, one, you might want users to be able to just very easily copy and paste the URL from their own Twitter profile into your form, into your app, so that you can figure out what their username is. Or you might have a form that asks the user for their Twitter username. And because people aren't necessarily paying very close attention, some people type their username. Some people type their whole URL or something else altogether. It would be nice, now that you're a programmer, to just be more tolerant of different types of input and just take on the burden of canonicalizing, standardizing the data, but being flexible with the users. It's arguably a better user experience if you just let me copy paste or type in what I want. You clean it up. You're the programmer, not me. Lens for a better experience, perhaps. Well, let me go ahead and do this with twitter.py. Let me first go ahead and prompt the user here for a value for a variable that I'll call URL, and just ask them to input the URL of their Twitter profile. I'm going to go ahead and strip off any leading or trailing white space, just in case users accidentally hit the spacebar. That's like literally the least I can do quite easily. But now let's go ahead and do this. Suppose that the user's address is the following. Let me print out what they type in, and let me clear my screen and run Python of twitter.py. I'm going to go ahead and type in, for instance, https://twitter.com/davidjmalin, which happens to be my own Twitter username. For now, we're just going to print it back onto the screen just to make sure I've not messed up yet. OK, so I've printed back out the exact same URL, but the goal at hand is to extract the username only. Now, let me just ask perhaps a straightforward question. Logically, what do I need to do to get at the user's username?
Well, we just ignore what's before the username and then just extract the username.
Perfect. Yeah, I mean, it is as simple as that. If you know the usernames at the end, well, let's just somehow ignore everything to the beginning. Well, what's at the beginning? Well, it's a URL. So we're probably going to need to ignore an HTTPS, a : / a twitter.com, and a slash. So we just want to throw all of that away. Why? Because if it's a URL, we know by how Twitter works that the username comes at the end. So let's use that very simple idea to get at the information we want. Well, I'm going to try this a few different ways. Let me go back into my program here, and instead of just printing it out, which was just to see what's going on, let me do this. Let me create a new variable called username, and let me call url.replace. It turns out that if URL is a string or a str in Python, it again comes with multiple methods like strip and split and others as well, one of which is called replace. And replace will do just that. You pass it 2 arguments, the first of which is what do you want to replace? The second argument is what do you want to replace it with? So if I want to get rid of, as Ivan proposed, really just everything before the username, that is the Twitter URL or the beginning thereof, let's just say this. Go ahead and replace https:// twitter.com/ close quote. That's what I want to replace. And comma, second argument, what do you want to replace it with? Nothing. So I'm literally going to pass in quote unquote to effectively do a find and replace. That's what the replace method does, just like you can do it in Microsoft Word or Google Docs. This is the programmer's way of doing find and replace. Now, let me go ahead and print out just the username. So I'll use an F string like this. I'll say username, : and then in curly braces, username, just to format it nicely. All right, let me go ahead and clear my screen and run Python of twitter.py, enter URL. Here we go, https:// twitter.com/ davidjmalin, enter. OK, now we've made some progress. Done for the day, right? Well, what is suboptimal about this? Can anyone critique or find fault with my program? It is working now, but it's a little fragile. I bet we could contrive some scenarios where I think it works, but it doesn't.
Well, I have a few ideas actually. Well, first of all, if we don't specify HTTPS, it will broken. Secondly, if we have slash at the end, it also will be broken. If we have like a question mark or something after question mark, it also won't work. So a lot of scenarios actually.
Oh my God. I mean, here we are. I was pretending to think I was done, but my God, like Alex gave us a whole laundry list of like problems. And just to recap then, what if it's not HTTPS, it's HTTP? Slightly less secure, but I should still be able to tolerate that programmatically. What if the protocol is not there? What if the user just typed twitter.com/DavidJMalin? It would be nice to tolerate that rather than show an error and make me type in the protocol why. It's not good user experience. What if it had a slash at the end of the username or a question mark? If you think about URLs you've seen on the web, there's very commonly more information, especially if it's been shared on social media. There might be HTTP parameters, so to speak, just stuff there that we don't want. There could be a www.twitter.com, which I'm also not expecting, but does work if you go to that URL too. So there's just so many things that can go wrong. And even if I come back to my contrived example as earlier, what if I run this program and say this? My username is https://twitter.com/DavidJMalin. Enter. Well, that too just didn't really work. It got rid of the URL. Actually, OK, actually that kind of worked. But the goal here is to actually get the user's username, not an English sentence describing the user's username. So I would argue that even though I just accidentally created perfectly correct English grammar, I did not extract the Twitter username correctly. I don't want words like my username is as part of my input. So how can we go about improving this and maybe chipping away at some of those problems one by one? Well, let me clear my screen here. Let me come back up to my code and let me not just replace it, but let me do something else instead. I'm going to go ahead and instead of using replace, I'm going to use another function called remove prefix. A prefix is a string or a substring that comes at the start of another. So if I remove prefix, I don't need a second argument for this function. I just need one. What prefix do you want to remove? So this will at least now fix the problem I just described of typing in like a whole sentence where the URL is there, but it's not at the beginning. It's only at the end. So here, this still is not correct, but we don't create this weird looking output that just removes the URL part of the input. My username is https://twitter.com/DavidJMalin. A moment ago, it did remove the URL and left only the David J. Malin. This is not perfect still, but at least now it does not weirdly remove the URL and then leave the English. It's just leaving it alone. So maybe I could handle this better, but at least it's removing it from the part of the string I might anticipate. Well, what else could we do here? Well, it turns out that like regular expressions just let us express patterns much more precisely. We could spend all day using a whole bunch of different Python functions like remove prefix or remove and strip and others and kind of make our way to the right solution. But a regular expression just allows you to more succinctly, if admittedly more cryptically, express these kinds of patterns and goals. And we've seen from parentheses, which can be used not just to group symbols together as sets, but to capture information as well, we have a very powerful tool now in our toolkit. So let me do this. Let me go ahead and start fresh here and import the RE library as before at the very top of my program. I'm still going to get the user's URL via the same line of code, but I'm now going to use another function as well. It turns out that there's not just re.search or re.match or re.fullmatch. There's also re.sub in the regular expression library, where sub here means substitute. And it takes more arguments, but they're fairly straightforward. The first argument to re.sub is the pattern, the regular expression that you want to look for. Then you have a replacement string. What do you want to replace that pattern with? And where do you want to do all that? Well, you pass in the string that you want to do the substitution on. Then there's some other arguments that I'll wave my hands at for now. Among them are those same flags and also a count, like how many times do you want to do find and replace? Do you want it to do all? Or do you want to do it just one? Or so forth. You can have further control there too, just like you would in Google Docs or Microsoft Word. Well, let me go back to my code here. And let me do this. I'm going to go ahead and call re, not search, but re.sub for substitute. I'm going to pass in the following regular expression, https://twitter.com / and then I'm going to close my quote. And now what do I want to replace that with? Well, like before, with the simple stir replace function, I want to replace it with nothing. Just get rid of it altogether. But what string do I want to pass in to do this to? The URL from the user. And now let me go ahead and assign the return value of resub to a variable called username. So resub's purpose in life is, again, to substitute some value for some regular expression some number of times. It essentially is find and replace using regular expressions. And it returns to you the resulting string once you've done all those substitutions. So now the very last line of my code can be the same as before, print, and I'll use an F string, username, colon, and then in curly braces, username. So I can print out literally just that. All right, let's try this and see what happens. I'll clear my terminal window, run python of twitter.py, and here we go, https://twitter.com/davidjmalin. Cross my fingers and hit enter. OK, now we're in business. But it is still a little fragile. And so let me ask the group, what problem should I now further chip away at? They've been said before, but let's be clear. What's one or more problems that still remain?
The protocols and the domain prefixes po.
Good, the protocol, so HTTP versus HTTPS. Maybe the subdomain, www, should it be there or not? And there's a few other mistakes here too. Let me actually stay with the group. What are some other shortcomings of this current solution?
If we use a phrase like you do before, we are going to have the same problem because it's not taking account in the first part of the text example.
Good. I might still allow for like some words, some English to the left of the URL because I didn't use like my caret symbol. So I'll fix that. And any final observations on shortcomings here?
It could be a HTTP, or there could be like less than 2 slashes.
OK, so it could be HTTP. And I think that was mentioned too in terms of protocol. There could be fewer than 2 slashes. That I'm not going to worry about. If the user gives me 1 slash instead of 2, that's really user error. And I could be tolerant of it. But you know what? At that point, I'm OK yelling at them with an error message saying, please fix your input. Otherwise, we could be here all day long trying to handle all possible typos. For now, I think in the interest of usability or user experience, UX, let's at least be tolerant of all possible valid inputs or reasonable inputs, if you will. So let me go here and let me start chipping away at these here. What are some problems we can solve? Well, let me propose that we first address the issue of matching from the beginning of the string. So let me add the caret to the beginning. And let me add not a $sign at the end, though, right? Because I don't want to match all the way to the end because I want to tolerate a username there. So I think we just want the caret symbol there. There's a subtle bug that no one yet mentioned. And let me just kind of highlight it and see if it jumps out at you now. It's a little subtle here on my screen. I've highlighted in blue a final bug here. Maybe some smiles on the screen. Yeah, can we take one hand here? Why am I highlighting the dot in twitter.com, even though it definitely should be there?
So the dot without a backslash means any character is of a new line?
Yeah, exactly. It means any character. So I could type in something like Twitter ?com or Twitter anything.com, and that would actually be tolerated. It's not really that bad because why would the user do that? But if I want to be correct and I want to be able to test my own code properly, I should really get this detail right. So that's an easy fix too, but it's a common mistake. Anytime you're writing regular expressions that happen to involve special symbols, like dots in a URL or domain name, a $sign in something involving currency, remember, you might indeed need to escape it with a backslash like this here. All right, let me ask the group about the protocol specifically. HTTPS is a good thing in the world. It means secure. There is encryption being used, so generally you like to see HTTPS, but you still see people typing or copy-pasting HTTP. What would be the simplest fix here to tolerate, as has been proposed, both HTTP and HTTPS? I'm going to propose that I could do this. I could do HTTP vertical bar or HTTPS, which again means A or B, but I think I can be smarter than that. I can keep my code a little more succinct. Any recommendations here for tolerating HTTP or HTTPS?
We could try to put a question mark behind the S.
Perfect. Just use a question mark, right? Like both of those would be viable solutions. If you want to be super explicit in your code, fine. Use parentheses and say HTTP or HTTPS so that you, the reader, your boss, your teacher, just know exactly what you're doing. But if you keep taking the more verbose approach all the time, it might actually become less readable, certainly once your regular expressions get this big instead of this big. So let's save space where we can. And I would argue that this is pretty reasonable. So long as you're in the habit of reading regular expressions and know that question mark does not mean a literal question mark, but it means 0 or 1 of the thing before, I think we've effectively made the S optional here. Now, what else can I do? Well, suppose we want to tolerate the www dot, which may or may not be there, but it will work if you go to a browser. I could do this, www dot. Wait, I want a backslash there, so I don't repeat the same mistake as before. But this is no good either, because I want to tolerate www being there or not being there. And now I've just required that it be there. But I think I can take the same approach. Any recommendations? How do I make the www dot optional? Just to hammer this home.
We can group, make a square and question mark.
Perfect. So question mark is the short answer again, but we have to be a little smarter this time. As Maria's noted, we need parentheses now, because if I just put a question mark after the dot, that just means the dot is optional. And that's wrong, because we don't want the user to type in www.twitter. We want the dot to be there, or just not at all with no www. So we need to group this whole thing together. Put a parenthesis there, and then a parenthesis not after the third W, after the dot, so that that whole thing is either there or it's not there. And what else could we still do here? There's going to be one other thing we should tolerate, and it's been said before, and I'll pluck this one off. What about the protocol? Like, what if the user just doesn't type or doesn't copy paste the HTTP : or an HTTPS : right? Honestly, you and I are not in the habit generally of even typing the protocol anymore nowadays. You just let the browser figure it out for you and automatically add it instead. So this one's going to look like more of a mouthful, but if I want this whole thing here in blue to be optional, it's actually the same solution as Maria offered a moment ago. I'm going to go ahead and put a parenthesis over here and a parenthesis after the 2 slashes and then a question mark, so as to make that whole thing optional as well. And this is OK. It's totally fine to make this whole thing optional, or inside of it, this little thing, just the S, optional as well. So long as I'm applying the same principles again and again, either on a small scale or a bigger scale, it's totally fine to nest one of these inside of the other. Questions now on any of these refinements to this parsing, this analyzing of Twitter?
What if we put a vertical bar besides this www dot?
What if we use a vertical bar there? So we could do something like that too. We could do something like this. Instead of the question mark, I could do www dot or nothing and just leave that in the parentheses. That too would be fine. I personally tend not to like that because it's a little less obvious to me. Wait a minute, is that deliberate, or did I forget to finish my thought by putting something after the vertical bar? But that too would be allowed there as well, if that's what you mean. Other questions on where we left things here, where we made the protocol optional too?
What would happen if we have parenthesis, and then inside we have another parenthesis and another parenthesis? Would it interfere with each other?
If you have parentheses inside of parentheses, that too is totally fine. And indeed, that should be one of the reassuring lessons today. As complicated as each of these regular expressions has admittedly gotten, I'm just applying the exact same principles and the exact same syntax again and again. So it's totally fine to have parentheses inside of parentheses if they're each solving different problems. And in fact, the lesson I would really emphasize the most today is that you will not be happy if you try to write out a whole complicated regular expression all at once. Like, if you're anything like me, you will fail and you will have trouble finding the mistake because, my God, look at these things. They are, even to me all these years later, cryptic. The better way, I would argue, whether you're new to programming or as old to it as I am, is to just take these baby steps, these incremental steps where you do something simple, you make sure it works. You add one more feature, make sure it works. Add one more feature, make sure it works. And hopefully by the end, because you've done each of those steps one at a time, the whole thing will make sense to you, but you'll also have gotten each of those steps correct at each turn. So please do avoid the inclination to try to come up with long, sophisticated regular expressions all at once, because it's just not a good use of a time if you then stare at it trying to find a mistake that you could have caught if you did things more incrementally instead. All right, there still remains arguably at least one problem with this solution, in that even though I'm calling re.sub to substitute the URL with nothing, quote unquote, I then, on my final line of code, line 6, am just blindly assuming that it all worked. And I'm going to go ahead and print out the username. But what if the user, if I clear my screen here and run python of twitter.py, doesn't even type a Twitter URL? What if they do something like https://www.google.com/, like completely unrelatedly, for whatever reason, enter? That is not their Twitter username. So we need to have some conditional logic, I would argue, so that for this program's sake, we're only printing out, or in a back-end system, we're only saving into our database or a CSV file the username if we actually matched the proper pattern. So rather than use re.sub, which is useful for cleaning up data, as we've done here to get rid of something we don't want there, why don't we go back to re.search, where we began today, and use it to solve the same problem, but in a way that's conditional, whereby I can confidently say yes or no at the end of my program. Here's the username, or here it is not. So let me go ahead now, and I'll clear my terminal window here. I'm going to keep most of I'm going to keep the first two lines the same, where I import re and I get the URL from the user. But this time, let's do this. Let's this time search for, using re.search instead of re.sub, the following. I'm going to start matching at the beginning of the URL of the string, https, question mark to make the s optional, colon // Then I'm going to make my www optional by putting that in question marks there. Then a twitter.com with a literal dot there, so I'll stay ahead of that issue too. Then a slash. And then, well, this is where David J. Malin is supposed to go. How do I detect this? Well, I think I'll just tolerate anything at the end of the URL here. All right, $sign at the very end, close quote. For the moment, I'm going to stipulate that we're not going to worry about question marks at the end or hashes, like for fragment IDs and URLs. We're going to assume for simplicity now that the URL just ends with the username alone. Now, what am I going to do? Well, I want to search for this URL specifically, and I'm going to ignore case. So re.ignore case, applying that same lesson learned from before. re.search, recall, will return to you the matches you've captured. Well, what do I want to capture? Well, I want to capture everything to the right of the twitter.com URL here. So let me surround what should be the user's username with parentheses. Not for making them optional, but to say capture this set of characters. Now, re.search, recall, returns an answer. Matches will be my variable name again, but I could call it anything I want. And then I can do this. If matches, now I know I can do this. Let's print out the format string, username colon, and then what do I want to print out? Well, I think I want to print out matches.group1 for my matched username. All right, so what am I doing just to recap? Line 1, I'm importing the library. Line 2, I'm getting the URL from the user, so nothing new there. Line 5, I'm searching the user's URL, as indicated here as the second argument, for this regular expression, this pattern. I have surrounded the dot plus with parentheses so that they are captured ultimately. So I can extract in this final scenario the user's username. If I indeed got a match, and matches is none, it is actually containing some match, then and only then print out username. In this way, let me try this now. If I run python of twitter.py and type in https://www.google.com/, now nothing gets printed. So I've at least solved the mistake we just saw, where I was just assuming that my code worked. Now I'm making sure that I have searched for and found the Twitter URL prefix. All right, well, let's run this for real now. Python of twitter.py, https://twitter.com/DavidJMalin. But note, I could use HTTP. I could use www. I'm just going to go ahead here and hit enter. Huh, none. What has gone wrong? This one's a bit more subtle. But why does matches.group1 contain nothing. Wait a minute. Maybe I did this wrong. Maybe do we need the www? Let me run it again. So here we go. https:// let's add it. www.twitter.com/DavidJMalin. All right. Enter. Ho ho ho. What is going on?
You have to say group 2.
I have to say group 2. Well, wait, oh, right, because we had the subdomain was optional, and to make it optional, I needed to use parentheses here, and so I then said 0 or 1. Okay, so that means that actually I'm unintentionally, but by design, capturing the www dot, or none of it if it wasn't there before, but I have a second match over here because I have a second set of parentheses. So I think, yep, let me change matches group 1 to matches group 2, and let's rerun this. Python of twitter.py, https://www.twitter, let's do this, twitter.com/DavidJMalin, enter, and now we've got access to the username. Let me go ahead and tighten it up a little bit further. If you like our new friend, it's hard not to like. If we like our old friend, the walrus operator, let's go ahead and add this just to tighten things up. Let me go back to VS Code here, and let me get rid of the unnecessary condition there and combine it up here. If matches equals that, but let's change the single assignment operator to the walrus operator. Now I've tightened things up further, but I bet there might be another solution here. And indeed, it turns out that we can come back to this final set of syntax. Recall that when we introduced these parentheses, we did it so that we could do A or B, for instance, with the vertical bar, though you can even combine more than just one bar. We used the group to combine ideas like the www dot, and then there's this admittedly weird syntax at the bottom here, up until now not used. There is a non-capturing version of parentheses if you want to use parentheses logically, because you need to, but you don't want to bother capturing the result. And this would arguably be a better solution here because, yes, if I go back to VS Code, I do need to surround the www dot with parentheses, at least as I've written my regex here, because I wanted to put the question mark after it. But I don't need the www dot coming back. In fact, let's only extract the data we care about just so there's no confusion down the road for me or my colleagues or my teachers. So what could I do? Well, the syntax per this slide is to use a question mark and a colon immediately after the open parenthesis. It looks weird, admittedly. Those of you who have prior programming experience might recognize the syntax from ternary operators, doing an if-else all in one line. A question mark colon at the beginning of that parenthetical means, yes, I'm using parentheses to group these things together, but no, you do not need to capture them instead. So I can change my code back now to matches.group1. I'll clear my screen here, run python of twitter.py. I'll again run here https://twitter.com/DavidJMalin with or without the www. And now I indeed get back that username. Any questions then on these final techniques?
So first of all, could we move the caret right at the beginning of Twitter and then just start reading from there and then get rid of everything else before that, the kind of www issues that we had? And then my second question is, how would we use kind of, I guess, either a list or a dictionary to sort the .com kind of thing, because we have .co.uk and that kind of stuff. How would we bring that into the RE function?
A good question, but no. If I move the caret before twitter.com and throw away the protocol and the www, then the user is going to have to type in literally twitter.com/username. They can't even type in that other stuff, so that would be a regression, a step back. As for the .com and the .org and .edu and so forth, the short answer is there's many different solutions here. If I wanted to be stringent about .com, and suppose that Twitter probably owns multiple domain names, even though they tend to use just this one. Suppose they have something like .org as well. You could use more parentheses here and do something like this, com or org. I'd probably want to go in and add a question mark colon to make it non-capturing, because I don't care which it is. I just want to tolerate both. Alternatively, we could capture that. We could do something like this where we do +, so as to actually capture that. And then we could do something like this. If matches.group1 now equals com, then we could support this. So you could imagine factoring out the logic just by extracting the top-level domain, or TLD, and then just using Python code, maybe a list, maybe a dictionary, to validate elsewhere outside of the regex if it's in fact what you expect. For now, though, we kept things simple. We focused only on the .com in this case. Let's make one final change to this program so that we're being a little more specific with the definition of a Twitter username. It turns out that we're being a little too generous over here, whereby we're accepting one or more of any character. I checked the documentation for Twitter, and Twitter only supports letters of the alphabet, A through Z, numbers 0 through 9, or underscore. So not just dot, which is literally anything. So let me go ahead and be more precise here. At the end of my string, let me go ahead and say this set of symbols in square brackets. I'm going to go ahead and say A through Z, 0 through 9, and an underscore, because again, those are the only valid symbols. I don't need to bother with an uppercase A or a lowercase z because we're using re.ignore case over here. But I want to make sure now that I tolerate not only one or more of these symbols here, but also maybe some other stuff at the end of the URL. I'm now going to be OK with there being a slash or a question mark or a hash at the end of the URL, all of which are valid symbols in a URL, but I know from the Twitter's documentation are not part of the username. All right, now I'm going to go ahead and run Python of twitter.py one final time, typing in https://twitter.com/DavidJMalin. Maybe with, maybe without a trailing slash, but hopefully with my biggest fingers crossed here, I'm going to go ahead now and hit enter. And thankfully, my username is indeed David J. Malin. So what more is there in the world of regular expressions and this own library? Not just re.search and also re.sub. There's other functions too. There's re.split, via which you can split a string, not using a specific character or characters like a comma and a space, but multiple characters as well. And there's even functions like re.findAll, which can allow you to search for multiple copies of the same pattern in different places in a string so that you can perhaps manipulate more than just one. So at the end of the day now, you've really learned a whole other language, like that of regular expressions. And we've used them in Python. But these regular expressions actually exist in so many languages too, among them JavaScript and Java and Ruby and more. So with this new language, even though it's admittedly cryptic when you use it for the first time, you have this newfound ability to express these patterns that, again, you can use to validate data, to clean up data, or even extract data and from any data set you might have in mind. That's it for this week. We will see you next time. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and this is our week on Object-Oriented Programming, or OOP. It turns out that in the world of programming, there's different paradigms of programming languages. There's different ways of solving problems with code, and it's a little hard to see this at first if you've only learned one language, but over time, if and when you learn other languages besides Python, you'll start to notice certain patterns and certain capabilities of some languages, but not another. Thus far, within the world of Python, you and I have largely been writing code that's procedural in nature, whereby we're writing procedures, we're writing functions, and we're sort of doing things top to bottom. Everything is step by step by step, as you would expect in general from an algorithm. But along the way, we've actually dabbled in another paradigm known as functional programming with Python, whereby we've been able to pass functions around. We even had an anonymous function some weeks ago, and that's evidence of features of a functional programming language, even though we've just scratched the surface thereof. Today, we focus on another paradigm, and this one in more detail, namely object-oriented programming. And now, while some of you might have prior programming experience and have learned languages like Java, which are by design fundamentally object-oriented, Python indeed allows you a bit of flexibility when it comes to how you solve problems with code. But it turns out OOP, object-oriented programming, is a pretty compelling solution to problems that you invariably encounter as your programs get longer, larger, and more complicated. So indeed, OOP for our purposes is going to be a solution to a problem that builds on so many of the lessons past. So let's go ahead and do this. Let's start by writing a program very procedurally by opening up VS Code here. I'm going to go ahead and create a program called student.py. And in this program, I want to do something relatively simple initially. As we might have done some weeks ago now, where I just ask a user for their name and maybe in the context of the Harry Potter universe, their house, and just print out where that student is from. And let's gradually enhance this program by adding more and more features to it and see if we don't stumble upon problems that up until now we might not have had very elegant, well-designed solutions to. But if we introduce explicitly object-oriented programming as a programming technique, I bet we can clean up our code and set the stage for writing even more sophisticated programs, longer programs down the line. So in student.py, let me go ahead and do a name variable, setting it equal to the return value of input, and just prompt the user for their name like this. And then let me go ahead and do the same for a house variable and prompt the user for their house using input like this. And let's do something super simple now. Let's just go ahead and print out an f string that says something like name from house, just so that I can confirm that the contents of these variables are indeed as I expect. I'm not going to do any error checking or trimming or anything like that for now. I'm really just going to spit back out whatever the user just typed in. All right, let me go ahead and run Python of student.py. Let's use our go-to, like Harry, as in Harry Potter, from Gryffindor. And when I hit enter now, let's see if I see that Harry from Gryffindor is indeed the case. All right, so I think we have a working program at this point. But let's now introduce some of those lessons learned way back from week 0, where we started writing our own functions. Not necessarily because it solves the problem more correctly. I dare say this is correct as is, but it begins to give us building blocks that we can extend so as to solve more complicated programs. So let me go back up to student.py. And let's go ahead now and do this. Let's put the entire logic I just wrote inside of our typical method called main. And let me indent those 3 lines so that at least they're now combined into one main method. But instead of using input on line 2 and input on line 3, why don't we go ahead and assume for the moment that we've got some function called getName in the world. And let's go ahead and assume we've got another function like getHouse in the world that don't take parameters, but their purpose in life is, by their name, going to be to get the user's name and to get their user's house respectively. And then I'm going to print out the exact same f string as before. I, of course, need to implement these functions now. So let me go lower in my file and define a function called get_name. Nothing in these parentheses because it's not going to take a parameter. And I'm going to go ahead and do something like name equals input, quote unquote, name, just like before. And then I'm going to go ahead and return name. So it's a super simple function, but it's an abstraction. I now have a function called getName whose implementation details I don't have to care about anymore. I just know that the function exists. And I can tighten this up, in fact. I don't really need a name variable on line 8 if I'm immediately going to return that same name variable on line 9. So let me just tighten this up a little bit, even though it doesn't change the functionality, and just immediately return the return value of the inputs function call here. Let's do something very similar now for getHouse, which will similarly take no arguments. I'm going to go ahead and return the return value of input, this time prompting the user for their house. And I need one final detail at the very bottom. Let's continue our habit of doing if the name of this file equals quote unquote main, then let's go ahead and actually call main. And recall that we have that in place so that if this eventually becomes part of a module, a library of sorts, I don't accidentally call main blindly. I only do it if I mean to run main from the command line on this file. All right, so if I didn't make any mistakes here, let me go ahead and in my terminal window again run Python of student.py, enter. Let's type in Harry, enter. Let's type in Gryffindor, enter. And we're set. Harry from Gryffindor seems to still be working. So we haven't really solved the problem any more correctly, but I've laid the foundation to maybe now do some more interesting things because I've had these building blocks in place. All right, but let me propose that we could be doing this a little bit differently. GetName, getHouse is fine, but at the end of the day, I'm really trying to get a student from the user. I want their name and their house, not just one or the other. So maybe it would be a little cleaner still to define a function called getStudent and let getStudent do all of this work for us. Now, theoretically, getStudent could call getName and could call getHouse. But because these functions are so short, I think I'm OK with just defining one function called getStudent that similarly won't take any arguments. But it's going to do two things. It's going to get the student's name by prompting them with input as before. And it's going to get the student's house by also prompting them as before. And then, now, I want to return the student, but I think I might have painted myself into a corner here because I now have two variables, name and house. And yet up until now, we've pretty much returned one or the other. We've returned one value. So any suggestions for how we can perhaps solve this problem that I just created for myself, whereby I want to return really a student, but I currently have a name variable and a house variable? I'd minimally like to return both of those.
I believe that we can return a dictionary, include the name and the house.
Yeah, so we absolutely could return a dictionary, a dict object in Python, whereby maybe one key is name, one key is house, and the values thereof are exactly the values of these variables. So we could totally do that. I worry that that might be getting a little complicated. I wonder if there's a simpler way instead. Any other instincts, even if you're not sure it would work?
Return both name and house.
Return both name and house. I like the sound of that. It sounds simple. I don't have to figure out what a dictionary is going to look like. And in fact, this too would be a valid approach, even if you've not seen this before. It turns out in Python that you can kind of return multiple values, but that's a bit of a white lie. Or we could take Mohammed's approach of actually returning a dictionary and putting multiple keys therein. So here again, we have yet another example of how you can solve the same problem in at least two ways. And I dare say we're about to see even more. So one way you could solve this problem, whereby you want to return multiple values, would be to do something like this. I could go ahead and literally return not just name, but I could put a comma and also return house. This is not necessarily something you can do in other languages if you have programmed in other languages before. It depends on the language. But it looks like, thanks to this comma, maybe I can, in fact, return two values as actually proposed. Well, if I'm returning two values in this way on line 10, how do I get both values at the same time? Well, there's a couple of ways. Let me go up to my main function. I know minimally I'm going to have to change the getName and getHouse to getStudent. But what am I going to store the return value in? I think I could actually do this. And we have seen this technique before, where you can unpack, so to speak, sequences of values that are coming back. And indeed, consider this to be exactly that. Name, comma, house is some kind of sequence that I'm returning of values. Name, comma, house. So if I want to unpack those and store the return values in two separate variables, I can, in fact, use the commas on the left-hand side of my assignment operator, the equal sign, to do just that. Now, to be clear, I don't need to call these variables name and house here. I could simplify this and use just n here and h here, and then I could return just n and h. But I would argue that's not very clear to the reader as to what's going on. So I think in this case, even though it's a coincidence that I've used the same variable names in getStudent and getMain, and in main, it's a little more readable to someone like me. So I'm going to leave it as is. Well, let's go ahead and see now if this works. Let me clear my screen down here and run Python of student.py, enter. Let's again type in Harry. Let's again type in Gryffindor, enter. And voila, we still see that Harry is from Gryffindor. But what are we actually doing here? What are we actually doing by returning this value? Well, it turns out that what we've just done is used a tuple. A tuple is another type of data in Python that's a collection of values, x comma y or x comma y comma z. It's similar in spirit to a list in that sense, but it's immutable. It's not mutable. Now, what does that mean? A list, as we've seen it before, is a data structure in Python that you can change the values of. You can go into bracket 0 for the first location and change the value there. You can go to bracket 1, bracket 2, bracket 3, and actually change the values in lists. But if you have no intention of changing the values of variables and you want to return effectively multiple values, you don't have to even return it as a list. You can return it as a tuple instead, just by using a comma. And it turns out we can make explicit that here's the white lie. I'm not actually returning two values per se. Whenever you use a comma in this way on line 9, you're actually returning one value, which is a tuple. Inside of that tuple now are two values. So it's similar in spirit to returning one list with two things. Here I'm returning one tuple with two things. And the mere fact that I've used a comma and nothing else tells Python that I indeed want to return a tuple. But there's more explicit syntax that we can use instead. I can actually more verbosely put explicit parentheses around the values of this tuple just to make more clear to me, to the reader, that this isn't two values per se. This is one value with two things inside of it. And what I can actually do then, too, is I don't have to unpack this up here, so to speak. I can actually go up here and maybe give a more apt name like student. And I can name the value, or rather name the variable in which I'm storing the return value of getStudent as, quote unquote, student. So maybe this is a little better design now because I'm sort of abstracting away what a student is. It's implemented at the moment as a tuple with two values, but at least now I have a variable called what I mean, a student. But there's going to be a catch. On line 3, I still want to print out that student's name and their house, but I don't have a name variable anymore, and I don't have a house, and I also don't have a dictionary, as was proposed earlier, so I can't even go at those keys by name. But what a tuple is, it's very similar in spirit to a list, but it is indeed just immutable. And what I mean by that is I can still index into it numerically by saying student square bracket 0 for the item in the first location in that tuple. And then over here, instead of house, I can say student bracket 1. Student bracket 1 is going to give me the second location in that tuple. Let me go ahead and clear my terminal window. Again, run python of student.py. Let's type in Harry. Let's type in Gryffindor. Enter. And we still have some working code. Let me pause here now and see if there are any questions on this technique of returning a tuple and indexing into it in this way.
I guess what's a actual use case where you would use a tuple versus, a list or something else that's similar?
It's a really good question. When would you use a tuple versus a list? When you want to program defensively, or in general when you know that the values in this variable shouldn't change. So why would you use a data type that allows them to be changed? It just invites mistakes, bugs down the line, either by you or colleagues who are interacting with your code. So tuple is just another way where you can increase the probability of correctness by just not letting anyone, yourself included, change the contents therein. So it's just another tool in your toolkit. But let's make clear then what I mean by immutable. Again, I claim that immutable means that you cannot change the value. Well, let's go ahead and try to do this. Let me go ahead and run this program once more as is, python of student.py. Let me go ahead and type in, for instance, how about Padma's name. And I'm going to go ahead and say that Padma's in Gryffindor, as in the movies. And we see Padma from Gryffindor. But technically, I went down this rabbit hole and looking at Harry Potter more closely. Technically, in the books, Padma, I believe, was from Ravenclaw. So this is actually a mistake or an inconsistency between the movies and the books. Let's see if we can't fix this inconsistency in our code. So how about we do this? If the student's name that's inputted equals Padma, why don't we override whatever the house is and change it to be properly Gryffindor? Let me go ahead and do if student. Now, if I want to get at Padma's name, I'm going to have to do student bracket 0. I have to know what location the name is in this tuple. But if that value equals Padma, let's go ahead with this if statement and make a change. Let's change the student's bracket 1 value. So the second value, if we're 0 indexing, let's change it to be another house in the world of Harry Potter called Ravenclaw. So I'm just fixing maybe the user's input. They watch the movie, so they type in Padma Gryffindor, but in the books, it was Padma from Ravenclaw. All right, let me go ahead and go down to my terminal window, clear my terminal, and do python of student.py, enter. I'm going to do Harry as well as Gryffindor just to demonstrate that that is still working as intended. Let me clear my screen again, though, and run python of student.py on Padma, and I'll put her too in Gryffindor as in the movies and hit enter. And now I just see a big mess of errors on the screen. Some kind of exception has been thrown, and indeed, a type error has happened. I'm using a data type wherein there's an error. And what is that error? Well, tuple object does not support item assignment. It's a little arcanely expressed. That is, that's not really very user-friendly. But if you think about what those words mean, tuple object does not support item assignment. So assignment is copying from right to left. So somehow that's invalid. And here is a manifestation of the immutability of tuples. You cannot change location 0 or 1 or anything inside. That is a feature. That is the design of a tuple. So if I want to override that, I think I'm going to have to use a different type of data that we've used before, namely a list. And that's fine. If you want to enable yourself and colleagues using your code to change the contents of that container, well, we can go ahead and return not a tuple using explicit parentheses or no parentheses, just the comma, but I can use square brackets. And if I'm using square brackets on the left and the right, this is indeed explicitly a list. Same idea, but it's mutable. That is to say, you can change the contents of a list. So making no other changes, just returning a list with square brackets instead of a tuple with parentheses or just the comma. Let me go ahead now and run Python of student.py, enter. Let me type in Harry and Gryffindor again. That's still working. Good to see. Let me run this once more and type in Padma and Gryffindor, as in the movies. But no, now we've corrected it to be Padma from Ravenclaw, as in the books instead. Any questions now on tuples versus lists, or this idea of immutability versus mutability?
Can we use a nested tuple in Python, like a nested list?
Absolutely. You can have not only nested lists in Python, where one of the elements in a list could be another list. So you have some square brackets out here. You might have some other square brackets inside. You can absolutely do the same with a tuple as well. There's no constraint on the types of values you can put in there. We've not had occasion to do that in this case. I'm just returning a simple tuple with two elements. But yes, you could absolutely do that too. Other questions on tuples versus lists?
Okay, for example, when I say the square bracket, is it mainly used for the list?
Oh, a really good question. Sort of. So when you create a value, like a list, you use square brackets, and that would indeed be a visual indicator that this is definitely a list. If you instead see parentheses, that's a visual indicator when creating a value that it's definitely a tuple. However, somewhat confusingly, both lists and tuples use square brackets when you access the contents of them. When you index into them at location 0 or location 1, you always use square brackets. So that's the distinction there. Good question. Allow me to propose now, if I may, that we solve this problem yet another way, and let's see if we're either making things better or for worse than us. Recall that dictionaries, or dict objects, also exist in Python, and a dictionary is this collection of keys and values. And the upside in particular of a dictionary is that they have better semantics, right? You don't just have to assume that a name is always going to be at location 0. House is always going to be at location 1. I mean, that's the kind of thing, especially if you had 3, 4, or more values, eventually you or someone is going to get confused and forget what the order is, and you're going to write buggy code. So a dictionary is a little more powerful in that you can semantically associate keys, like little descriptions with the values, those keys and those values respectively. So let me go ahead and do this. And we can do this in a few different ways, but let me propose that we focus on getStudent here. And let's go ahead and do this. Let me go ahead and delete the implementation of getStudent as is. Let me create a student variable and initialize it to an empty dictionary. And I can do that with just 2 curly braces here. And then let me go ahead and set 2 keys inside of that dictionary. Inside of the student, there will be, quote unquote, a name key. And the value of that is going to be whatever the return value of input is when I prompt the user for their name. And then the house key inside of that same student dictionary is going to be the return value of whatever the user types in for their house. And lastly, I'm going to go ahead and return student. So now I am literally returning one thing still, but this time it's a dict rather than a tuple, rather than a list. But there's still 2 things in it, technically 4 things if you count the keys and the values, but there's 2 key value pairs. Now my code up here is going to have to change a little bit. And let's simplify this and remove, for instance, now the Padma if statement, just to focus on what's changing at hand. And let me go ahead now and leave line 2 alone. I'm still going to have a student variable that gets assigned the return value of getStudent. But what I want to do here now is actually access the keys inside of that dictionary, not by numeric index, which was for tuples and lists, 0 and 1, but by way of their keys. Now, normally, I might be in the habit, as I personally am, of using double quotes, quote unquote name inside of there, and quote unquote house inside of there. But before I even run this code and show you a mistake, see an error on the screen, does anyone want to call out what I have done wrong here? This is just an F string. I just want to print out the value of the name key, the value of the house key in this dictionary. But your audio is a little garbled for us, but I think I heard double quotes and single quotes. So I'm going to assume that indeed you've identified precisely the issue. I'm just going to confuse Python right now. Even though this is an F string inside of double quotes prefixed with an F, I can't actually use my double quotes inside my double quotes because that's going to potentially confuse Python. Indeed, if I run this program now, Python of student.py, and hit enter, I get a syntax error. So the program didn't even run fully. It just couldn't be understood because it got confused by those double quotes. So the simplest fix here would indeed just be to use not double quotes, but single quotes around the keys. Or conversely, flip the double quotes on the outside to single quotes, then use double quotes on the inside. You just want to be consistent. So a subtle detail, but again, this is now specific to dictionary syntax. This isn't fundamental to how we're solving this current problem at hand. All right, well, let's go ahead and try this. Let me go ahead now and run Python of student.py. Let's go ahead and type in Harry. Let's type in Gryffindor. And hopefully, Harry is back from Gryffindor. No syntax errors, no other errors. I think I'm back in business here. And what I do like to be clear about using a dictionary is that it is allowing me just better semantics. Again, I don't have to remember, memorize, document that 0 is name, 1 is house. Instead, name is name and house is house. It's just a little clearer, a little more expressive. So that's generally a good thing, especially if we stored more data about students than just their name and their house. If you had 3 fields, 4, 5, 10 different fields, no one's going to want to remember or be able to remember forever which is 0, which is 1, which is 2, and so forth. Better to introduce names like name and house in this case. But let me tighten this up further. Indeed, I'm typically in the habit of not introducing variables unnecessarily unless they make the code more readable. And an alternative way to format the same code would be this. Strictly speaking, I don't need to create an empty dictionary, then add one key to it, then add a second key to it, and then return that dictionary. I can actually consolidate this all into one statement, if you will. Let me go ahead and do this. Let me go ahead and say name equals inputs return value, house equals inputs return value, and then instead of returning any variable named student, which I'm going to propose doesn't need to exist anymore, let me just create and return the dictionary all at once. Let me do quote unquote name in lowercase here, and then the variable, it's storing the user's name, then quote unquote house as my second key, the value of which is going to be house, the variable. Now, is this better? Maybe, maybe not. Maybe the first way was a little more readable, and that's totally fine to create variables if they improve the readability of your code. But just know that you can also create and return a dictionary on the fly like this, so to speak, all in one line. And I think it's arguably pretty reasonable in this case. Why? It's just pretty short. I probably wouldn't do this if it got longer and longer and longer. I might minimally then start moving my key value pairs to separate lines. But this would just be a slightly more compact way of doing this as well. But let me propose we do one more change. Let's go ahead and introduce that same special casing of Padma to fix her house. From Gryffindor, for instance, to Ravenclaw. How do we do this with dictionaries? Well, dictionaries, like lists, are mutable. You can change what is in them just like you can lists. How do you do that? It's just a little different syntactically. So let's go back into main and do this fix. If the student variable has a name key that equals Padma, then, indented, go ahead and change the value of the house key inside of that student dictionary to be, quote unquote, Ravenclaw instead. So very similar in spirit to what we did with a list, but instead of using location 0 and 1, we're much more clearly, explicitly, semantically using quote unquote name and quote unquote house. Because you index into lists and tuples using numbers, but you index into dictionaries using strings, as I've done here. All right, let me go ahead and run Python of student.py. We'll again do Harry from Gryffindor, and I think all is well. Let me run it one more time, this time with Padma, who in the movies is from Gryffindor, but should really be from Ravenclaw. All right, any questions then on this progression from tuples to lists to dictionaries? We haven't necessarily introduced anything new other than those tuples, which have been available to us all this time, but the goal at the moment is just to demonstrate this distinction among these different data types and how they each work a little bit differently.
What if a combination of lists is there in a tuple? So is the list, like we can change the list because tuple are immutable, but lists are mutable.
Correct. You can change the contents of lists, and you can put most anything you want in them, other lists or strings, as I've done, integers or anything else. Tuples, you can do the exact same thing, but you cannot change them once you've created them. A dictionary is more like a list in that it is mutable. You can change it, but the way you index into a dictionary is by way of these keys, these strings, as we keep seeing, rather than by numbers, those numeric indices. All right, well, let me propose that there is yet another way of solving this problem. And indeed, I would argue that there's now an opportunity at hand. Even though this program isn't particularly complicated, all I'm doing is collecting a name from the user and a house from the user. You could imagine wanting longer term to collect even more information, like the student's patronus or magical spell or a whole bunch of other information that might belong in a student. And right now, we're just kind of using these very general purpose data types in Python. A tuple to combine some values together, a list to do the same, but let us change it later, a dictionary, which is more powerful because it's a little more structured. It does have keys and it has values, not just values. But you know what? We wouldn't have to be having this conversation if the authors of Python had just given us a data type called student. Right? Wouldn't it have been nice if there were just a type of variable I could create in my code called student? Then we wouldn't have to figure out, well, do we use a tuple or a list or a dictionary? But that's pretty reasonable, right? You could imagine just how slippery of a slope that is, so to speak, if the creators of a language had to anticipate all the possible types of data that programmers like you and me want to store in your programs. So they just gave us these general purpose tools. But they gave us another general purpose tool that's going to allow us to create our own data types as well and actually give them names. And that terminology is a class. A class is kind of like a blueprint for pieces of data, objects, so to speak. A class is kind of like a mold that you can define and give a name. And when you use that mold or you use that blueprint, you get types of data that are designed exactly as you want. So in short, classes allow you to invent your own data types in Python and give them a name. And this is a primary feature of object-oriented programming, to be able to create your own objects in this way. And in the case of Python and classes, even give them some custom names. So what does this mean in real terms? Well, let me go ahead and come back to VS Code here. And let me propose that we introduce a little bit of new syntax. I'm going to go ahead and clear my terminal window first. I'm going to go to the top of my file, and I'm just going to start a thought but not finish it yet. I'm going to use this new keyword for classes called literally class. So indeed, the new keyword we're going to have here, and if I go back to our slides here, this would be the official URL where you can read up more on this particular feature of Python in the official tutorial. Class is a new keyword we can use. Now, this is coincidentally related to students, because students take classes, but it has nothing to do with the fact that we're dealing with students. Class is a general purpose term in a lot of languages, Python among them, that allow you to define these custom containers with custom names for pieces of data. So let's go back to VS Code. Let's use this new keyword. And let me propose that we create a class called student. And by convention, I'm going to use a capital S here. And I'm going to go ahead and, with a colon, get to later the implementation of this class. So I'm just going to use ... which is a valid placeholder for now. That just indicates to me that I'm going to come back to implementing this later. But as of now, it does, in fact, exist. I now have a student class defined for me that I can now use in my code here. How am I going to use it? Well, first of all, let me go down to get student, and let me change this code to no longer use a dictionary, but to use this class. I'm going to do this. I'm going to give myself a variable called student, as I've done before, but I'm going to set it equal to capital student, open parenthesis, close parenthesis. So I'm going to do what appears to be calling a function, and that function, student with a capital S, notice, matches the name that I gave this class at the top of my file. All right, what do I next want to do? I'm going to go ahead and give this student a name. Now, if I were still using a dictionary, I would say student, quote unquote, name using square brackets. But this is not a dictionary. It turns out classes have what for now we'll call attributes, properties of sorts that allow you to specify values inside of them. And the syntax for that happens to be a dot. We've seen dots before. We've used it in the context of modules and libraries more generally. This is another similar in spirit use of a dot that allows you to get at something inside of something else. So student.name is going to be the syntax I use for giving this student a name. And that name is going to be whatever the return value of name is. And then I'm going to go ahead and say student.house to give another attribute called house and give that the return value of input here, prompting the user for house. And then as before, I'm just going to return student. But now what's really powerful about class and object-oriented programming more generally is that I've created this custom data type called literally student, capital S. I've stored one such student in a variable like I can always do in a variable called student, lowercase s, but I could call it anything I want. It just makes sense to call it student as well, but lowercase for clarity. And then I'm returning that variable. And because of my syntax in lines 14 and 15, that has the result of putting inside of that class a name attribute and a house attribute. I just need to make one more change up here. I'm going to go ahead and remove our Padma code just so we can focus only on what's new rather than fixing her house. And I'm going to go in here and change the syntax that previously was for dictionaries. Again, dictionaries use square brackets and then strings in quotes, either single quotes or double quotes, depending on the context. Here, though, I'm going to change this to be student.name. And over here, I'm going to change it to be student.house. And that's just going to be my new syntax for getting the contents of what appears to be a class called student. Let me go ahead and rerun Python of student.py, enter. Let's type in Harry's name as before. Let's put him in Gryffindor, crossing our fingers as we often do. And Harry is indeed from Gryffindor. What, though, have I done? Let's introduce one other bit of terminology here. It turns out that I can create a class using that class keyword. But anytime you use a class, you're creating what are called objects. And here is the word objects as in object-oriented programming, or OOP. Let me go back to my code here. And even though I haven't really implemented much of it at all, I literally just left it with a ... That's enough code, lines 1 and 2, to just invent a new data type called student, capital S, that may or may not have some future functionality as well. That's enough to create a class. What, though, am I doing on line 11? On line 11, what I'm technically doing is creating an object of that class. So this, too, is another term of art. You create objects from classes. So if we go back to that metaphor that a class is like a blueprint for a house, or a class is like a mold, an object is when you use that blueprint to build a specific house, or something that comes out of in plaster, the mold, when you actually use that mold to create such an object. So a class is, again, the definition of a new data type. The object is the incarnation of, or technically instantiation of. And another term for objects would actually be an instance. You have instances of classes as well. So that's a lot of vocabulary, but at the end of the day, it just boils down to this. You can define your own class, which is really your own data type. You can then store attributes inside of it using this dot notation here, and then you can access those same attributes using code like this here. And now I have a proper student data type, and I don't have to kind of hack something together using a tuple or a list or even a dictionary. I now have a proper data type called student that the authors of Python didn't give me, I gave myself. Any questions now on classes, this new keyword class, or this idea of these objects or instances thereof?
Is the class object mutable or immutable?
A good question, and we've clearly laid the stage for having that conversation about every data type now. We will see that they are mutable, but you can make them immutable. So you can get the best of both worlds now by writing some actual code. And we'll write more code than the ... in just a bit. Other questions on classes or these objects thereof?
Then what would be the properties of those classes?
So at the moment, the properties of, or the attributes of, as I've been calling them thus far, would just be name and house. it turns out that there may very well be other attributes built into classes that we may see before long. But for now, the only two attributes that I care about are the ones that I myself created, namely name and house are, again, what I would call attributes. And in a little bit, we're going to start calling those same attributes more technically instance variables. Name and house, as I presented them here in VS Code, are really just variables called name and called house inside of an object whose type is student. All right, so what more can we do with these classes? Well, again, on line 11 is where we're instantiating an object of the student class and assigning it to a student variable. We're then adding attributes name and house respectively on lines 12 and 13 currently. Both of those have values that are technically strings or strs, because that's what the return value of input is. But those attributes values could actually be any data type. We're just keeping things simple and focusing on defining students in terms of two strings, name and house. And then on line 14, we're returning that variable. We're returning that object to main so that we can actually print out who is from what house. Well, let's go ahead and add a bit more functionality here, because right now on lines 12 and 13, this is a little manual. And it's a little reckless of me to just be putting anything I want inside of this student object. It turns out with classes, unlike with dictionaries, we can actually standardize all the more what those attributes can be and what kinds of values you can set them to. So let me go ahead and do this. Let me propose that it would actually be really nice if instead of doing this here, let me go ahead and simplify my code as follows. Let me go ahead and give myself a local variable called name and set it equal to the return value of input, like we've done many times now already. Let me give myself one other variable for now called house and set it equal to the return value of input as well, prompting the user for their house. And now, instead of creating a student object from my student class and then manually putting the name attribute inside of it and the house attribute inside of it, let me actually do something more powerful. Let me do this. Let me call that student function, which is identical to the class name. Just by defining a class, you get a function whose name is identical to the class name with the capital letter included. But instead of just doing open parenthesis, close parenthesis, let me pass in the name that I want to fill this object with and the house that I want to put in that object as well. And now let me set the return value as before to be student equals like this. So what have I done that's different? Fundamentally, I'm still getting user input in the same way. I'm using input on line 11 and input on line 12, and I just so happen to be storing those return values in local variables. But now we're setting the stage for the more powerful features of classes and object-oriented programming more generally. Notice that I'm deliberately passing to this capital S student function name, comma, house. I'm passing in arguments to the function. Now, the student class is not going to know what to do with those yet, but now I'm sort of standardizing how I'm passing data into this student class. And ultimately, it's going to give me an opportunity to error check those inputs to make sure that the name is valid, that it has a value, and it's not just the user hitting enter. It's going to allow me to ensure that it's a valid house, that it's Gryffindor or Hufflepuff or Ravenclaw or Slytherin, or not just hitting enter or some random value that the user types in. Because I'm passing name and house to the student class, this particular function, I'm going to have more control over the correctness of my data. So let's now go up to the student class, which up until now I left as just ... It turns out that in the context of classes, there are a number of not just attributes or instance variables that you can put inside, but also methods. Classes come with certain methods or functions inside of them that you can define, and they just behave in a special way by nature of how Python works. These functions allow you to determine behavior in a standard way. They are indeed special methods in that sense. Now, what do I mean by this? Well, let me go back to VS Code here, and let me propose that I start to define a standard function called underscore underscore, or dunder as it's abbreviated, init underscore underscore. And then I'm going to go ahead and do open parenthesis. And then I'm going to put in here literally the word self. More on that in just a moment. But now inside of this function, I'm going to have an opportunity to customize this class's objects. That is to say, this underscore underscore init method, or dunder init method, is specifically known as an instance method, and it's called exactly this. This is designed by the authors of Python, and if you want to initialize the contents of an object from a class, you define this method, and we'll see what it's about to do here. Let me go back to VS Code, and let me do something like this. Self.name equals name, and self.house equals house, but I don't want to just init this object very generically. I want this method called init to take in not just self, but name, comma, house as well. Now, what in the world is going on? Because there's a lot of weird syntax here. There's this dunder init method, double underscore, init, double underscore. There's all of a sudden this parameter called self, and then there's this new syntax, self.name and self.house. Now you're seeing really a manifestation of object-oriented programming. It's not all that different fundamentally from what we've been doing for weeks with dictionaries by adding keys to dictionaries. But in this case, we're adding variables to objects, aka instance variables to objects. Now, what's going on? Let's do this in reverse. Let's go back to the line of code we wrote earlier. On line 15, I am treating the name of this class, student with a capital S, as a function. And I am passing in two values, name and house. What I've highlighted here on the screen on line 15 is generally known as a constructor call. This is a line of code that is going to construct a student object for me. Using synonyms, it is going to instantiate a student object for me. And again, how is it going to create that object? It's going to use the student class as a template, as a mold of sorts, so that every student is structured the same. Every student is going to have a name. Every student's going to have a house. But because I can pass in arguments to this student function, capital S, I'm going to be able to customize the contents of that object. So if you think about the real world, if you've ever been on a street or a neighborhood where all of the houses kind of look the same, but they might be painted differently, they might be decorated a little bit differently on the outside, all of those houses might have been built using the exact same blueprint, sort of a mold, if you will, but then you can specialize exactly the finer points of those houses by painting the outside a different color or planting different trees. You can style them differently. Similar in spirit here. We have a student blueprint that's always going to have now a name and a house, but it's up to you and me to pass in any name and any house that we want. Now, where is this function? The fact that I'm calling student, capital S, and then a parenthesis and a closed parenthesis with arguments inside suggests that there's a function somewhere in the world that has been defined with def that's going to be called. Well, as you might have guessed by now, the function that will always be called by definition of how Python classes work is a function called double underscore init double underscore. Why? It's a crazy name, but it's what the authors of Python chose to just implement the initialization of an object in Python. Now, the only weird thing, especially weird thing, I will admit, is this. It would be way clearer to me, too, if the only two parameters for init were just name, comma, house, right? That's how we've defined every function thus far in the class. You just specify the parameters that you want the function to accept. And indeed, that lines up with what I'm doing on line 15. I am only passing in two things to the student function. But it turns out that the authors of Python need to give us a little bit of help here. Because suppose that you pass in name and house to this init method, and a method is just a function inside of a class. What are you going to do with the name and the house? Like literally, where are you going to put them? If you want to remember the name and the house for this student, you've got to be able to store those values somewhere. And how do you store them in the current object that has just been instantiated? Well, the authors of Python decided that the convention is going to be that this init method also semi-secretly takes a third argument that has to come first. By convention, it's called self, but you could call it technically anything you want. But the convention is to always call it self. And self, as its name implies, gives you access to the current object that was just created. What does that mean? Again, now on line 14, now that it's moved down a little bit, This line here is a constructor. It constructs a student object, but there's nothing in that object initially. There's no name, there's no house, but the object exists in the computer's memory. It's up to now you to store the name and the house inside of that object. How do you do that? Well, Python will just automatically call this init method for you, and it's going to automatically pass in a reference to an argument that represents the current object that it just constructed in memory for you, and it's up to you to populate it with values. And what this means is that inside of your init method, you can literally do self.name to create a new attribute, aka an instance variable, inside of that otherwise empty object and put this name inside of it. It allows you to do self.house and store that value of house. Now, you could call these things anything you want. They could be n, they could be h as before, but that's really not very self-explanatory. Much better to do this kind of convention, self.name equals name, self.house equals house. And this is like installing into the otherwise empty object the value name and house, and storing them in really identically named instance variables in the object. And again, an object is just an instance of a class. Now, I know that was a lot of vocabulary. That's a lot of weird syntax. So any questions on this init method, whose purpose in life, again, is to initialize an otherwise empty object when you first create it?
So what is the difference between the init method and default constructor?
A good question. So in other languages, if you programmed before, for instance, Java, there are functions that are explicitly called constructors that indeed construct an object. They initialize it with values. Python technically calls this init method the initialization method. It initializes the value. It's on line 15 now of my code. If I scroll back down, that I'm technically constructing the object. It turns out there's another special method in Python that we won't talk about in detail today called underscore underscore new underscore underscore that actually handles the process of creating an empty object in memory for us. But generally speaking, you, the programmer, don't need to manipulate the new function. It just works for you. Instead, you define your own init method here, an init function inside of your class, and that method initializes the contents of the object. So there's technically a distinction between constructing the object with new and initializing it with init. But in the world of Python, you pretty much only worry about the init method. Python generally does the other part for you. A good question. Others?
What about if you want to store more than one name or more than one house?
A good question. If you want to store more than one name or more than one house, you can do this in different ways. You could create other attributes, technically called instance variables, like self.name1, self.name2. But we've seen in the past that that is not a very good design, just to have multiple variables to store multiple things. Maybe instead you have an instance variable called self.names, plural, and you set it equal to a list of names or a list of houses. Now, in this case, I don't think that really solves the problem because I'm trying to implement a student, singular, so it doesn't really make sense to have multiple first names, maybe a nickname, maybe a last name, so we could add those too. But I don't think we need multiple names per se, and in this case, multiple houses. But absolutely, you could do that using some of our familiar building blocks like lists. Other questions?
How are classes or objects represented in memory?
How are classes and objects represented in memory? So the class is technically just code. It is the code on the top of my file, lines 1 through 4, that defines that blueprint, that template, if you will. Objects are stored in the computer's memory by taking up some number of bytes. So you're probably familiar with bytes or kilobytes or megabytes. There's some chunk of bytes, probably all in the same location in the computer's memory or RAM, where those objects are stored. But that's what Python, the program, handles for you. Python, the interpreter, figures out where in the computer's memory to put it. You and I, the programmers, get to think and solve problems at this level. Python, the interpreter, handles those lower level details for you. How about one final question on classes and objects?
Now, my question is, if we can do the same thing with the dictionary, so why to use classes?
Good question. If you can do the same things as you can with dictionaries, why should you use classes? Because we are just scratching the surface now of what you can do with classes. Allow me to go back now to my keyboard and show you more of what you can do with classes. But in short, you can do much more with classes. You can ensure the correctness of your data much more with classes. You can error check things. And generally, you can design more complicated software more effectively. And we'll continue to see today features of Python and object-oriented programming more generally that allows us to do just that. So let me propose, in fact, that first, let's just tighten up this current implementation, which again has us with an init method that just declares two instance variables, self.name and self.house, which again just creates those variables inside of the otherwise empty object and assigns them values, name and house respectively. Let me go ahead and just do one little thing here. I don't really need this student variable. Let me just tighten this up so that each time we improve or change the code, we're focusing really on just the minimal changes alone. So I've not fundamentally done anything different. I just got rid of the variable name, and I'm just returning the return value of this student function that's constructing my new object for me. So I'm just tightening things up as we've done many times in the past. Well, what if something goes wrong when in creating this student? For instance, what if the user does not give us a name and they just hit enter when prompted for name? Like, I don't want to put in my computer's memory a sort of bogus student object that has no name, right? I'd ideally like to check for errors before I even create it so I don't create a nameless student. It would just be weird and probably a bug to have an object that has no name. Similarly, I don't want the user to be able to type in something random as their house. At least in the world of Harry Potter, there's really only 4 houses, at Hogwarts at least. Or there's, again, Gryffindor and Hufflepuff and Ravenclaw and Slytherin, a list of 4 valid houses. It would be nice if I somehow validated that the user's input is indeed in that list. Now, I could do all of that validation in my getStudent function. I could check, is the name empty? If so, don't create the student object. Is the house one of those 4 houses? If not, don't create the student object. But that would be rather decoupled from the student itself, right? GetStudent currently exists as just my own function in my student.py file. But classes, and really object-oriented programming more generally, encourages you to encapsulate inside of a class all functionality related to that class. So if you want to validate that a name exists, if you want to validate that a house is correct, that belongs just fundamentally in the class called student itself, not in some random function that you wrote elsewhere. Again, this is just methodology. Because again, if we think about writing code that gets longer and longer, more and more complicated, it should make just intuitive sense that if you keep all the house and all of the name and all of the house-related code in the student, it's just better organization, right? Keep all of the related code together, and that's probably going to set you up for more success. And indeed, that's part of this methodology of object-oriented programming. Let me go ahead now and change my students classes init method to do this. If the name is blank, so if not name, and we've seen this kind of syntax before. If you say in Python, Pythonically, if not name, that's like doing something like this. If name equals quote unquote, but I can do this a little more elegantly, just say if not name would be the more Pythonic way to do it. Well, I want to return an error. Like I might want to do something like this, print missing name. But this is not good enough. It does not suffice to just print out missing name and then let the rest of the code go through. All right, well, what could I do instead? In the past, we've seen another technique. I could do sys.exit, and I could say something like missing name, and I could go up here and I could import sys. But this is a really obnoxious solution to the problem. Just because you, or maybe a colleague, messed up and called a function with an invalid name, you're going to quit my whole program? Like, that's really, really extreme of a response. And you probably don't want to do that if your program's in the middle of running. You might want to clean some stuff up. You might want to save files. You don't want to just exit a program sometimes in some arbitrary line just because input was invalid. So I don't think we want to do that either. But we do now have a mechanism for signaling errors. Unfortunately, I can't do something like this. I could try returning none and say, this student does not exist. I'm going to hand you back none instead. But it's too late. If we scroll back down to where I'm creating the student, it's on line 17 now where I've highlighted this code. The student has already been created. There is an object somewhere in the computer's memory that's structured as a student. It just doesn't have any values inside of it. But it's too late, therefore, to return none. That ship has sailed. The object exists. You can't just suddenly say, nope, nope, there is no object. There is an object. It's up to you to signal an error. And how do you signal an error? Well, we've actually seen this before, but we haven't had occasion to create our own errors. It turns out in Python, there's another keyword related to exceptions that Python itself uses to raise all of those exceptions we've talked about in the past when you've caught things like value errors or other such exceptions that come with Python. Well, it turns out you, the programmer, can raise, that is, create your own exceptions when something just really goes wrong. Not wrong enough that you want to quit and exit the whole program, but enough that you need to somehow alert the programmer that there has been an error, something exceptional in a very bad way. Something exceptional has happened, and let them try to catch that exception as needed. So let me go back to VS Code here and propose that if the user passes in an invalid name, it's just empty, so there's not a name. Well, what I really want to do is this. I want to raise a value error. And we've seen the value errors before. We've created value errors accidentally before, and generally you and I have tried to catch them if they happen. Well, the flip side of this feature of exceptions in a language like Python is that you, the programmer, can also raise exceptions when something exceptional happens. And you can even be more precise. You don't have to raise a generic value error and let the programmer figure out what went wrong. You can treat value error and all exceptions in Python like functions and actually pass to them an explanatory message like, quote unquote, missing name. So that at least the programmer, when they encounter this error, knows, oh, I messed up. I didn't make sure that the user has a name. And now what do you want to do instead? Well, now if you're the programmer, you could do something like this. You could try to create a student, except if there's a value error, then you could handle it in some way. And I'm going to wave my hand with a ... at how you would handle it. But you would handle it using try and except, just like we have in the past. And that would allow you, the programmer, to try to create the student. But if something goes wrong, OK, I'll handle it nonetheless. So what's new here again is this raise keyword that just lets you and I actually raise our own exceptions to signal these errors. Well, let me go back to my code here. And I'm just going to go ahead and not bother trying or catching this error. For now, we'll just focus on raising it and assume that from our week on exceptions, you could add try and except as needed in places. Let me go back to the code here and propose that something else could go wrong with house. Right? If there is a name, we're good. But if we're given a house but it's invalid, we should probably raise an exception for that too. So what if we do this? If house is not in the list containing Gryffindor, quote unquote, Hufflepuff, quote unquote, let's see, Ravenclaw, quote unquote, or Slytherin, quote unquote, then with my colon, let's raise another type of value error. But rather than raise a generic value error, let's pass in an argument, quote unquote, invalid house. And so here we now see a capability that we can do with classes that we can't with dictionaries. If you add an attribute to a dictionary, a key to a dictionary, it's going in no matter what. Even if the name is empty, even if the house is a completely random string of text that's not one of these four houses, it's going into that dictionary. But with a class, and by way of this init method, you and I can now control exactly what's going to be installed, if you will, inside of this object. You have a little more control now over correctness. And so now let me go ahead and scroll back down to my terminal window and clear it. Let me run Python of student.py. Let me type in something like Harry. Let me type in Gryffindor, enter. And we see that indeed Harry is from Gryffindor. What if I made a mistake, though? What if I ran Python of student.py and typed Harry as the name, but I this time typed in number 4 Privet Drive, which is where he grew up, instead of his proper Hogwarts house? Let me hit enter now, and now you see a value error. But this isn't one that Python generated for us per se. I raised this error, and therefore, if I went in and wrote more code in my getStudent function, I could also catch this error with our usual try except syntax. So all we have now is not just classes in our toolkit, but even more powers when it comes to exceptions, and not just catching them ourselves, but raising them ourselves too. Any questions now on this use of classes and init, and now this ability to raise exceptions when something goes wrong inside of the initialization?
So what if the user has a middle name, middle name, and last name. How would you fix that?
A good question. If you wanted the student to have a first name, middle name, and last name, we could do this in a bunch of different ways. The simplest, though, let me clear my screen here, and let me just temporarily do this. Let me propose that the init method take in a first argument, a middle argument, and a last argument. And then what I think I would do down here is ultimately have first equals first, and then I would do the same thing for middle and last. So middle, and then last and last. And then what I would have to do here is when I actually ask the user for their name, I might need to really go all out. I might need to ask them first for their first name and store that in a variable called first, and therefore pass in first. I might similarly need to ask them for their middle name and store that in a variable, and then pass in a second argument middle. And then lastly, if you will, let me go ahead and create a third variable called last, get the input for their last name, and pass that in as well. I could instead just use one input and just ask them for their whole name. So type in David Malin, enter, or David J. Malin, all three of them. And maybe I could use Python split function, maybe a regular expression to tease it apart. That's probably going to be messy, because there's going to be people who don't have just 2 or 3 names. They might have 4 or 5. So maybe sometimes it's better to have multiple prompts. But that's not a problem, because with a class, we have the expressiveness to take in more arguments if we want. We could even take a list if we wanted. But I think we'd probably want to have even more error checking then, not just for name, but for first, and then maybe for middle, and then maybe for last. So it just is more and more code, though there would be ways to perhaps consolidate that too. Let me undo all of that and see if there are other questions now on classes.
I assume this is classes are something I might do at the beginning of a project. Can I just put them in a different file and import them into my project or my main code as needed?
Absolutely. A really good question. You could imagine wanting to use this student class not just in student.py, but in other files or other projects of yours. And absolutely, you can create your own library of classes by putting the student class in your own module or package, per our discussion in the past about libraries more generally. And absolutely, you can do that. And later today, will we see that we've actually been using classes, you and I, before in third-party libraries. So you, too, can absolutely do the same. How about one more question on classes?
Can you have optional variables in classes? And 2, can you have your own error names? Like, let's be egotistical and say, I want to raise Eric error.
Short answer, yes. So you can, these init functions are just like Python functions more generally, even though they're special in that they're going to get called automatically by Python for you. But if you wanted to make house optional, you could do something like this. You could give it a default value in the init function's signature, so to speak, in that first line of code on line 2, and that would allow me to not have to pass in house. In this case, I'm going to continue to always pass in name and house, but you could make things optional. And yes, to your second question, if you wanted to have your own error message, like an Eric error, you could actually create your own Eric error exception, and we'll see in a little bit that there's actually a whole suite of exceptions that exist, and you too can invent those as well. Let me propose, though, that we now introduce one other aspect of this whereby we try printing out what a student looks like. At the moment, if I scroll back down to my main function, I'm still printing the student's name and house very manually. I'm going inside of the object, doing student.name, and I'm going inside of the object again and getting student.house just to see where the student is from. But wouldn't it be nice if I could just print the student like I've been printing for weeks, any int or float or stir or any other data type? Well, let's see what happens if I just try printing the student instead of manually going inside and trying to create that sentence myself. Well, in my terminal window, let me go ahead and run Python of student.py again. Let me type in Harry. Let me type in Gryffindor. And voila, Harry. Whoa. OK, main student object at 0x102733E80. Well, what is going on? Well, if you were to run the same code, you might actually see something different on your computer in terms of that number. But what you're really seeing is the underlying representation as a string of this specific object. In particular, you're seeing where in the computer's memory it is. This number 0x102733E80 refers to essentially a specific location in the computer's memory or RAM. That's not really that interesting for me or you, or generally speaking, programmers, but it's just the default way of describing via print what this thing is. But I can override this as well. It turns out that there are other special methods in Python when it comes to classes, not just underscore underscore init underscore underscore, but continuing in that same pattern, underscore underscore stir underscore underscore. So this too is a special method that if you define it inside of your class, Python will just automatically call this function for you anytime some other function wants to see your object as a string. Print wants to see your object as a string, but by default, if you don't have this method defined in your class, it's going to print out that very ugly esoteric incarnation thereof where it says main.studentObject at ox ... Well, how can I then define my own stir function? Well, here back in VS Code, let me propose that I go in and define not just underscore underscore init, but let me define a second function in this class here as follows. Def underscore underscore stir underscore underscore. There are indeed two, even though the font in VS Code is putting the two underscores so close, it just looks like a longer underscore. There are indeed two there on the left and the right, just like for init. This one only takes one argument that by convention is always called self, so that you have access to it. And then indented below that, after a colon, I'm going to go ahead and create a format string and return it. So let me go ahead and return, how about something generic first, like a student. So I'm not going to bother even trying to figure out what this student's name or house is. I'm just going to always return a student. Let me go back now to my earlier code, which has print student on line 16. Let me clear my terminal window and rerun Python of student.py, enter, type in Harry, type in Gryffindor. Last time I saw that very cryptic output. This time I see more generically a student. You know, more readable, but not very enlightening. Which student is this? Well, notice that the double underscore stir method takes in this self argument by default. It's just the way the Python authors designed this method. It will always be passed a reference to the current student object. What do I mean by that? When this line of code on line 6 is called, print, because it's hoping it's going to get a string, is going to trigger the underscore underscore stir underscore underscore method to be called. And Python for you automatically is going to pass into that method a reference to the object that's trying to be printed so that you, the programmer, can do something like this. Here's an F string with double quotes as usual. I'm going to use some curly braces and say print out self.name from self.house. So there's nothing new in what I've just done. It's just an F string, an F on the beginning, two double quotes, a couple of pairs of curly braces. But because automatically this stir method gets past self, so to speak, a reference to the current object, I can go inside of that object and grab the name. I can go inside that object again and grab the house. So now when I go back to my terminal window, previously it just printed out a student. But now if I run Python of student.py, enter, type in Harry, type in Gryffindor, and one more time hit enter, Harry is again from Gryffindor. But if I run this yet again, let's for instance do Draco is from Slytherin, enter, Draco's from Slytherin. Now it's customized to the specific object that we're trying to print. Questions on this function here, this dunder stir method?
Is there anything else that the underscore underscore stir method can do? The other question is, what's the difference between stir and repr?
A good question. So there are many other methods that come with Python classes that start with underscore or underscore. We're just scratching the surface, and we'll pretty much focus primarily on these. But yes, there are many others, and we'll see at least one other in just a little bit. There is among the others is indeed one called repr, which is a representation of the Python object. Generally speaking, the underscore underscore repr underscore underscore method is meant for developers' eyes. It typically has more information than Harry from Gryffindor. It would also say what type of object it is, like a student, capital S, whereas underscore underscore stir underscore underscore is generally meant for users, the users of the program, and it's meant to be even more user-friendly. But both of those can be overridden as you see fit. Well, let me propose now that we pick up where we've left off on student and just add even more functionality, but not just these special methods like _init and _stir. Like, let's create our own methods, because therein lies the real power and flexibility of classes if you and I, as the programmers, can invent new functionality that's specific to students. For instance, students at Hogwarts over the time in school learn how to cast a certain type of spell. So when they say expecto patronum, something comes out of their wand that typically resembles an animal or something like that. It's a special spell that they have to practice and practice. So let's see if we can't store not just a student's name and their house, but also their patronus, what actually they conjure when using this spell. Well, let me go ahead and clear my terminal window. And in the top of my code here, in the init method of student, let me go ahead and start expecting a third argument, in addition to self, which automatically gets passed in, called patronus. And I'm not going to worry for now on validating the patronus from an official list of valid patronuses or patroni. I'm instead going to go ahead and just blindly assign it to self.patronus equals patronus. And we're going to let the user type whatever they want for now. But I could certainly add more error checking if I wanted to limit the patronuses to a specific list of them here. Let me go ahead now and prompt the user for this patronus as by, in my getStudent method, getStudent function, defining a variable called patronus or anything else, prompting the user for input for their patronus. And now I'm going to go ahead and pass in that third variable here. So again, similar in spirit to just adding more and more attributes to the class, I'm going to pass in all three of these values instead of just two. I'm not going to do anything interesting with that value yet, but just to make sure I haven't made things worse by breaking my code, let me run Python of student.py. I'll type in Harry, I'll type in Gryffindor, and it turns out his patronus was a stag, and hit enter. I haven't seen what his patronus is in my output because I didn't change my stir method yet, but at least I don't have any syntax error. So at least I've not made anything worse. But suppose now I want to have functionality, not just for initializing a student and printing out a student. If my class is really meant to be a student, what I can do is not just remember information about data about students. What's powerful about classes, unlike dictionaries alone, is that classes can have not just variables or instance variables, so to speak, those attributes we keep creating. They can also have functions built in, aka methods. When a function is inside of a class, it's called a method, but it's still just a function. At this point, we've seen two functions already, two methods called _init and _stir, but those are special methods in that they just work if you define them. Python calls them automatically for you. But what if you wanted to create more functionality for a student so that your class really represents this real world, or maybe fantasy world, notion of a student, where students not only have names and houses and patronuses, they also have functionality. They have actions they can perform, like casting a charm, a spell, magically. Could we implement, therefore, a function called charm that actually uses their magical knowledge? Well, let's go ahead and define our very own function as follows. Let me clear my terminal window, scroll back up to my student class, and instead of creating yet another function that's special with double underscores, I'm going to invent my own function or method inside of this class. I want to give Harry and Hermione and all of the other students the ability to cast charms. So I'm going to define a function that I can completely on my own called charm. Though I could call this function anything I want, but because it's a method inside of a class, the convention is that it's always going to take at least one argument, called self by convention, so that you have access to the current object, even if you don't plan to use it per se. All right, let me go ahead and propose that we implement charm in such a way that the method returns an emoji that's appropriate for each student's patronus. All right, how to implement this? Well, inside of the charm method, let's go ahead and match on self.patronus, which is the instance variable containing a string that represents each student's patronus. And in the case that it matches a stag, for instance, for Harry, let's go ahead and return maybe the closest emoji, this horse here. How about in the case of an otter? Well, in that case, let's go ahead and return, maybe the closest match to the otter, which might be this emoji here. And let's see, in the case of for Ron, rather than Hermione, a Jack Russell Terrier, let's go ahead and return, how about Don't have as many options here. Why don't we go ahead and return the cutest available dog in that case? And in the case of no Patronus recognized, as might cover someone like Draco, let's go ahead and use a default case using the underscore as in the past. And let's go ahead and return for this. Oh, what should happen if someone doesn't have a Patronus? Why don't we just see a magical wand that seems to fizzle out, as in this case? All right, well now, rather than just print the student, let's go about printing their actual Patronus. So I'm going to go down to my main function here. I'm going to still get a student using the getStudent function. But rather than print student, let's go ahead and declare expecto patronum, printing out just that as pure text. And now let's go ahead and print out not the student, but rather the return value of their own charm method. All right, so let me go back down to my terminal window and run Python of student.py and enter. Name, let's start with Harry. He lives in Gryffindor. Patronus is a stag. And let's see, expecto patronum. And of course, we see the stag emoji. But what about someone like Draco, who, at least in the books, doesn't have a known Patronus? Well, let's go ahead and clear my terminal window, rerun Python of student.py. And this time, let's type in Draco for name, Slytherin for house, and Patronus is unknown. So I'm just going to go ahead and hit enter. And now expecto patronum, and just kind of sizzles instead. Well, let me propose now that we remove this Patronus code just to simplify our world and focus on some of the other core capabilities of classes. So at the risk of disappointing, I'm going to get rid of all of these beautiful emoji and charms. And I'm going to go ahead and stop asking the user now for their Patronus. And I'm going to stop passing it into init here. And I'm going to stop doing this here. And I'm going to instead just go ahead and restore our use of print student here. And I'm going to go ahead and get rid of Patronus down here, so to essentially undo all of the fun charms we just created. So we're now back at the point in the story where we have a student class with only two methods, init and stir. The first of those takes, of course, self as the first argument, as it always will, plus two more now, name and house. No more Patronus. We're validating name up here. We're validating house down here. And then we're assigning name and house, respectively, to two instance variables called name and house also. But we used self to get access to the current object to store those values therein. We then still have our stir method here, which takes one argument, by default self, and that's it. And that function is going to be called automatically anytime you want to convert a student object to a string, just like print might want to do here. So let me go ahead and just make sure I haven't broken anything. Let me run Python of student.py. I'll type in Harry. I'll type in Gryffindor. Enter. OK, we're back in business. Gone are the charms and Patronuses, but at least I'm back to a situation where I have names and houses. But it turns out, at the moment, our use of classes is not very robust, even though we have this mechanism, very cleverly, if I may, in our init method of making sure that we're validating name and house, making sure that name is not blank, and making sure that house is a valid house among those four Hogwarts houses. It turns out that classes will still let me get at those attributes, those so-called instance variables, using dot notation anyway. Let me scroll down then and try to do this a little adversarially. Suppose that on line 16, I go ahead and call getStudent, which exists as before, and then I store the return value in a student variable, again on line 16. That will ensure that getStudent gets called, which calls input and input, and then it calls the student constructor, which invokes automatically this init method. So by way of how we've laid out my code, we're going to ensure that name is not blank and house is definitely one of those four values. My error correction or error checking is in place. But if I'm a little adversarial, I can still circumvent it. Suppose that, fine, you're going to require me to type in Harry and Gryffindor. I'm going to go ahead and type in student.house equals, quote unquote, number 4 privet drive, and you're not going to be able to stop me. Why? Well, it turns out with classes and objects thereof, you and I can still access those instance variables using this familiar dot notation. That's how we began the story of classes, just setting these attributes ourselves. But you can also read these attributes themselves and change them later if you want. And this will effectively circumvent the if condition and the other if condition in our init method, because that is only called when you first create the student object. There's nothing stopping me at the moment from just changing the house or the name after. So if I now clear my terminal window and run Python of student.py, I'll still type in Harry and Gryffindor to meet my requirements that the house be one of those 4. But when it's printed, notice I've still overridden it. So it seems that while classes do allow us a little more control over the data we're storing, it doesn't necessarily prevent the user, or rather the programmer, be it myself or maybe a colleague, from still kind of messing things up. So here too, in the spirit of programming a little more defensively, allow me to introduce another feature of Python as well, namely properties. So a property is really just an attribute that has even more defense mechanisms put into place, a little more functionality implemented by you to prevent programmers like me and you from messing things up like these attributes. So again, a property is going to be an attribute that you and I just have more control over. How? We just write a little more code using some Python conventions. And how we're going to do that is going to use in just a moment a keyword known as @property, which is technically a function. Property is a function in Python. But we're about to see some new syntax that allows you to decorate functions. And this, too, is a term of art. In the world of Python, you can have decorators, which are functions that modify the behavior of other functions, if you will. And we'll leave it at that without going too much into the weeds. And we'll see by example how you can use these decorators specifically to define properties. So let me go back to VS Code here. And let me propose that I do this. I'm going to go ahead and create, how about a property called house as follows. Inside of my student class, I'm going to go ahead and below my init method and below my stir method, I'm going to go ahead and define a function called house that takes, as it always must, one argument at least called self. And what I'm going to do now is return self.house. So I'm just going to define a method called house whose sole purpose in life is to return the value of house. But I'm going to define one other method, curiously also called house, but that's going to take into as arguments 2 values, self, as always, and also a value called house. And I'm going to now do this. I'm going to say I'm going to do self.house equals house. Now, what have I done? Well, let me just temporarily add some comments here. In a moment, we're going to start referring to this generally as a getter. And down here, I'm going to refer to this as a setter. And this is terminology you frequently see in the world of Java. Some of you have programmed in Java before. But as the names imply, a getter is a function for a class that gets some attribute. A setter is a function in some class that sets some value. And now, even though we're not done, and there's a bit of a mistake in the code I've already written, intuitively, what we're going to do is this. We're trying to prevent programmers, myself included, from circumventing my error checking that I put into place for name and house. How can I do that? Well, we don't have that many building blocks in programming. We have things like variables for data, and we have functions for actions. Well, why don't we do this? Why don't we somehow require that in order to access an attribute, you go through some function? And let's require that in order to set some attribute, you go through some function. And conventionally, those functions are called a getter function and a setter function. And why are we using functions, or in this case, methods inside of a class? Well, once you have functions, those are just actions or verbs that you and I can create ourselves. We can put any error correction I want in these functions because it's code that's going to get executed top to bottom. So how can I now prevent the user from setting the house to an invalid value? Let me borrow some logic from before. Rather than blindly do this, just set self.house equal to the house value that's passed in, let's add our error checking there. So if house is not in the following list of Gryffindor or Hufflepuff or Slytherin or Ravenclaw or Slytherin, just as before, let's go ahead and raise a value error just to signify that something has gone wrong. I'll be more explicit. I'll include a message like invalid house, quote unquote. Otherwise, I'm going to proceed on now line 21 to set self.house to house. So I've just copied, if you will, or retyped my error checking inside of this so-called setter function. Now, why have I done that? Well, to be clear, whenever the user or the programmer writes code like this, student.house equals, what's about to happen magically is Python will not just let the programmer access student.house directly, that attribute, that instance variable, aka self.house. It's instead going to magically, automatically call this setter function for me. How does Python know to do that? Well, if it sees that on the left-hand side, there is self.house, where house is the name of the getter or setter, and then it sees an equal sign indicating assignment, that's just enough of a visual clue to say, wait a minute, I'm not going to let you access that attribute directly. I'm going to use the setter instead. Why? Because the equal sign means I'm trying to assign a value from right to left into that attribute. So what Python's going to do automatically is call this function for me. And that's amazing, because now I can execute code, an algorithm, to check, do I want to let the user, the programmer, set that attribute to that value? If not, I'm going to raise a value error, and you're just not going to be able to do it. If so, fine, I'll go ahead and set it for you. But in order to do this, we need a little more syntax. And I'm going to get rid of my comment, and I'm going to use that decorator. I need to tell Python to treat this method as a getter. And then the syntax for the setter is a little different. You now say house.setter. I wish one was getter and the other was setter. That's not the way they designed it. When you want to define a getter, you just say @property above the function. And you name the function exactly like you would like the property to be called, quote unquote house. Once you do that, you can now use a new decorator that's sort of automatically created for you called @house, because I called it house. And then you literally say @house.setter. And this whole line on line 17 is a clue to Python that here comes a function whose name is identical, but notice that it takes two arguments, both self, so you have access to the contents of the object, and house, which is just going to be a stir that comes from the programmer, from like the human input return value, so that you can set that value as well. But there's one fix I need to make now here. Everything else I think is still good. However, watch this. I no longer need this error check here. Why? Because if I scroll back down to my code here, I claimed a moment ago that code like this with student.house equals is going to automatically get Python to call my setter for me. Guess what? Even up here in my init method, calling self.house equals is also going to call my setter method, which is amazing because now I can keep all of my error checking in one place in the setter. And it will now get called either when I create the object for the first time because of init, or even if the programmer tries to circumvent that init method and change the value of this attribute, my setter will also get called. My setter will get called anytime I access .house. But there's one fix I need to make. Unfortunately, I have collided names. Right now, if we go up here on line 5, this is an instance variable. It's a string inside of myself, inside of the current student object called name. And this is another instance variable called house. Unfortunately, if I have an instance variable called name and house, I cannot also have functions called house. They're going to collide. You got to decide. Do you want the variable to be called house, or do you want the function to be called house? Unfortunately, you can't have both, because now Python's going to confuse one for the other. So the conventional fix for this is to do this, to have the setter not store the value that's passed in self.house, but to use an almost identical name, but to use a little indicator that means you know you're doing this correctly. You typically, by convention, put an underscore in front of the instance variable's name. And when you return it up here, you similarly put an underscore. So now technically, my instance variable is called underscore house, but my property, which is a fancier attribute, if you will, is called house alone. Huge amount of syntax, I know, but it's a very powerful feature. And again, this is why you can graduate from dictionaries alone and have so much more functionality at your disposal. Let me go ahead and clear my terminal window and run python of student.py, enter. name. All right, let's go ahead and type in Harry. Let's go ahead and type in Gryffindor, crossing my fingers as always. And now look, invalid house. This is a good thing. Why? Because notice in my main function, I'm still trying, maliciously if you will, to change Harry's house to not be one of the 4 valid ones. I'm trying to change it to his childhood home of number 4 Privet Drive. But because Python knows that, wait a minute, you're trying to assign, that is set a value, and that value, aka house, is now defined as a property, you're going to have to go through the setter function instead to even let you change that value. And because I have this raise value error, if the house is not as intended, you're not going to be allowed to change it to an invalid value. So I'm protecting the data on the way in through the init method, and I'm even defending the data if you try to override it there. So I think the only solution for me, the programmer, is don't try to break my own code. Let me remove that line because it's just not going to work. Let me run Python of student.py, and again, type in Harry, type in Gryffindor, enter, and Harry is indeed from Gryffindor. If I did something incorrect, like Harry from number 4 Privet Drive, enter, we're again going to see the value error because my code just doesn't let that value in via manual input now or via that adversarial change. All right, that was a lot, but any question on properties?
While we are using getters and setters, it's just for the purpose so that we can find our that function, that method, that function in our code.
The reason that I'm going through the trouble of defining this getter or setter is because I want to make sure that programmers cannot do things like this. If I'm going through the trouble of validating the attributes for these student objects, I don't want you to be able to go in there and just change them at will. I want to have some control over that object so that you can just trust that it's going to be correct as designed. So using a getter and setter really just enables Python to automatically detect when you're trying to manually set a value. The equal sign and the dot, as I've highlighted here, is enough of a clue to Python to realize, wait a minute, you're trying to set a value. Let me see if this class has a setter defined. And if so, I'm going to call that, and I'm not just going to blindly assign the value from right to left. So it's just giving me more control. Other questions on properties?
When we use getters, we just have just one argument. And if we use setters, it's always going to be 2 arguments. Is that normal?
Correct. It's always going to be 1 argument, self, for the getter, 2 arguments for the setter, self and something else. And the intuition for that is if you're getting a value, you don't need to pass anything else in because you already know the object. It's called student in this case. So you're just going to get the value of that property. But if you want to set the property to something else, you got to pass in that argument. You've got to pass in the value to which you want to set it. So it's always 0 or 1. However, you see it as 1 or 2 because, again, any function inside of a class, aka a method, is going to be automatically passed self so that you have access to that current object in memory. How about one other question on properties?
Why didn't we use the same underscore house in init method?
A good question. So even though I'm using the underscore house here in my setter and the underscore house here in my getter, I deliberately did not use it up here. The reason for that is that by using self.house and this equal sign, that's the same pattern that I want Python to recognize. I want Python to automatically call the setter even when I'm passing in the house via the init method. If I were to change this to do this, that would circumvent the setter, and now there's no error checking in init whatsoever. So it's such a fine line. The only thing standing between us and error checking or no error checking is the presence or absence of this underscore. But that's typically the convention. By not using the underscore there, make sure that even that assignment goes through the setter so that, honestly, I don't have to copy paste the same error checking in 2 places. I can put it just in the setter. So it's better design, and that's why I manually retyped it at first, but then I deleted it from init. Well, allow me to propose that we make one other change to this file. Might as well go ahead and define a property for name as well. And let me go ahead and do this. Maybe above the house property, just to keep things in the same order as I defined them earlier. Let me give myself another property. This one's going to be called name. It's going to take 1 argument called self as always. And this one, very similarly, is just going to return self._name. So I'm going to anticipate that I'm going to have to rename name also, so that I don't have that same collision as before. But now let me go ahead and define another setter, this one for name. So the convention is @name.setter. Why name? Because the property I just created is called name. So the getter and setter sort of work in conjunction in this way, if you will. Let me go down under @nameSetter and define another function also called name. But the key thing here is that it's not identical. It's not the exact same function name and the exact same number of arguments. The setter, again, takes a second argument. And I can call it anything I want, but I'm going to call it name because that's what's being passed in. And I'm going to put my error checking here. If not name, just like we used to do, let's go ahead and raise a value error. And let's put an explanatory message like missing name, quote unquote. Otherwise, let's go ahead and update self._name to equal name. And I don't have to change init except to get rid of this duplicate error checking now. Because again, if I use self.name equals here and self.house equals here with no underscore, both of those assignments are going to go through my two setter functions now. Before we run this, let me go ahead and remove this adversarial code, which we know won't work because we're catching it. Let me go back down to my terminal window and run Python of student.py, enter. Let's type in Harry, let's type in Gryffindor, and that seems to work. Let's try, though, again to run Python of student.py with Harry from number 4 privet drive. This will not work. A value error with invalid house, because that's not one of the 4 Hogwarts houses. And now, for good measure, let's run it one more time. And let's not even give it a name. Let's just hit enter when prompted. I can type anything for the house. I'll go ahead and still give it Gryffindor, enter. Now we get another value error, but this one is for missing name. So we seem now to have all the more of a defense mechanism in place to ensure that name is as we expect. It's got to have some value that's not blank. And house is as we expect. It's got to have one of those 4 values. But at the risk of bursting everyone's bubble and making you wonder, why did we just go through all of that? Unfortunately, Python really focuses on conventions, not hard constraints. And by that I mean this. If I go back into my main function after I've gotten a student on line 30, and I try to adversarially do something like this, student.house equals quote unquote number 4 privet drive, we know this won't work because my setter for house is going to catch this. Watch again. Python of student.py. Let's type in Harry. Let's type in Gryffindor, which will at least pass our check that's induced by init, but line 31 is going to trigger the same setter to be called, and we're going to raise a value error saying invalid house. Unfortunately, and if some of you are already thinking a little adversarially, tragically, look what you can do. You can change .house to be ._house. Why? Well, the instance variable is now called _house. The property is called house, no underscore. But the underlying attribute implemented as an instance variable is still called _house. And tragically, Python of student.py, let's type in Harry, let's type in Gryffindor, which is correct, but watch what happens now. Oh my God, we slipped through. So what was the point of all of this emphasis from me on doing things the right way, the Pythonic way, by having this getter and setter? Well, unlike languages like Java that just prevent you from doing things like this, Python itself allows you to specify that certain instance variables can be public and accessible to anyone's code, or protected, or private, which means that no one else should be able to change these values. In the world of Python, it's just the honor system. It's not baked into the language itself that there's a notion of visibility, public or private, or even somewhere in between protected. Instead, you're on the honor system. And the convention generally is, if an instance variable starts with an underscore, please don't touch it. Like, just don't. Like, that's on you if you touch that variable and break things. The underscore is meant to signify a convention that this is meant to be private, but it really just means please don't touch this. Sometimes if there's 2 underscores, which you can use too, that's an even greater effort by programmers to say, really don't touch this. But technically speaking, there's nothing stopping you or me from circumventing all of these mechanisms, these properties, these getters and setters. We're ultimately just on the honor system not to do so when we see instance variables prefixed with 1 or perhaps even 2 underscores. All right, so this is a lot all at once, this introduction to object-oriented programming, but it might come as quite a surprise that even though we might have identified OOP by name in weeks past, we've all been using classes and objects for weeks now in this class. In fact, if you think back on one of the very first things we did in this class, we used integers and just got integers from the user. But if you haven't already, if you go and dig into the documentation for integers, which again lives at this URL here, you would actually find that int itself is and has been for weeks a class. And in fact, this is the signature of the constructor call for an int, whereby you pass in x, like a number, quote unquote 50 or quote unquote something else. You pass in optionally the base, 10 for decimal, 2 for binary, or anything else. And that int function will actually return to you all this time an object of type int. That is to say, int is a class. It is a template, a blueprint for creating integers in memory. And anytime you and I have converted a string, for instance, to an int, you and I have been creating an object of type int that was calling apparently the underscore underscore init underscore underscore method that someone else, the authors of Python, wrote to give us back that proper integer. Besides that, if you can believe it, strs, strings in Python, have been classes since the first week of this class as well. If you look up the documentation for a str, which lives at a similar URL there, you will find that when you instantiate, that is, create a str, it takes optionally a parameter called object here, the default value of which is just quote unquote, which allows you to create, in effect, an empty string, a blank string, if you will. But anytime you and I have created strs or even used explicitly this str function, you are getting back an object of type str. Anytime you and I have forced a string to lowercase, per the documentation using syntax like this, you and I have been taking an object of type str and forcing it all to lowercase by calling a method called lower, a method that the authors of Python built into the str class, but it's been there from the get-go. So this notion of methods is not even new today. You and I have been doing it for this long. If you've ever called strip to remove the leading and the trailing white space from a string in Python, you are calling another method that came with Python, written by the authors of Python. And even though we didn't call it a class at the time, a str all this time has been a class. And instances of strings are themselves objects, and those objects come therefore with these functions built in, aka methods, that allow us to do things like force to lowercase and strip white space from the beginning and end. Let's do another. List. Anytime you've created a list, either syntactically with square brackets or literally with list, open parenthesis, close parenthesis, which is also possible, you have been using a class. If you go to the documentation for list at this similar URL here, or more specifically, the tutorial on lists here in Python, you will see that a list is and has been, since the early weeks of this class, a class itself. And that list class takes, as part of its initialization, an optional iterable, something that can be iterated over, like 1, 2, 3, or some list of values. And you can then get back a list containing those same iterable values. If you've ever appended something to a list in this class, as I have myself in the past, you've been using a method called append that comes with the list class that, per the X here, takes an argument that allows you to append something to the current list, aka self, in the context of that method. We can do this all day long. If you've used a dictionary or a dict in Python, I've actually all this time been calling them dict objects, and that's for a reason. Dict itself is a class in Python. If you pull up its official documentation here, and you'll see that it is defined indeed as itself a class, and that class comes with methods as well. And so anytime we've manipulated dictionaries, we've been underneath the hood using all of those same methods. And in fact, we can see this if we're really curious. Let me go back over here to VS Code, and let me go ahead and create a new file that very simply does something like play around with data types. And let me go ahead and create a new file, for instance, called, say, type.py, just so that I can poke around inside of some values. And in type.py, I'm just going to go ahead and do this. I'm going to print out whatever the type is of, say, the number 50. And this is a function you've not necessarily seen me use already, and it's not one you would frequently use in your own code. There are other ways to detect, if you need to, what the type is of a variable. But in this case, type of 50 is just going to tell me and then print out what the data type is of that value. Now, hopefully, all of us could guess that 50 is indeed going to be an integer, that is an int, but we can see it in this way. And this, too, is what's powerful about knowing a bit of programming. If you want to know the answer to a question, just try it out, like I am here. So let me go ahead and run Python of type.py, enter, and there it is. When you print out the type of the number 50, you'll see on the screen in this cryptic syntax, class quote unquote int. This is not something that you'd probably want to show to the user, but if you yourself just want to poke around and see what's going on, or maybe use that information somehow, it's certainly at your disposal to use with this type function for that. Let's change it around a little bit. Instead of passing as the argument to type 50 as an int, let's type something also familiar, like hello, comma, world in double or single quotes. Let me go back to my terminal window, clear the screen, and run Python of type.py again. And now, voila, there it is. All this time, a str is also a class. We can do this a few more times. For instance, let's go ahead and change hello, world to just an empty list. Open square bracket, close square bracket. And this is starting to look a little cryptic, but again, notice what I'm doing. In square brackets is an empty list. We've done that before. That is the sole argument to this new type function, and that's just being passed to the print function so that the return value of type is the argument to print. So if I now run this code, Python of type.py, there it is. A list is a class too. You might recall that I said that you can also create an empty list by literally doing list, open parenthesis, close parenthesis. This is a bit of an inconsistency, as we can now identify that int and str and now list, they're technically all lowercase. And I went to great lengths of creating my student class to have that capital S. That's a convention. Because int and str and list and others come with Python, they decided to make their built-in data types, even though their classes all lowercase. But the convention, the recommendation in the Python community when creating your classes is indeed to capitalize the first letter, as I did in something like student, capital S. But list, open parenthesis, close parenthesis is identical to really just two empty square brackets. If I clear my screen and run type.py again, you see the exact same thing. The class is called list. Let's do one more. Let me change list to be not square brackets, but curly braces. We've done this before. Anytime I've done two curly braces with nothing in between, this, of course, is an empty dictionary or a dict object in Python. Well, we can see that now. Let me clear my screen, run Python of type.py, enter, and there it is, class dict. It's been there this whole time. We just didn't call it a class until today. I can similarly do this one explicitly. Instead of two curly braces, let's write out dict with two parentheses. Now we have a lot of parentheses again, like with list, but this is just making even more clear that the type of a dict object is indeed the class dict itself. So this is to say that as new as a lot of today's idea and syntax might be, you've actually been using it, perhaps unbeknownst to you, for weeks now. We now just have terminology to describe what it is we've been doing all this time. And you now have the expressiveness with some practice to create your own classes, inside of which are your own instance variables, perhaps wrapped with those properties and your own instance methods. But it turns out there's other types of methods in the world. Thus far, I've been deliberate in calling all of our variables instance variables and all of our methods instance methods. It turns out there's other types of variables and methods out there, and one of those is called class methods. It turns out that sometimes it's not really necessary or sensible to associate a function with objects of a class, but rather with the class itself. An instance, or an object of a class, is a very specific incarnation thereof. Again, on that neighborhood that has a lot of identical looking buildings, but they're all a little bit different because of different paint and such, sometimes you might have functionality related to each of those houses that isn't distinct or unique for any of the houses. It's functionality that's going to be exactly the same no matter the house in question. Same in the world of object-oriented programming. Sometimes you want some functionality, some action to be associated with the class itself no matter what the specific object's own values or instance variables are. And for that, we have a keyword called @classMethod. This is another decorator, really another function that you can use to specify that this method is not by default implicitly an instance method that has access to self, the object itself. This is a class method that's not going to have access to self, but it does know what class it's inside. So what do I mean by this? Well, let me go back to VS Code here, and let me propose that we create a new file this time, implementing the notion of the sorting hat from the world of Harry Potter as well to stay on theme. I'm going to go ahead and run code of hat.py. And in hat.py, let's implement the notion of this sorting hat. If unfamiliar, in the books and in the films, there is literally a pointy hat that when a student puts it on their head, that sorting hat, so to speak, decides what house the student is in, whether it's Gryffindor or something else. So let's implement in code this notion of a sorting hat such that when we pass to the sorting hat the name of a student, like quote unquote Harry, this sorting hat implemented in code will tell us what house that student should be in. All right, well, let's go ahead and do this. In hat.py, first, let's go ahead and define a class called hat. And then let's get back to implementing it itself. And I find this to be a helpful technique, not just with teaching, but when writing code. Like, I know I want a hat class. I don't necessarily know what I want it to do yet, so I'm going to create this sort of placeholder ... So I'll come back to that. Let's now try to use this class as though it existed. And from there, I perhaps can realize exactly what functionality that class needs to have to support my use case. Let me go ahead and create a variable called hat in all lowercase and instantiate a hat object. So no matter what the hat class ends up looking like, this is the common syntax for instantiating an object of a certain class. In the past, we saw student, all lowercase, equals capital student, open parenthesis, close parenthesis, and then eventually we added in things like name and house. For now, let's assume that the hat is much simpler than a student, and it only has sorting capabilities, so I'm not going to even pass any arguments there too. Indeed, let me assume that the sorting hat has one function, one method inside of it called sort. And so if I do hat.sort, quote unquote Harry, let's propose that that prints out what house that student should be in. So that's it. I'm going to encapsulate, that is, tuck away inside of a hat class all of this requisite functionality, and I'm going to print out onto the screen what house Harry belongs in. All right, now I think I need to get into the weeds of actually initializing this class. Well, let me go ahead and do this. If I don't care to parameterize hat, I just want to, for instance, sort values. Let's go ahead and define this function sort first. So let's define sort as taking a first argument self, which is always going to be the case when defining an instance method as before. But the sort method clearly takes one argument from the programmer, me, namely the student's name. And again, we've seen this dichotomy before. Even though I'm trying to pass in one argument, when I define the method, it's got to take that many arguments plus one more, self, which is always going to be automatically passed in by Python first. All right, what do I want to do? Well, let's go ahead and do something like this. Print, quote unquote, or rather print this name. How about quote unquote is in, quote unquote, some house. I'm going to again use some placeholder code for myself because I'm not quite sure how to finish implementing this sorting hat. But I think that's enough to just test where my code is at now. Let me go ahead and run Python of hat.py and hit enter. And it looks like, indeed, Harry is in some house. We're not done yet because it's clearly not doing anything interesting, but it at least is running correctly with no errors. Well, let's go ahead now and decide what house Harry should actually be in by introducing a bit of randomness and choosing a house randomly. Well, I can do this in a few ways. Let me go ahead and do this. I need to have a list of houses somewhere. So where can I put that? I could solve this problem in different ways. Let me propose that I do this. Let me define a method called init, as I've done before, that takes in self but no other arguments. And whenever the sorting hat is instantiated, let's do this. Let's create a houses instance variable, plural, that equals this list. Gryffindor, comma, Hufflepuff, comma, Ravenclaw, comma, Slytherin. So the exact same list that we've used before, and I'm storing it in an instance variable inside of this class. I'm not taking any arguments beyond self to init, but I just need this list of values somewhere, for instance. So what can I do here? Well, let me go ahead and replace some house with the actual house. Well, what could I do here? Well, I want to put a house there. Well, let's go ahead and create a variable called house. And if you think back to our discussion of libraries, in the random module, there is a function called choice that if you pass in a list of choices, like self.houses, that will pick a random house out of those 4. And then on line 7, I can pass it in. If I want to tighten this up, let me just go ahead and highlight that code, get rid of the variable. It's technically unnecessary. And because the line of code is still pretty short, I'm OK with just putting it all in one line. But I could certainly use the variable like I did a moment ago. So what have I done? In my init function, I have defined a initialization of the object that stores in self.houses the list of 4 houses. And then in sort, I'm accessing that same list, but I'm randomly choosing the set of houses there. Now, why have I done it in this way? This too is general convention. Anytime you have a list of things that, who knows, maybe will change over time. Places like Harvard have constructed new houses over the years, so you might have to change the list of available houses. It didn't happen in 7 books or 8 films of Harry Potter, but you could imagine maybe Hogwarts eventually has a 5th house. So there's generally some value in putting list of constants toward the top of your file, toward the top of the class. So it's just obvious what the list of values is. You don't want to necessarily tuck it away in some function like sort, especially if you might want to use that function in, especially if you want to use that list in multiple functions. Not just sort, but if I kept adding to this class, you might want to use that same list of houses in multiple functions. So let's keep it in the object itself by storing it in self.houses. All right, well, we're about to change the course of history here, perhaps. Let me do Python of hat.py, and I think we're about to assign Harry to one of those 4 houses randomly. Name error. Name random is not defined. Well, wait a minute. Where did I go wrong here? Thinking back to our class on libraries, why did my code break and not tell me where Harry is to be?
You do not import the random library.
Exactly. If the random library or module is something I want to use, I need to tell Python that at the top of my file. So let me go up here and do import random. And then below that, let me go ahead and clear my terminal window and try again. Python of hat.py, crossing my fingers, seeing where Harry is going to end up. And OK, Harry, as of now, is officially in Hufflepuff, despite everything you've read or seen. Well, let's run this again. Let me clear my window and run Python of hat.py. And now he's in Ravenclaw. That's consistent with using random. Let's clear that and run it again. He's still in Ravenclaw, but that could happen even though there's 4 choices. Let's do it again. Hufflepuff, back in Hufflepuff. We can't seem to get the right answer, so to speak. Now he's in Gryffindor, albeit randomly. So we seem to have a program that, based on these limited tests, seems to indeed be assigning Harry to a house randomly. Now, I'm somewhat lazily just letting sort print out this value. I could do something else like return a string and then let me, on line 13, do the printing for me. But for now, I think we have an example of a class called hat that nonetheless applies some of our lessons learned thus far today, where I've created a class because a sorting hat is, frankly, well, I was about to say real world entity, but really a fantasy world entity. And indeed, that's a perhaps common heuristic or mental model to have. When should you use a class to represent something in your code? Very often when you're trying to represent some real world entity or fantasy world entity, like a student, which is something in the real world, like a sorting hat, which, OK, doesn't exist, but hats certainly do, so quite reasonable to have a class for hat. And that's not always the case, that classes represent real world entities, but indeed we've seen thus far that int and stir and list and dict, these are all structures that you might have in the real world. We have integers and strings of text and other things, so it rather makes sense to represent even those things more technically using a class as well. You could use just a dictionary to represent a student or a hat, but again, with classes come all this and even more functionality. But I honestly am not using classes in really the right way here. Why? Well, in the world of Harry Potter, there really is only, to my knowledge, one sorting hat. And yet here I have gone and implemented a class called hat. And again, a class is like a blueprint, a template, a mold that allows you to create one or more objects thereof. Now, most of my programs thus far have been pretty simple, and I've just created one student. But certainly, if I spent more time and wrote more code, you could imagine writing one program that has a list of students, many more students than just the one we keep demonstrating. Yet it would be a little weird, it's a little inconsistent with the real or the fantasy world of Harry Potter to instantiate 1, 2, 3, or more sorting hats. There really is just one. Really one singleton, if you will, which is a term of art in a lot of contexts of programming. So let me propose that we actually improve the design of the sorting hat so that we don't have to instantiate a sorting hat, because right now this is kind of allowing me to do something like hat 1 equals hat 2 equals hat 3 equals, and so forth. I don't really need that capability. I really just need to represent the sorting hat with a class, but I don't really need to instantiate it. Why? Because it already exists. I need just one. So it turns out in Python that up until now we've been using, as I keep calling them, instance methods, writing functions inside of classes that are automatically passed a reference to self, the current object. But sometimes you just don't need that. Sometimes it suffices to just know what the class is and assume that there might not even be any objects of that class. So in this sense, you can use a class really as a container for data and or functionality that is just somehow conceptually related. Things related to a sorting hat. And there's this other decorator or function called class method that allows us to do just this. So let me go back to my code here, and let me propose that if I'm not going to instantiate multiple houses, I don't really need this init method, because that's really meant to initialize specific objects from that blueprint, that template, that mold. So let me get rid of this. But if I get rid of this, I no longer have access to self. But that's OK, because it turns out, in addition to their existing class methods, there are also what we might call class variables. And class variables exist within the class itself, and there's just one copy of that variable for all of the objects thereof. They all share, if you will, the same variable, be it an int or a str, or in this case, a list. So what I've done here is define inside of my hat class, in a class variable called houses. I don't say self, because self is no longer relevant. Self refers to specific objects. I want a variable inside of this class, aka a class variable that equals that list. Because it's inside of this hat now class, I can use that list in any of my functions. I've only got one now called sort, but if I had more, it would be accessible to all of those methods as well. And with sort, it also doesn't really make sense to sort within a specific sorting hat, because again, I only want there to be one. So I can actually specify that this is a class method by saying @class method. And I don't pass in self anymore. I actually, by convention, pass in a reference to the class itself. It's typically written as CLS. Why? Well, if you wrote CLASS, that would actually conflict with the keyword class that we keep using up here. So the world realized that, oops, we can't reuse that same phrase here, so let's just call this class. This is useful in some contexts, including this one. Why? Well, notice what I can now do. I can now change self to be just class. Why? Because houses is now not an instance variable accessible via self.houses. It is now a class variable accessible via class.houses, or technically CLS.houses in this case. But now the final flourish is this. Now I don't have to instantiate any hat objects as I used to on here, line 13. I can just use functionality that comes with this class. So I'm going to delete that line altogether. I'm going to capitalize the hat on this new line 13 and just say hat.sort, quote unquote, Harry. So what have I done? I've not bothered instantiating an object of type hat. I am just accessing a class method inside of the hat class that, you know what, is just going to work. This is how class methods work. You use the name of the class, capital letter and all, dot method name, passing in any arguments you want. Python is going to automatically pass in some variable via which you can refer to that class in that function that you've implemented inside of that class, so that I can do something like this. It's not that I want a variable called houses locally in this function. I want the variable called houses that's associated with this current class. So I can still access this same list that I defined on line 6. And now, if I go back down here to my terminal and run python of hat.py, enter, Harry is still in Hufflepuff. Once more, Harry is still in Hufflepuff. Once more, Harry is back in Gryffindor, at least randomly. Questions now on these class variables or these class methods, which are in contrast with instance variables and instance methods. And the one thing, at least, that's a little strange here is that even though there's a decorator called @classMethod, there is not one called @instance_method. A method is just automatically a so-called instant method when you define it without any decorator.
Can you have a class inside another class?
You can. You can define one class inside of another. Generally speaking, this isn't done, but there are cases where it can be helpful, especially for larger, more sophisticated programs. So yes, it is possible. Good. Other questions?
The question was about the self.houses. When we remove it, and we pass data, the variable is created itself. Why we remove the self?
So in the previous examples, both of the hat demonstration and also all of the student demonstrations, we were creating a student object by calling student, capital S, open parenthesis, close parenthesis, with eventually name and a house passed in. And then we were using the double underscore init method to initialize the self.name and the self.house instance variables therein to those respective values. In this latest version of the sorting hat, I haven't bothered with self anywhere, only because conceptually, I don't need or want there to be multiple hats in the world. I'm just using the class as kind of a container to bundle up this list of houses, this sorting functionality. Maybe eventually I'll add more functionality to it, but that's it. And so sometimes you can use object-oriented programming in this somewhat different way when you want there to be functionality, but it's not specific to any one specific hat. It's specific to the sorting hat itself. How about one other question now on these class variables or methods? Just another way of using object-oriented programming, but to solve a somewhat different problem.
Well, what's the difference between the class hat and, I don't know, like a function of hat?
A good question. So why are we using a class at all and not just having a file called hat.py with a variable called houses and a function called sort? Like, why are we adding this complexity? In this particular case, we don't necessarily need to. I could absolutely go in here. I could get rid of the class. I could undo this indentation. I could get rid of this decorator. And I could get rid of hat dot. And I could just do this. And additionally, let's get rid of class here. Let's get rid of class here. And now run python of hat.py, enter. And it still works. Put Harry in the wrong house, but that's what happens randomly. That's fine too. What we're introducing today by way of object-oriented programming is just a different way of modeling the world. It's not really compelling with an example like this, frankly, that's relatively simple. It's not very complex. There's not much functionality. Honestly, the version that we just typed up, these 10 lines, this is fine. This solves this problem. But as our code gets longer, as we start collaborating with other people, as the problems we're trying to solve with code get more sophisticated, you're going to find that your code gets messy quickly. And you're going to find that you have a huge number of functions, for instance, in one file. And some of them are related to each other, but some of them are not. Well, at that point, wouldn't it be nice to just organize them a little differently? And in the world of Harry Potter, let's have a class for student. Let's have a class for professor. Let's have a class for the sorting hat. Let's have a class for something else. And so once your world gets much more complicated than some of the demonstrations we do here in class, when we want to focus on individual ideas, object-oriented programming is just a way of encapsulating related data That is variables, related functionality, that is methods, inside of things that have names. These things are called classes. So it's just another way to solve problems. And when we focused on libraries a couple of weeks back, that too was another solution to the same problem. You could define your own modules or packages, put some of your data and or functionality in there, and that's fine too. And sometimes which one you should use overlaps. If you're familiar with Venn diagrams, the overlapping region might mean that you could use a class, you could use a module or a package, you could just use a single local file. Over time, you'll develop an instinct and maybe even a personal preference for which tool to use. All right, let me propose now that we apply this same idea of a class method to clean up one other thing as well. Let me close hat.py and reopen student.py as we left it earlier. And let me go ahead and simplify it just a little bit. I'm going to go ahead and get rid of the properties. Not because there's anything wrong with them, but just because I want us to focus on some of the key ideas when we began with this program. So I'm going to go ahead and keep main as well. I'm not going to adversarially try to change Harry's address there. I'm going to instead go ahead, though, and just print the student. But this is the thing I want to focus on here. This, in our previous student examples, was kind of a missed opportunity to clean up my code. Well, what do I mean by that? Well, up here at the top of this file, even though I've simplified it by getting rid of the properties and all of that error checking, because I want to focus on the essence of this class now, just the student's name and the house and the printing thereof, this is, by nature of classes and object-oriented programming, theoretically all of my student-specific functionality. That is to say, if I have functionality and data related to a student, you, the programmer, my colleague, would assume that it's all bundled up, encapsulated, so to speak, inside of the student class. And yet, if you scroll down further, what is this? Like, there's a function called getStudent that just exists elsewhere in this file that prompts the user for a name, prompts the user for a house, creates the student object, and then returns it. Like, that's not wrong. Like, it works. And we saw many, many times it kept working. But this is a little weird, right? Because if this is a function that helps you get a student, helps you get the name of a student and the house of a student, why isn't that functionality in the class itself? After all, as my code gets more and more complicated and does more things, I'm going to be looking at the student class for all student-related functionality. I'm not going to be scrolling down expecting that, oh, maybe there's some other student functionality just kind of randomly later in this file. So it's not wrong, but this is, again, evidence of maybe bad design. Not so much with this small program, but this is an example, again, of code smell. Like, something smells a little off here. Like, this is probably going to get us in trouble by separating related functionality. So again, it's a design principle, not a correctness concern. But class methods allow us to address this too. Let me go ahead and do this. I'm going to delete getStudent altogether, leaving only main as my other function here. And inside of my student class, I'm going to do this. I'm going to define a function, even more simply called get. And by nature of how class methods work, it's going to take in the name of the class itself, or a reference there too, as an argument. And I'm going to move the functionality from getStudent into the student class. And I'm going to do this. Name equals input, quote unquote name. House equals input, quote unquote house. And then what this function is going to do is return a new student object by calling class, which again is just an automatically passed in reference to the class itself, passing in name and house. And I will admit, this syntax seems a little strange that now I'm calling CLS and I'm passing in these arguments. But let me do one final fix here. Let me go to the top of this function and more explicitly say this is a class method. This solves a potential chicken and the egg problem, so to speak, whereby one needs to come before the other potentially. So what am I doing here? Inside of my student class, I now have a function called get. It is, I shall claim, a class method. What does that mean? It just means I can call this method without instantiating a student object first. Therein lies the potential chicken and the egg problem. And if unfamiliar, that's an expression meaning, well, did the world have chickens first that laid eggs, or was there an egg that then yielded the chickens, but how did the egg get there? It's this sort of weird circular problem, and that's what we're facing here. It would be weird if you had to create a student object in order to call get, in order to get another student object. Like, that sounds messy. Let's just get a student via a class method that by definition does not require you to create a student object first. Just like the hat in its final form, we use the hat class to just say hat, capital H, dot sort. We didn't need to create a hat first. We just used the class itself. So what am I going to do here now? Let me go down to main. And instead of saying get student, notice what I can now do. Student.get. And everything else can stay the same. All I've done now is I've migrated all of my logic from getStudent, which was its own standalone function, but clearly related to students by name. I've moved the same code, really, to inside of the student class in a more simply named function called get, but I could still call it getStudent if I want. It just seems a little redundant to call it getStudent in a student class, so I'm simplifying. So I have a method called get, but I'm calling it a class method to avoid that chicken and the egg problem. I want to be able to call get without having a student object in my universe already. And the syntax for that is at class method. The convention is to give this method at least one argument, by convention called CLS for class, which is just going to be a reference to the class itself. Lines 11 and 12 are identical to what they've always been in getStudent. The only new syntax here is this, but this, again, is one of the features of object-oriented programming. You can now instantiate a student object by just using CLS that's passed in. I technically could use student capital S, but it turns out I'm doing what's more conventional because this will both solve and avoid problems down the line with more complicated code. This line here on line 13 just means create an object of the current class. What class is that? Well, whatever CLS is. Well, that, by definition of how it all works, is going to be student. And I want you to initialize it, as always, with name and house. So now, scrolling down, my code is this. And this is just nice to read. You did perhaps have to acquire a taste for this. And I sound a little odd saying this is nice to read. But indeed, student.get just tells me what's going on. I'm going to get a student. I don't need a separate function written by me called getStudent in the file itself. The get functionality is built into the class. All my student-related code now is together. So let me go down to my terminal window and run Python of student.py, enter. Let's type in Harry. Let's type in Gryffindor. And we're back to where we began. But, everything related to students now is in this here class. The only other thing in the file is main and this conditional that we always use to avoid accidentally executing main when we're making a module or a package or the like. So again, a solution to a problem, not a big one in the case of a relatively small program, but one that you will eventually encounter as your programs get longer and longer with more and more entities to represent. Questions now on this use of a class method?
Does the class have to be defined before the main function in terms of the order of the program?
A really good question. So when in doubt, let's try this. So let's try to change the order. Let's move main to the top, which I've often encouraged. So let's go ahead and above the class do this. And notice now that technically line 2 is mentioning student, which does not exist until line 6 and below. Let me go ahead and clear my terminal and run Python of student.py. So far, so good. Harry, Gryffindor. OK, and indeed, Harry's from Gryffindor. The reason, Michael, it does not matter in this case is because we're not actually calling main until the very end. And just as in the past, that means that Python has a chance to read everything, top to bottom, left to right, so everything exists. I would say generally, classes are defined at the top of the file. However, it would be even maybe cleaner to move the class's definition to its own file and then import it. So essentially to make reusable code by putting it into your own module or package so that not just this program, but many others can use that definition of student as well. Other questions now on classes, class methods, or the like?
I wanted to ask, is there a way to like declare all the possible attributes of the class? Because it looks so inconsistent.
Well, so my takeaway there is this is Python's approach to these principles. Different languages like Java just take a different approach but have very similar features. The syntax just tends to vary. And this is how the Python community chose to implement this idea. The right mental model ultimately is that these instance variables, instant methods, belong to or operate on specific objects, a specific student, a specific hat. Class variables and class methods operate on the entire class itself, or in turn, all objects of that class, which we've not seen a demonstration of, but it's sort of a higher level concept. So it turns out besides these class methods, which are distinct from those instance methods, which to be fair do not have their own decorator, they just are by default instance methods, there's yet other types of methods you can have in classes in Python. They tend to be called static methods, and they too come with another decorator called @static method, which is a rabbit hole we won't go down, but realize that there is yet other functionality that you can leverage within object-oriented programming. But what we thought we'd do is focus really on some final core features that you see not just in Python, but other languages as well. And perhaps one of the most compelling features of object-oriented programming that we haven't yet used explicitly, though it turns out we've seen implicitly over the past weeks, is this notion of inheritance. It turns out via object-oriented programming, there's actually an opportunity to design your classes in a hierarchical fashion, whereby you can have one class inherit from or borrow attributes, that is, methods or variables from another class, if they all have those in common. So what do I mean by this here? Well, let me propose that we implement over in VS Code here a brand new file called wizard.py. Let me go ahead and run code of wizard.py. And then let's start as before defining a class called student. And let's go ahead and first define the __init method, which of course is minimally going to take an argument traditionally called self. And in this case, let's also have it take as before a name and a house. And then in this init method, let's go ahead and assign the instance variables self.name equals name and self.house equals house. Let's assume that there's some other functionality in this class as well, ... But let's move on now to implementing the notion of a professor in the wizarding world as well. So for this class, let's call it professor. And a professor, let's say, is also going to have its own initialization method. So __init. It's going to take self, as always, as the first argument. A professor also has a name, so we'll pass that in second too. And even though some professors are heads of houses, let's assume that a professor is really identified by their name and their subject area, the class that they teach. So we'll call this third argument subject. Now, as before, let's go ahead and assign self.name equals name. And let's assign self.subject equals subject here. And as before, let's assume that there's some more functionality associated with professors as well. Well, what do you notice already here in my definitions of students and professors? Typically, we're a bit reluctant to allow for any redundancy in our code. And here, I feel like my init method is taking a name for student. My init method is also taking a name for a professor. And I have these identical lines of code like self.name equals name. And this is only going to get exacerbated if I now go and add some error checking. So for instance, how about if not name, we should probably be in the habit of raising something like a value error in an explanatory message like missing name. And you know what? If a professor's missing their name, I should probably copy paste that code down here. And that's where the red flag should be going off, whereby as soon as you start copy pasting code, there's probably a better way so that we can write the code once and perhaps reuse it in some way. And here too, object-oriented programming offers a solution. It turns out that object-oriented programming in Python also supports inheritance, whereby you can define multiple classes that somehow relate to one another. They don't need to exist sort of in parallel in this way. There could actually be some hierarchy between them. So for instance, in the wizarding world, we could argue that both a student and a professor are, at the end of the day, wizards. So maybe what we should really define is a third class, for instance, called wizard, that has any of the common attributes for students and professors alike. And for now, we've kept it relatively simple. The only thing they have in common is a name and a name in student and professor respectively. So why don't we minimally factor that out first? All right, so let me go ahead here. And just to keep things organized, at the top of my file, let's define a third class called wizard. And a wizard will have its own initialization method. So def __init __, and self, as always. And a wizard, let's say for now, is only going to be initialized with their name in this way. And now I'm going to go ahead and do some of that error checking. So if not name, we'll raise a value error in the wizard class. Otherwise, we'll go ahead and do self.name equals name. And heck, ... got maybe some other functionality as well. But not a subject, which is specific to professors, and not a house, which I've claimed is specific to students. Now, I think we can begin to maybe remove some of the redundancies in our other classes here. So for instance, down with student, why don't I go ahead and remove this error checking here and remove this error, this assignment of self.name equals name, because I'm already doing that in wizard. And similarly down here in professor, why don't I do the same? Let's get rid of the error checking. Let's get rid of self.name equals name, because again, I'm doing that already up there for wizard as well. But at the moment, even though they're all in the same file, I haven't told Python that a student is a wizard and a professor is a wizard. So I really need to link these two together. And the way you can prescribe inheritance, whereby one class should inherit from another, or conversely, one class should descend from another, we can do this. I can say class student, but before the colon, I can go in and say in parentheses, a student inherits from or is a subclass of wizard, which conversely is the superclass of the student class. So this just means that when I define a student class, go ahead and inherit all of the characteristics of a wizard as well. And I'm going to do the same thing for professor. So parenthesis, wizard after the class name professor, and that's going to give me access to some of that same functionality. But because my student class and my professor class still have their same init methods, those are the methods that are going to get called whenever I create a student in code or I create a professor in code. I need to somehow explicitly say that I also want to use the functionality in the wizard class's init method. And the way to do this in Python is as follows. Let me go into my init method for student, and let me call super with no arguments, which is a reference to the superclass of this class. So if this class is student, the superclass, that is the parent class, is wizard. So super, open paren, close paren, will have the effect of accessing the superclass, and then I'm going to go ahead and explicitly call its init method, and I'm going to pass to the wizard's init method the name that the student's init method was passed. And I'm going to go ahead and do the same down here in wizard. This is one line of copy paste, but I think I'm OK with it here because it's still allowing me to do all of the name assignment and the error checking up in the wizard class instead. I think we're OK now by just calling super.init for both student and professor alike. Now, admittedly, this syntax is definitely out there. The fact that we're calling super in parentheses and dots and underscore on the left and the right of init here, but it's just a combination of these two ideas. Super, open parenthesis, close parenthesis, is a way of programmatically accessing a current class's parent class or superclass, and underscore init, of course, is just referring to now that class's own initialization method. Now, per the ... so there could be a lot more going on in these classes, but what's nice now is that wizard as a class is taking care of all of the assignment of a wizard's name, whether that wizard is a student or a professor, and it's even doing some error checking to make sure that the name was actually passed in. Meanwhile, student is inheriting all of that functionality and using it by calling the superclass's own init method, but it's additionally taking the house that's presumably passed into the student constructor function and assigning it to its own instance variable, self.house. And similarly, professor are restoring in self.subject the subject that was passed into that one as well. Now, how might we use these classes? Well, we'll continue to wave our hands with a little bit of detail here, but if at the bottom of this file or any other file that imports this one, I could now write code like this. I could create a student variable and assign it the return value of the student constructor call, and maybe that student is named Harry, and that student's house, for instance, might be Gryffindor. And meanwhile, I might do something like this. Professor equals professor over here. And notice the lowercase s on the left, capital S on the right. Same for professor on the left, lowercase and uppercase on the right, respectively. Professor, quote unquote, Severus. And how about defense against the dark arts will be his subject. And meanwhile, if we want more generically just a wizard who at the moment is neither student nor professor teaching classes actively, we could even do that. We could do wizard equals wizard in capital W on the right-hand side of the equal sign because it's the name of the class, and someone like Albus, passing in only Albus's name, not a house, not a subject, because in this case, he's known only as a wizard. Meanwhile, with each of these calls, This line of code here will ensure that the init method for the wizard class is called. This line of code here will ensure that the init method of the student class and in turn the init method of the superclass wizard is called. And then lastly, on this final line of code, will this syntax ensure that the init method of the professor class is called, which in turn calls the init method of the superclass as well. Any questions now on this idea of inheritance, which is a key feature of a lot of object-oriented programming languages?
So is there any situation where, because from what I've seen so far, a lot of times there's like a lot of nesting. If you do super, does it go one up? Is there any situation where, you know, it's nested in another class as well, above wizard, let's say?
A really good question. If you were to have a super class, so your hierarchy is even taller than the 2 levels of hierarchy that we currently have, absolutely. But what's nice about what's nice about inheritance, as the name implies, is just as you might have inherited certain traits as a human from your grandfather and grandmother, or your great-grandfather or great-grandmother, some of those properties can actually trickle down to you, so to speak, in the context of code as well. So when you descend from another class, that is, when you subclass a superclass or a superclass, you actually do inherit all of the functionality, not just from one level above you, but from 2 or 3. So you can indeed access some of that functionality as well. And you can even override it if you want some of these classes to behave a little bit differently than others. Other questions on inheritance?
So it's kind of similar to the last one, but can you have like 2 parents on the same level?
A really good question. So there are ways to implement descendants from multiple parents, and there's different ways to do this, not just in Python, but other languages. We've kept things simple here, though, by having a single inheritance path. A good question. How about one more question on inheritance?
Can we have multiple arguments in super dot double underscore init?
Yes, but in this case, I'm only passing in name on line 18, and I'm only passing in name on line 10. Why? Because on line 2, when I define the init method for the wizard class, I only expect a single argument. But I could absolutely have other common functionality, like I could add in a patronus. If both students and professors have patronuses that can come out of their wands, I could have 2 arguments instead. We've been using this feature of object-oriented programming now for quite some time in the form of exceptions. Indeed, if you look at the official documentation for exceptions in Python, you'll see that there's not even the ones we've seen in class, like value error and others. There's any number of others as well, but they are all themselves hierarchical in nature. This is just a subset of the available exceptions that come built into Python, and you can actually, as a programmer, create your own exceptions as well. But as this chart here captures hierarchically, all exceptions we've seen thus far actually descend from or inherit from superclasses already. So for instance, at the bottom of this list here is value error, which we've seen quite a bit. And if you follow the line straight up on this ASCII rendition of this chart, you'll see that value error has a parent class or superclass called exception. And the exception class, meanwhile, has a parent class called base exception. Why did the authors of Python do this? Well, it turns out that whether you have a value error or a key error or an assertion error or any number of others, there's a lot of functionality common to all of those types of errors that you want a programmer to be able to use. And so it turns out that the authors of Python decided, you know what, let's not have a dozen or more different classes that all just have copy-pasted similar functionality. Let's create this hierarchy so that even though the exceptions toward the bottom of this list are very precise, they at least inherit, that is, borrow some very common functionality up above. So it turns out that when you use the try and the except keyword in Python, generally speaking, we've tried to catch very specific exceptions like value error. But technically, you could capture the parent or even the grandparent exception for a given exception, especially if you're not necessarily sure which one is going to get raised. Or better yet, there could be many exceptions that get raised, but you want to handle them all the same. And you don't want to necessarily enumerate them in parentheses separated by commas. You want to say you want to handle all exceptions of a certain superclass in much the same way. So this has been latent this whole time. Anytime we've seen or used or caught or now raised exceptions, and built into Python is this hierarchy. And if you were to invent your own exception, generally you wouldn't want to start from scratch. You would want to descend from, that is, subclass one of these existing exceptions and add your own twist on it your own functionality as well. Well, there's one final feature of object-oriented programming that we'd like to share with you today, and that it will perhaps be quite the eye-opener as to what you can really do now that you have classes at your disposal. And this, too, surprise, has been a feature you and I have been taking for granted for weeks now. This has just worked, but it's been implemented in a way that you can now leverage yourself. It turns out that Python and some other languages too support this notion of operator overloading, whereby you can take very common symbols like plus or minus or other such syntax on the keyboard, and you can implement your own interpretation thereof. Plus does not have to equal addition, and minus does not have to equal subtraction. And in fact, you and I have already seen another context in which plus means something else. Plus has not always in Python meant addition per se. What else has Python used plus for?
Concatenation.
For concatenation, for joining two strings, for adding to a list. Can you use plus as well? So plus has actually been, funny enough, overloaded by the authors of Python for us. And so we can use the same symbol in much the same way as addition, but with different data types to solve slightly different problems. Well, let me propose that we go back over to VS Code here, and let me go ahead and create a new final file called vault.py. So code of vault.py. And let me propose that we implement the idea of a vault at Gringotts, keeping on theme, wherein there's a bank in the world of Harry Potter, and within this bank, families and individuals have vaults containing all sorts of money in the wizarding world. And the type of money that exists in the world of Harry Potter are coins called galleons and sickles and knuts. And those are in descending order of value. And so inside of a vault might be a whole bunch of coins, gold, silver, and bronze, essentially, each in those denominations tucked away. So how can I go about implementing, first of all, the idea of a vault so that I can store, for instance, for Harry Potter, how much coinage is in his family's vault, or for Ron Weasley, the same. Well, let me go ahead in vault.py and first create a class called vault, essentially meant to represent a bank vault. Perfect. Another real world or fantasy world entity that I want to represent with code. I could use a tuple or a list or a dictionary, but again, I'm going to get a lot more functionality with classes, and we'll see one final flourish with operators. Inside of this vault class, let's go ahead and do this. Let me define my init method, taking its first argument of self, and let me define 3 arguments to this. When you create a vault in my code here, I want to be able to initialize it with some number of galleons, some number of sickles, and some number of knuts. I want the programmer to be able to pass in one or more of those values ideally, but they can be optional, so I'll give them defaults. So let's go ahead and define a parameter called galleons, whose default value will be 0, sickles, whose default value will also be 0, and knuts, whose default value will be 0 as well. So the programmer can pass in 1 or 2 or 3 or heck, even none of those, and they'll all have some implied defaults. How do I want to remember those values that are passed in? Well, let me do this. Self.galleons equals galleons, and self.sickles equals sickles, and self.knuts equals knuts. And so I could add some error checking, especially if you don't pass in a number. I could turn these into properties to do even more validation. But let's keep it simple, and as always, focus only on the new ideas. So I'm just going to trust that these values were passed in, and I'm going to immediately assign them to these instance variables. What now do I want to do? Well, let's come up with a way of printing out what is in someone's vault, ultimately. But first, let's do this. Let's create a vault for the Potters by creating, via assignment, a new vault. And let's say that the Potters have 100 galleons, 50 sickles, and 24 knuts. All right, and that's in that vault. And let's print out, for instance, Potter. All right, let's run this code and see how it works now. Let me go ahead and run Python of vault.py, enter. OK, seems to work. No syntax errors or anything else, but this is not very enlightening. How do I fix this? Thinking back to what we've done before.
You have to use the _ stir.
Exactly. I need to use one of those special methods that comes with classes and define for myself how I want a vault to be printed as a string. So let me go ahead and do that. Let me define the stir method, taking in self as its sole argument here. And let's just return a very simple string that just reveals what's in the vault. So I'm going to return a formatted f string, inside of which is self.galleons, and then the word galleons, so I know which those are. Then let's do self.sickles, and let's output the word sickles. And then lastly, let's output self.knuts, and then knuts here. So I know in this string just how many of each of those coins I have in this particular family's vault. All right, let me go ahead and run Python of vault.py, changing nothing else except the stir method. And now we see indeed that Harry has 100 galleons, 50 sickles, and 25 knuts. All right, well, let's do one thing more here. Below that, let's go ahead and define a Weasley variable. And Ron never seemed to have quite as much money in the vault as did Harry. So let's say that the Weasley vault will have 25, 50, and 100. So I'll just reverse the order of those denominations rather than Harry's 100, 50, 25. And now let me go ahead and print Weasley like this. And let's go ahead and clear my terminal window, run Python of vault.py. This time that stir method will be invoked twice, once for each of those vault objects. And we'll see indeed that the first one for Harry's got 100, 50, and 25 respectively, versus Ron's 25, 50, and 100 respectively. But now let's do something interesting. Suppose that you wanted to combine the contents of two vaults, be it Harry's and Ron's or any other two people. How would you go about doing this in code? Well, if I wanted to combine the vaults for someone, I could do this. Well, I could do galleons equals, let's do potter.galleons plus Weasley.galleons. That gives me a variable called galleons that has the sum of Harry and Ron's galleons. Let's next do sickles equals potter.sickles plus Weasley.sickles. And then lastly, let's do knuts equals potter.knuts plus Weasley.knuts. I've got three variables. What can I now do with these values? Well, let's create a new vault. Total will be the name of this variable equals a new vault, capital V, notice. And now let's pass in those three new variables, galleons, sickles, and knuts. And that's it. And let's print out this total vault. So we should now see three vaults, one for Harry, for Ron, and the combination, the addition of the two. Let me go ahead and rerun Python of vault.py, and there we have it. What was 100, 50, 25, and 25, 50, and 100 combined through addition now is 125, 100, 125. So pretty straightforward, using techniques from weeks ago where we're just declaring a few new variables and doing some addition. But wouldn't it be cool if I could do something like this? Wouldn't it be cool if I could just somehow not manually create my own vault and do all of this annoying math up here? What if I could just do Potter plus Weasley and get rid of all of this logic here? Like, wouldn't it be nice if I overload the operator we know as plus, just like stir does, just like list does, to allow me to add two vaults together on the left and the right? Well, it turns out in Python, and through operator overloading, there is a way to do just this. If you consult the documentation, there's this and so many other special methods that come with classes. The third one we'll see here is this one here. Underscore underscore add underscore underscore. And you'll see that it very generically is described in the documentation as working for any object, be it a vault or a stir or a list or something else. By convention, it's going to take a first argument called self, and then it's going to take some other argument by convention called other. Self, in effect, is going to be referring to whatever object is on the left of a plus sign. Other is going to be referring to whatever's on the right-hand side of a plus sign, thereby giving us a way of describing in code the operand on the left and the operand on the right of the operator plus in between. That is to say, if I go back to VS Code here, what I'm trying to do is implement support for this. Well, let me try without writing any other code just yet. Python of vault.py, enter, type error. Unsupported operand types for vault and vault. That is to say, Python at this moment does not know what it means to add two vaults together, right? You and I might have an instinct, probably want to combine the galleons and the sickles and the knuts respectively. Python doesn't know that. It just knows that you have a new class called vault. But let's teach Python to do this. Let me clear my terminal window. Let me scroll back up to the class itself, where at the moment I only have two special methods, init and stir. But let's add this third. All right, let me go into the class here and define underscore underscore add underscore underscore, and then specify its first parameter as self, as before, and then a second parameter for this particular method called, by convention, other. Now, as always, I could name those parameters anything I want, but I'm going to stick with convention here. And now inside of this method, am I going to have to now add together the contents of two vaults? Well, what two vaults? Well, if we scroll down to our goal at hand, the goal, of course, is to add this vault plus this other vault, Potter plus Weasley, respectively. directly? Well, it turns out in Python that when you do overload an operator like plus, what's going to happen automatically as soon as Python sees that is it's going to call that underscore underscore add underscore underscore method, and it's going to pass into it 2 arguments. Whatever the operand is on the left, Potter in this case, and whatever the operand is on the right, Weasley in this case, and those values are going to get passed in as self and other respectively. What that means is that we can access their contents up here in our implementation of add as follows. Let me go ahead and define a local variable called galleons and set that equal to, for instance, the sum of self.galleons, whatever's in Potter's vault in this case, plus whatever's in Weasley's vault in this case, which would be other.galleons. Let me do the same for sickles, self.sickles plus other.sickles. And let me lastly do that for knuts. So self.knuts plus other.knuts. But at the end of the day, I'm going to need to return a brand new, bigger vault that contains all of those contents together. And if we ultimately want to assign that bigger vault to a variable like total here on the left, we'd better indeed return a value from this add method. So I'm going to go ahead and give myself a brand new vault as by returning capital vault, which of course is going to call my vault function into which I can now pass some of those initialization arguments. Well, how many galleons, sickles, and knuts do I want this brand new vault to contain? Well, I want it to contain this many galleons, this many sickles, and this many knuts. So ultimately, what we're doing in this implementation of add is adding together those galleons, sickles, and knuts, passing them to the vault function so that we get a brand new, bigger vault and return that all together. So now I've defined this new special method called add that should now just make plus work for 2 vaults. All right, let's see. Let me run down to my terminal window, Python of vault.py, and hit enter, and voila. Now we've implemented an overloaded operator plus to do what you and I as humans would hope would be the case when you add 2 vaults together. But I've now written the code more specifically to teach Python what it means concretely to add 2 vaults together. And it's with very similar code in effect underneath the hood that Python is doing this for 2 strings, to concatenate them together, to joining 2 lists into a new list with lists, and so many other classes as well. Any questions now on operator overloading, or this example here?
How would you go about creating a function for adding a student and a vault for two separate classes? How would that be possible?
Let me see what happens here. I don't know offhand. Let's do this. Let's create a stir and see what happens if I add Potter plus a stir. Stir object. Yeah, OK, so it would work. I'm just figuring this out as I go here, Eric. So just to be clear, what I did was I just changed Weasley to stir just to see what would happen when I add a vault plus a stir. And it will work theoretically. Why? Because so long as the type of value on the left has an add method implemented, other can be any type that you want. You just have to decide in code what it's going to mean conceptually to add a vault plus a string, which in this case probably doesn't make any sense at all, but it's possible. It's going to be the operand on the left. And I'm inferring that. I did not know the answer a moment ago. I'm inferring that because what I got was an attribute error here on line 11 because Python did not like this. Other.galleons didn't work, but I could make it work by figuring something out. Really good question. Didn't know that one myself. Other questions on operator overloading?
Can you define new operators in Python?
I don't think so. There is a very long but precise list of operators that you can overload. I do not believe you can assign arbitrary characters to be operators in Python. Let me defer to Carter in the chat to revoke. OK, I'm seeing 2 of my colleagues are saying, no, not possible. So I'm going to go with my first instinct. No. Otherwise, that'd be kind of cool. You could make emoji do whatever you want to. How about one final question on operator overloading?
Is that the only operation you can do? As far as like, can you do a subtraction as well?
You can do so many others. Let me, if Carter, you don't mind pulling up this URL here. So this link here, special method names in today's slides, you'll see a long list of all of the operators that you can overload. You can do less than, equals than, plus equals, minus equals. Pretty much any symbol you've seen me type on the screen can be overloaded in the context of classes. So even though today we focused entirely on object-oriented programming, this is a technique that we've been using really since the first week of the class. Because indeed, those ints, those strs, those floats, those lists, those dictionaries, and so much more were already underneath the hood this whole time, classes and objects thereof. But you now, as a programmer, have the ability to create your own classes with your own instance or class variables, with your own instance or class methods, with your own properties, and even with your own custom behavior for operators. So ultimately, you can absolutely continue using those simple tuples or lists or those dictionaries or other structures as well. But object-oriented programming, and with it classes and now these objects, is just another tool in your toolkit. And dare say, as your code gets more sophisticated and your problems get bigger, you'll find that being able to model these real-world or even fantasy world entities with classes and related data and functionality will ultimately just allow you to define code that's not just correct, but ever well designed as well. This was CS50. All right, this is CS50's Introduction to Programming with Python. My name is David Malin, and over these past many weeks have we focused on functions and variables early on, then conditionals and loops and exceptions, a bit of libraries, unit tests, file I/O, regular expressions, object-oriented programming, and really, etc. And indeed, that's where we focus today, is on all the more that you can do with Python and programming more generally beyond some of those fundamental concepts as well. In fact, if you start to flip through the documentation for Python in all of its form, all of which is, as always, accessible at docs.python.org, you'll see additional documentation on Python's own tutorial and library, its reference, its how-to. And among all of those various documents, as well as others more online, you'll see that there's some tidbits that we didn't quite touch on. And indeed, even though we themed these past several weeks around fairly broad topics that are rather essential for doing typical types of problems in Python, it turns out there's quite a number of other features as well that we didn't necessarily touch on, that didn't necessarily fit within any of those overarching concepts, or might have been a little too much too soon if we did them too early on in the course. And so in today, our final lecture, will we focus really on all the more that you can do with Python and hopefully whet your appetite for teaching yourself all the more too. For instance, among Python's various data types, there's this other one that we haven't had occasion to yet use, namely a set. In mathematics, a set is typically a collection of values wherein there are no duplicates. So it's not quite a list. It's a bit more special than that, in that somehow any duplicates are eliminated for you. Well, it turns out within Python, this is an actual data type that you yourself can use in your code. And via the documentation here, might you be able to glean that it's a useful problem if you want to somehow automatically filter out duplicates. So let me go ahead and go over to VS Code here, and let me go ahead and show you a file that I created a bit of in advance, whereby we have a file here called houses.py. And in houses.py, I already went ahead and whipped up a big list of students, inside of which is a number of dictionaries, each of which represents a student's name and house, respectively. Now, this is a pretty sizable dictionary, and so it lends itself to iteration over the same. And suppose that the goal here was quite simply to figure out, well, what are the unique houses at Hogwarts in the world of Harry Potter? It would be nice, perhaps, to not have to know these kinds of details or look them up online. Here we have a set of students, albeit not exhaustive with all of the houses, but among these students here, what are the unique houses in which they live? Well, I could certainly, as a human, just eyeball this and tell you that it's, well, Gryffindor, Slytherin, Ravenclaw, but how could we go about doing it programmatically for these students as well? Well, let's take one approach first here. Let me go into houses.py, and let me propose that we first, how about create an empty list called houses, in which I'm going to accumulate each of the houses uniquely. So every time I iterate through this list of dictionaries, I'm only going to add a house to this list if I haven't seen it before. So how do I express that? Well, let me iterate over all of the students with for student in students, as we've done in the past. And let me ask you a question now. So if the current student's house, and notice that I'm indexing into the current student because I know they are a dictionary or dict object, and if that student's house is not in my houses list, then indented am I going to say houses dot append, because again, houses is a list, and I'm going to append that particular house to the list. Then at the very bottom here, let me go ahead and do something somewhat interesting here and say for each of the houses that I've accumulated in, I could just say houses, but if I just say houses, what was the point of accumulating them all at once? I could just do this whole thing in a loop. Let's at least go about and sort those houses with sorted, which is going to sort the strings alphabetically. And let's go ahead therein and print each of the houses. Let me go ahead now in my terminal window and run Python of houses.py and hit enter. And there we have it. Gryffindor, Ravenclaw, Slytherin in alphabetical order, even though in the list of dictionaries up here, technically, the order in which we saw these was Gryffindor, 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 Slytherin, Ravenclaw. So indeed, my code seems to have sorted them properly. So this is perfectly fine, and it's one way of solving this problem. But it turns out we could use more that's built into the language Python to solve this problem ourselves. Here I'm rather reinventing a wheel, really the notion of a set wherein duplicates are eliminated for me. So let me go ahead and clear my terminal window and perhaps change the type of object I'm using here. Instead of a list, which could also be written like this to create an empty list, let me go ahead and create an empty set, whereby I call a function called set that's going to return to me some object in Python that represents this notion of a set wherein duplicates are automatically eliminated. And now I can tighten up my code because I don't have to use this if condition myself. I think I can just do something like this. Inside of my loop, let me do houses.add. So it's not append for a set. It's append for a list, but it's add to a set per the documentation. Then let me go ahead and add this current student's house. And now I think the rest of my code can be the same. I'm just now trusting, per the documentation for set in Python, that it's going to filter out duplicates for me. And I can just blindly add all of these houses to the set. And any duplicates already there will be gone. Python of houses.py and enter. And voila, we're back in business with just those three there as well. Let me pause here to see if there's any questions now on this use of set, which is just another data type that's available to you, another class in the world of Python that you can reach for when solving some problem like this.
How can we locate an item in a set? For example, find Gryffindor in that set.
How do you find an item in a set? You can use very similar syntax as we've done for a list before. You can use syntax like if Gryffindor in houses, then, and you can answer a question along those lines. So you can use in and not in and similar functions as well. Other questions on set?
Okay, what happens if you have a similar house name? Let's say instead of Slytherin, it is maybe an O instead of an I. Will the for loop throughout each of those letters in the house name?
It would compare the strings. So if Slytherin appears more than once but is slightly misspelled or miscapitalized, if I heard you right, those would appear to be distinct strings. So you would get both versions of Slytherin in the result. However, we've seen in the past how we can clean up users' data. If indeed it might be messy, we could force everything to uppercase or everything to lowercase, or we could use capitalize, the function built into stirs, or title case that would handle some of the cleanup for us. In this case, because the data is not coming from humans using the input function, I wrote the code in advance, it's safer to assume that I got the houses right. But that's absolutely a risk if it's coming from users. Allow me to turn our attention back to some of the other features here that we can leverage in Python if we dig further into the documentation and read up more on its features. Well, in some language, there's this notion of global variables, whereby you can define a variable that's either local to a function, as we've seen many times, or if you put a variable outside of all of your functions, perhaps near the top of your file, that would generally be considered a global variable. Or in the world of Python, it might be specific to the module, but for all intents and purposes, it's going to behave for a given program as though it is global. However, it turns out that if you do this when solving some problem down the line, whereby you have multiple functions and you do have one or more variables that are outside of those functions, you might not be able to change those variables as easily as you might think. So indeed, let me go back to VS Code here. And in just a moment, I'm going to go ahead and create a new file. How about called bank.py? Let's go ahead and implement the notion of a bank wherein we can store things like money in various forms. And let me go ahead and do this. Let me go ahead and implement a very simple bank that simply keeps track of my total balance, the number of dollars or cents or whatever I might be storing in this bank. And I'm going to give myself a variable called balance at the top, which is an integer, set to 0. Now let me go ahead and define a main function, as we often do. And inside of my main function, let me go ahead and print out, quote unquote, balance, and then print out the value of balance itself, passing to print, as we've often done, more than one argument so that they get separated by a single white space. And now, since I have a main function, really setting the stage for doing more interesting things soon, let me go ahead and do our usual if the name of this file equals underscore underscore main, then go ahead and call main. So this is a terribly short program, but it's perhaps representative of how you might solve some future problem in Python whereby you have a main function that's going to eventually do some interesting stuff. And at the top of your file, you have one or more variables that are just useful to keep there because then you know where they are. And perhaps not just main, but other functions can access them as well. So let's see, when I run this program, Python of bank.py, I would hope, based on my own intuition thus far, that I'm going to see that my current balance is 0. That is to say, even though the balance variable is defined on line 1, hopefully I can still print it on line 5 inside of main, even though balance was not defined in my main function. Here we go, hitting enter, and voila, balance 0. So it does seem to work. Even if you declare a variable in Python outside of your functions, it appears that you can access it. You can read the value of that variable even inside of a function like main. Well, let's get a little more adventurous now, because this program really isn't solving anyone's problems. Let's go ahead and implement more of a bank, like the ability to deposit money into the bank and to withdraw money from the bank, thereby giving me some more functions that might very well need to access that same variable. Let me clear my terminal window here, and let me go ahead and pretend for the moment that I have the ability to deposit, say, $100 or 100 coins, whatever the unit of currency is here. And then maybe I want to withdraw straight away 50 of those same dollars or coins. And now let me go ahead and just print out at the bottom of main what my new balance should be, so that in an ideal world, once I've deposited 100, then withdrawn 50 after starting at 0, I'd like to think that my new balance on line 8 should indeed be 50. All right, but I haven't implemented these functions yet, so let's do that as we've done in the past. Down here, I'm going to go ahead and define another function, deposit. I'm going to say that it takes an argument called n for a number of coins or dollars or the like. And I'm just going to do this. I'm going to go ahead and say balance plus equals n, thereby changing the value of n. I could do it more verbosely, balance equals balance plus n, but I'm going to use the shorter hand notation here instead. And now let's implement withdraw. So define a function called withdraw. It too is going to take a variable, an argument n for number of dollars or coins. And now I'm going to go ahead and subtract from balance using minus equals n as well. And I'm still going to call main if the name of this file is main. So what have I done? I've just added not just one, but 3 functions total, all of which apparently need to access balance by printing it, incrementing it, or decrementing it, as we've seen here. All right, let me go ahead and focus on these 3 functions here. Let me go back to my terminal window and run Python of bank.py and hit enter. And wow, seems like we've introduced some number of problems here. And what are these problems? Well, unbound local error is perhaps the first time we've seen this one here. Local variable balance referenced before assignment. And that's a bit misleading, definitely confusing, right? Because I absolutely assigned balance a value on the top of my code. And indeed, if I scroll back up, nothing has changed or been lost up there. It's definitely been assigned a value. And now on line 12, it would seem that when deposit is called, I'm just trying to access that variable again. So intuitively, what might explain this error message? Unbound local error. What is Python telling us there that Python can or can't do when it comes to these so-called global variables that are at the top of my file?
So if you want to change this variable, you should write inside def function main, and global variable unchangeable.
Yeah,
You
so if you want to change the value, it might need to be local to the function. If you are trying to change a global variable, though, in a function, it clearly does not work. So it's OK to read a global variable, read meaning access it and print it and so forth. But apparently, you can't write to a global variable in the same way from within one of these functions. All right, well, maybe the fix is to do this. Let me clear my terminal window in that error. And maybe I could just do this. Let's get rid of the global variable. And let's go ahead and put it, for instance, inside of main. Might this now work? Well, let me try this now. Python of bank.py enter. That alone did not solve it. I still have an unbound local error. This time, though, it's for a different reason. It turns out now that balance on line 2 is by definition a local variable. A local variable is one that exists in the context of a function, at least in this case. A global variable is the opposite, one that does not, for instance, at the top of my file. So here is another distinction in Python. If you declare a variable in a function like main, just as I've done on line 2 with balance, it is indeed local to that function. Deposit and withdraw do not have access to that same variable. Why? Because it's local to main. And so you would think now we're kind of stuck in this vicious cycle. Well, maybe the solution then is to move balance globally so all 3 functions can access it. But clearly, where we began, as Elena noted, we can't therefore change it. So it turns out the solution to this problem in Python is, ironically, exactly this keyword here. It's a little different, as you might have seen if you programmed before in other languages, but there's indeed a keyword in Python called global that allows you to tell a function that, hey, this is not a variable that's local to you. I mean it to be a global variable that I want you to edit. So if I go back to VS Code here, clearing my terminal window to get rid of that error, let me go ahead and undo the change I just made and put balance back at the top of my file. But this time what I'm going to do is I'm going to inform my 2 functions that need to change the value of balance, that it is indeed global by typing global balance. Again, here as well as here, global balance. I still leave the same lines of code now on lines 13 and 18 that increment and decrement balance, but this now use of keyword global is a little bit of a clue to Python that, oh, OK, it's not a local variable. This is not a bug that you've introduced. You mean for me to edit this variable up above. So now let me go ahead in my terminal window and run Python of bank.py. I'm hoping to see that my balance is 0 plus 100 minus 50 is 50. And indeed, it now is. It starts off at 0 per my first print statement on line 5, but it ends up at 50 total at below that on line 8. Let me pause here to see if now there's any questions on these global or local variables.
What happens when you declare a variable globally and as in the same variable globally and in a function?
A good question. You're always thinking about the so-called corner cases. So if you declare a variable both globally, like at the top of your file, and then an identically named variable inside of a function, same name, the latter will shadow, so to speak, the former. That is, you'll be able to use the latter, that is the local variable, but it will have no effect on the global variable. Temporarily, Python will only know that the local variable exists. So in general, the rule of thumb is just don't do that. Not only might it create bugs in your code because you don't quite change what you intend to change, it's also perhaps non-obvious to other readers as well. Other questions on globals or locals?
OK, what if we decide to add balance as an argument inside the main function?
Yeah, another good instinct, but in this case, that also is not going to solve the problem, because if you pass in a variable like balance to each of the functions and then change it within that function, it's only going to be changing, in effect, a local copy thereof. It's not going to be changing what's outside of those functions. So I think we actually need a better way altogether. And in fact, allow me to transition to perhaps a modification of this same program. Recall that we looked most recently at this notion of object-oriented programming, whereby you can model real-world entities, for instance, a bank, and you can model and encapsulate information about that real-world entity, for instance, like someone's account balance. So let me propose that we actually do this. Let me start from scratch with bank.py, get rid of the global variable altogether, and actually use some object-oriented code. Let me define a class called account to represent someone's bank account. And then let me go ahead and initialize with my init method, which again takes by convention at least one argument called self. Let me go ahead and initialize every person's bank account to some value like 0. Now, how can I do that? Well, I'm going to go ahead and do self.balance equals 0, thereby giving me an instance variable called balance initialized for this account to 0. But I'm going to proactively remember how we also introduced this notion of properties, which might otherwise collide with the names of my instance variables. So just by convention, I'm going to do this. I'm going to rename this instance variable proactively to underscore balance to effectively indicate that it's private, even though that's not enforced by Python. It's just a visual clue to myself that this is something that really I should not, or other code should not touch, just functions in this class. Now let me go ahead and do this. Let me go ahead and define an actual function called balance that really is going to be a property whose purpose in life is just to return self.balance. And I'm going to go explicitly and say this is indeed a property of this class. Now let me go ahead and re-implement those other two functions, deposit and withdraw, but in the confines of this class. So I'm going to say define deposit. It's going to take in an argument self as always, but an additional one, n, a number of dollars or coins to deposit. And how do I now manipulate this? Well, I'm going to do self.underscore balance plus equals n. And now down here, I'm going to do def withdraw self n, just like for deposit. But here, I'm going to do self.balance minus equals n. And now, if I go down below this class, I'm going to go ahead and define myself a main function, just so I can try this now out. I'm going to go ahead and create an account object by calling the account constructor. That is the name of the class with 2 parentheses if I'm not passing in any arguments to init. I'm going to go ahead now and print out, as before, the balance of my account. But to do that, I'm going to access the property of that account like this. And I'm going to go ahead now and say deposit another $100 or coins with deposit 100. And I'm going to go ahead like before and also now immediately withdraw, for whatever reason, 50 of the same. And now I'm going to print one last time balance followed by account.balance, again accessing that property. And for this whole thing to work, of course, I need one of these if name equals underscore main. Then go ahead and call main. Now, before I run this, you'll see that it rather escalated quickly. I had a very simple goal at hand to implement the notion of a bank, and I was able to implement that perfectly fine ultimately by declaring balance to be global, but then to tell each of my functions that it is indeed global. But that's not really the best form of encapsulation we have at our disposal now, right? Per our focus on object-oriented programming, if we're trying to implement some real-world entity like an account at a bank, that's what classes allow us to do. And it allows us to solve that same problem perhaps a little more cleanly, certainly if we're going to accumulate more and more functions or methods over time. So if I didn't make any mistakes here, if I run Python of bank.py and hit enter now, you'll see that it just works just fine. Because in the world of classes in Python, these so-called instance variables are by definition accessible to all of the methods in that class because we're accessing them all by way of that special parameter self. So which way to do it? For a reasonably small script wherein you are simply trying to implement a script that has some global information, like an account balance that you then need to manipulate elsewhere, the global keyword is a solution to that problem. But generally speaking, in many languages, Python to some extent among them, using global variables tends to be frowned upon only because things can get messy quickly. And it can become less obvious quickly exactly where your information is stored, if some of it's up here, some of it's in your function. So generally, the rule of thumb is to use global variables sparingly. Though technically speaking in Python, these global variables are technically local to our module if we were indeed implementing a library and not just a program. So in short, try to use global variables sparingly, but when you do, there is a solution to these same problems. Questions now on globals or our re-implementation of the same idea, but using full-fledged object-oriented programming?
I just would like to ask what this property does.
What this property does. So if I go back to VS Code here, you'll see that this was a technique we looked at in our lecture on object-oriented programming, whereby a property is an instance variable that's somehow protected. It allows me to control how it can be read and written. So in this case, I only have what's called generally a setter. In this case, I only have what's generally called a getter. And there's no mention of the word getter here. This is just what @property means. That function balance will allow me, recall, to use syntax like this, where I can pretend as though balance is indeed, with no underscore, an instance variable, but I can now prevent code like mine in main from trying to change balance. Because I do not have a setter, I would not be able to do something like account balance equals 1,000 to just give myself $1,000 or coins because I have not defined a setter. So again, per our focus on object-oriented programming, these properties just allow me some finer grained control. Some languages allow you to define variables that are, so to speak, constant. That is, once you have set a value to them, you cannot change the value of that variable. And that tends to be a good thing because it allows you to program defensively. Just in case you accidentally or someone else accidentally tries to modify the value of that variable, if you have declared it in some language as a constant, it cannot be changed, or usually cannot be changed without great effort. Unfortunately, in Python, we're again on the sort of honor system here where we have conventions to indicate that something should be treated as though it's constant, but that's not actually enforced by the language. So for instance, let me go back here to VS Code and let me create a new file, for instance, called meows.py. And let's see if we can't implement the notion of a cat meowing on the screen. So I'll do code of meows.py. And in meows.py, let me go ahead, for instance, and implement a very simple program that just has a cat meowing 3 times. So how about this? For I in the range of 3, go ahead and print out quote unquote meow. All right, well, we've seen in the past how we can clean this up a little bit. For instance, if I'm not actually using I might as well Pythonically just change the name of that variable to underscore, even though that has no functional effect here. But here we have this 3 sort of randomly hard-coded, that is typed explicitly into my code. And it's totally not a big deal when your code is only 2 lines. But imagine that this is a much bigger program with dozens or even hundreds of lines. And imagine that one of those lines just has a 3 in there somewhere. Like, you're never going to find that 3 very easily. And it's going to be very easily overlooked by you or colleagues or others that you've hard-coded some magic value like a 3 right there in your code. So it tends to be best practice, not just in Python, but other languages as well. Anytime you have what is essentially a constant, like a number 3 that shouldn't ever change, is to at least let it bubble up, surface it to the top of your code so that it's just obvious what your code's constant values are. And so by that I mean this. At the top of this file, it would probably be a little clearer to colleagues and frankly me tomorrow after I've forgotten what I did today to define a variable like meows and set it equal to 3. And then instead of hard coding 3 here or even lower in a much bigger program, let me just go ahead and pass in that variable's value to my loop so that now it's just kind of obvious to me that meows is apparently the number of times to meow. And if I ever want to change it, the only code I have to change is at the very top of my file. I don't need to go fishing around or figure out what's going to break, what do I need to change. I just know that I can change these constants up at the top. The problem, though, with Python is that Python doesn't actually make variables constant. It's indeed a convention in Python and some other languages to at least capitalize your variables when you want to indicate to the world that you should not touch this. It is constant. But there is literally nothing in my code preventing me from saying, you know what, today I feel like 4 meows instead. Like, that would work. In other languages, though, there's typically a keyword or some other mechanism syntactically that would allow you to prevent line 3 currently from executing so that when you tried to run your code, you would actually get an error message explicitly saying you cannot do that. So Python, again, is a bit more on the honor system when it comes to these conventions instead. Now, it turns out there's other types of constants, quote unquote, that Python typically manifests. And in fact, let me go ahead and change this around a little bit. Let me delete this version of meows. And let me introduce, again, a class from our discussion of object-oriented programming, like a class representing a cat, another real-world entity. Recall that within classes, you can have not just instance variables, but class variables. That is, variables inside of the class that aren't inside of self per se, but they're accessible to all of the methods inside of that class. Here, too, there's a convention, but not enforced by Python, of having class constants, whereby inside of the class, you might want to have a variable that should not be changed, but you just want to indicate that visually by capitalizing its name. So for instance, if the default number of meows for a cat is meant to be 3, I can literally, inside of my class, but outside of any of my defined methods, just create a class variable, all capitalized, with that same value. And then if I want to create a method like meow, for instance, which as an instance method might take in self, as we know. And then I might have my loop here for underscore in the range of, and now I need to access this. The convention would be to say cat.meows to make clear that I want the meows variable that's associated with the class called cat. Then I'm going to go ahead and print out one of these meows. And now at the bottom of my code, outside of the class, let me go ahead and do something like this. Let me instantiate a cat using the cat constructor. Notice this is important. Per our discussion of OOP, the class is capitalized by convention, but the variable over here is lowercase. And I could call it just C or anything else, but I kind of like the symmetry of calling it little cat here and big cat, so to speak, over here. And now if I want this particular cat to meow that default number of 3 times, I can just do cat.meow like this. And that method, meow, is going to, per line 5, access that class constant. But again, it's constant only in the sense that you should not touch that, not that it's actually going to be enforced by the language. All right, let me go ahead then and run this with Python of meows.py. And there it is, 3 of our meows, meow, meow. It turns out that Python is a dynamically typed language. That is to say, it's not strongly typed, whereby when you want an int, you have to tell the program that you are using an int. You don't have to tell the program that you are using a str or a float or a set or anything else. Generally speaking, to date, you and I, when we're creating variables, we just give a variable a name. We frequently assign it using in the equal sign some other value. And honestly, Python just kind of dynamically figures out what type of variable it is. If it's quote unquote hello world, the variable is going to be a str. If it's 50, the integer, the variable is going to be an int. Now, in other languages, including C and C++ and Java and others, it's sometimes necessary for the programmer to specify what types of variables you want something to be. The upside of that is that it helps you detect bugs more readily, because if you intend for a variable to store a string or an integer, but you accidentally store an integer or a string, the opposite, or something else altogether, your language can detect that kind of mistake for you. When you go, for instance, to run the program, it can say, no, you've made a mistake, and you can fix that before your actual users detect as much. In Python 2 here, it's again more of a friendly environment where you can provide hints to Python itself as to what type a variable should be, but the language itself does not strongly enforce these. Rather, you can use a tool that will tell you whether or not you're using a variable correctly, but it's typically a tool you would run as the programmer before you actually release your code to the world. Or if you have some kind of automated process, you can run this kind of tool just like you could reformat or lint your code with some other program before you actually release it to the world. So how might we go about using these so-called type hints? Well, they're documented in the usual place in Python's own documentation. And it turns out there's a program that's pretty popular for checking whether or not your code is adhering to your own type hints. And that program here is called MyPy, and it's just one of several, but this one's particularly popular and can be easily installed in the usual way with pip install MyPy. And its own documentation is at this URL here, but we'll use it quite simply to check whether or not our variables are indeed using the right types. So how can we go about doing this? All right, let me go back here to VS Code, clear my terminal window, and in fact erase meows.py as it currently was, and let's implement a different version of meows that quite simply has a function called meow that does the actual meowing on the screen, and then I'm just going to go ahead and call that function down toward the bottom. I'm not going to bother with a main function just for simplicity so that we can focus, as always, only on what's new. So here we are defining a function called meow. It's going to take a number of times to meow, for instance, n for number. And inside of this function, I'm going to do my usual for underscore in the range of n, go ahead and print quote unquote meow. So based on our earlier code, I think this is correct. I've not bothered defining the variable as I. I'm instead using the underscore because I'm not using it anywhere. But I think I now have a working function whose purpose in life is to meow 0 or 1 or 2 or 3 or more times. Well, let's use this function. Again, not bothering with main. I'm just going to keep my function at the very top because there's only one. And I'm going to write my code here on line 6. So I'm going to ask the user for a number. And I'm going to go ahead and prompt them in the usual way for that number of times to meow. And now I'm going to go ahead and call meow on that number. Now, some of you might see what I've already done wrong, but perhaps I myself don't. So let me go into my terminal window and run Python of meows.py, the goal being to prompt me This seems to be working. I'm going to type in 3. And I would expect now the meow function to print out meow 3 times. Enter. But no, there's some kind of type error here. Stir object cannot be interpreted as an integer. Why might that be? Why might that be?
Because the input function returns a string instead of an integer.
Exactly. The input function returns a string or a stir, not an int. So in the past, of course, our solution to this problem has just been to convert the string to an int by using the int function. But now let me start programming more defensively so that, honestly, I don't even find myself in this situation at all. Let me go ahead and do this. Let me add what's called a type hint to my function that explicitly specifies for meow what type of variable should be passed in. I'm going to go ahead now and change the very first line of my code in my function to specify that n colon should be an int. And this is a type hint. The fact that I've added a colon, a space, and the word int is not creating another int or anything like that. It's just a hint, an annotation, so to speak, to Python that this variable on the left called n should be an int. Now, unfortunately, Python itself doesn't care because, again, these type hints are not enforced by the language, and that's by design. The language itself in the community prefers that Python be dynamically typed, not so strongly typed as to require these things to be true. But if I run meows.py, type in 3 again, the same error is there. But let me go about trying this MyPy program, an example of a program that understands type hints, and if I run it proactively myself, can find bugs like this in my code before I, or worse, a user, actually runs and encounters something cryptic like this type error here. Let me clear my terminal window, and this time run mypy space meows.py. So I'm going to run mypy on my program, but I'm not running Python itself. When I hit enter, we'll see this. All right, we see now that mypy found apparently an error on line 7. Error, argument 1 to meow has incompatible type stir expected int. So it's still an error message, but mypy is not a program that my users would use. This is a program that you and I as programmers would use. And because we have run this code now, before we, for instance, released this program to the world, I can now see, even before the code is called or run, oh, I seem to be using my argument to meow wrong. I had better fix this somehow. Well, I can actually go about adding type hints even to my own variables here so as to catch this another way too. If I know on line 6 that I'm creating already a variable called number, and I know already that I'm assigning it equal to the return value of input, I could give mypy and tools like it another hint and say, you know what, this variable called number should also be an int. That is to say, if I now start getting into the habit of annotating all of my variables and arguments to functions, maybe mypy can actually help me find things quite quickly as well before I get to the point of running Python itself. Let's go ahead and try this again. Mypy of meows.py and hit enter. And this time, notice that mypy actually found the mistake a little more quickly. Notice this time it found on line 6 that error, incompatible types in assignment, expression has type stir, variable has type int. So before I even got to the point of calling meow, line 6 via this type hint, when used and analyzed by mypy, has helped me find, oh, wait a minute, I shouldn't be assigning the return value of input to my variable called number in the first place. Why? MyPy has just pointed out to me that 1 returns a stir. I'm expecting an int. Let me fix this now instead. All right, so let me clear my terminal window, and now let me do what most of you were probably thinking I should have done in the first place after all of these weeks. But now let me go ahead and convert the return value of input to an integer. For today's purposes, I'm not going to try to catch any exceptions or the like. We're just going to assume that the user types this in properly. And now let me go ahead and run mypy of meows.py, having not only added 2 type hints to my argument, to my function, to my variable down here on line 6, and I've also now fixed the problem itself. Let me go ahead and run mypy, and success. No issues found in one source file. Now, it's more reasonable for me to go and run something like Python of meows and just trust that when I type in 3, at least I'm not going to get a type error. That is, I didn't mess up as a programmer with respect to the types of my variables. Why? Because when I wrote the code in the first place, I provided these annotations, these hints that inform tools like MyPy that my intention had better line up with what the actual code does. Let me pause here and see if there's now any questions on type hints or MyPy.
Is it common, or how common is it for those to be used, or is it just that it's more used in more complex code where it's more difficult to ensure that you're actually using the correct type in the way that you're using the variables?
It's a good question, and it's rather a matter of opinion. Python was designed to be a little more versatile and flexible when it comes to some of these details, partly for writability, to make it easier and faster to write code, partly for performance, so that the program like Python doesn't have to bother checking these kinds of details. We can just get right into the code. The reality, though, is that strong type checks do tend to be a good thing for the correctness of your code. Why? Because programs like MyPy can find, before your code is even run, if there's already known to be an error, and it tends to be good for defensive programming. So the situation essentially is that within the Python ecosystem, you can annotate your types in this way. You can use tools to use those type hints. But to date, Python itself does not enforce or expect to enforce these conventions. In larger code bases, in professional code bases, commercial code bases, probably, depending on the project manager or depending on the engineering team, they may very well want themselves to be using type hints. Why? If it just decreases the probability of bugs. In fact, let me propose now that I imagine a situation where instead of expecting that meow prints meow, meow, meow some number of times, suppose that I accidentally assume that the meow function just returns meow some number of times. We saw, for instance, when focusing on unit tests, that it tends to be a good thing to have functions that return values, be it an int or a string, rather than just having some side effect, like printing things out themselves. So perhaps I'm still in that mindset, and I've just assumed mistakenly for the moment that meow returns a value like meow or meow meow or meow meow meow, a big string of some number of meows, rather than just printing it itself, as it clearly does at the moment on line 3. And therefore, suppose that I accidentally did something like this. Rather than just getting the number and passing it to meow, suppose I did this. Suppose I declared a number of a new variable called meows, the type of which I think should be stir. And suppose, again, I assume accidentally that meow returns to me a string of those meows so that I myself can then print them later. This would be a little more conducive, arguably, to testing my meow function. Why? Because I could expect that it's returning meow or meow meow or meow 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 separated by new lines, returning a stir that I could then assert equals what I expect it to be in something like a unit test. I'm not going to bother writing any unit test now, but let's just suppose that's the mindset I'm now in. And so on line 7, I'm assuming that I want to assign the return value of meow to a new variable called meows, which I've annotated with this type hint as being a stir, just so we can see another variable. This one's not an int, but a stir instead. Well, let me go ahead and run this code now. Python of meows.py, enter, typing in 3, and you'll see a curious bug, meow, 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 none. Well, why is that? Well, it turns out at the moment, my meow function only has a side effect. It just prints out meow some number of times. It doesn't explicitly return a value, as it would if there were literally the return keyword there. By default, then, when a function in Python does not explicitly return a value, its implicit return value is, in effect, none. And so what we're seeing here is this. On line 8, because I'm assigning the return value of meow, which is none, to my meows variable, line 3 is what's still printing meow, 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 and line 8 is what's now incorrectly printing none, because I accidentally thought that meow returns a value, but it doesn't, so its return value is effectively none, so I'm printing very weirdly the word none at the bottom. So how could I go about catching this kind of mistake too? Like, I might make this mistake, but maybe with less frequency if I'm in the habit of annotating my code with this new feature called type hints. What you can do here is this. Let me clear my terminal window to get rid of that artifact. And up here, let me additionally specify with some funny looking syntax that my meow function actually by design returns none. So you literally use this arrow notation in Python when hinting what the return value of a function is. You would do this. After the parentheses, a space, a hyphen, a greater than symbol, like an arrow, and then another space, and then the type of the return value. For now, it's indeed going to return none. But now, at least, I can catch it like this. If I now run not Python, but MyPy on my code, which would be a habit I'm now getting into if using type hints, check that I'm using all of my types correctly before I even run my program, we'll see that now MyPy has found on line 7 that meow, quote unquote, does not return a value. And MyPy knows that because I have proactively annotated my meow function as having none as its return value. So now MyPy can detect that. I should now realize, oh, wait a minute, I'm being foolish here. Meow clearly does not return a value. I should not be treating it like it does on line 7. Let me go about actually fixing this now. So how do I go about fixing this? Well, let's practice what we preached in our focus on unit tests, having a function like meow not have side effects like printing itself, but let's have it return the actual string. And I can actually do this kind of cleanly. Let me clear my error message in my terminal window here. Let me get rid of the loop here. Let me say this time that, OK, fine, meow is going to return a value, an actual str or string. So I've changed none to str. And now I can implement this in any number of ways, maybe even using a loop. But recall that we have this syntax in Python, which will, I think, solve this problem for us. If I want to return a string of n meows, what I can actually do, recall, is this. Return, quote unquote, meow, \n times that number n. So it's kind of a clever one-liner, avoids the need for a for loop or something more involved than that, to just say multiply meow \n against itself 3 times, or n times, in this case, in general, so that I get back a big string of 0 meows, 1, 2, 3, or many more meows instead. I think now my code on line 6 is actually correct. Now I've changed meow to behave the way I was pretending to assume it always worked. So I'm storing in meows, plural, a variable that's of type str, because now meow does have a return value of type str itself per this type hint as well. All right, let me go ahead now and print meows. But because each of my meows comes with a trailing new line, the \n, I'm going to proactively fix what would be a minor aesthetic bug. And I'm just going to avoid outputting an extra new line at the end of those 3. So if I run python of meows.py now, type in 3, there's my meow, meow, meow. And now, no mention of none. Questions now on type hints and these annotations in MyPy, and using them to defensively write code that just decreases, hopefully, the probability of your own bugs.
In the return, there is a double quotes that have meow/n. Why the program don't take it as a string?
Why does the program not take it as strange?
Sí. Yeah.
So recall that early on in the class, we looked at plus as a concatenation operator that allows you to join a string on the left and the right. Multiplication is also an overloaded operator for strings, whereby if you have a string on the left and an int on the right, it will multiply the string, so to speak, by concatenating or joining that many meows all together. So this is a feature of object-oriented programming, an operator overloading, as we saw it in the past. Other questions on type hints or MyPy?
Can we not typecast this data type of this variable number?
No, you still, and let me correct the terminology. It wouldn't be called typecasting in this context because it's not like C or C++ where there's an equivalence between these types. You're technically converting on line 5 a str to an int. You do still have to do this because MyPy, for instance, would yell at you if you were trying to assign a str on the right to an int on the left. You must still use the int function. Int itself is still a function. It's not a type hint. But the word int is being used in another way now in these type hints. So this int is still a function call, as it always has been. This syntax on the left is another use of the keyword int, but in the form of these type hints. So you still have to do the conversion yourself. All right, let me propose that we transition to another feature of Python that's worth knowing, especially since it's one that you'll see in the wild when you see code or libraries that other folks have written, namely something known as a docstring or document strings. It turns out in the world of Python, there is a standardized way per another PEP, Python enhancement proposal, this one 257, that essentially standardizes how you should document your functions among other aspects of your code. And so for instance, let me go back to my meows.py file here, and let me propose that we now start documenting this code too, so that I know what the meow function does. And in fact, the standard way of doing this, using docstring notation, would be as follows. To comment this function, not above it, as you might be in the habit of doing with code in general, but actually inside of it. But instead of commenting it like this, with the usual hash comment sign, like meow n times, it turns out that when you're formally documenting a function, like meow in this case, you don't use regular inline comments, so to speak. You use this syntax instead. You use triple quotation marks, either double or single. Then you write out your comment, meow n times, and then you write the same again at the end. So either 3 double quotes at the start and the end, or 3 single quotes at the start and the end. And Python has built into it certain tools and certain assumptions that if it detects that there is a comment using this docstring format, triple quotes on the left and the right, it will assume that that's indeed the documentation for that function. And it turns out in the Python ecosystem, there's a lot of tools that you can then use to analyze your code automatically, extract all of these document strings for you, and even generate web pages or PDFs of documentation for your own functions. So there's these conventions via which, if you adhere to them, you can start documenting your code as for other people by generating automatically the documentation from your own code without writing something up from scratch manually. Now, it turns out if your function does take arguments and perhaps does a bit more, there are multiple conventions for how you can document for the human programmers that might be using your function, whether it's you or a colleague or someone else on the internet, to actually use these docstrings to standardize the information therein. So you might see this instead. Using these same triple quotes above and below now, you might see your one sentence explanation of the function, meow n times. Sometimes, depending on the style and use, it might actually still be on the first line, but with a blank line below it. But I'll keep everything uniformly indented. And this is a convention used by some popular Python documentation tools as well. You would say syntax like this: param n colon, and then a description of what n is, number of times to meow. Then colon type n colon int, which just indicates that the type of n is an integer. Then if this function could actually raise an exception, you can document that too. And actually, it's not really, well, it's arguably my mistake here. If n comes in as an argument and is not in fact an int, maybe it's a float or a string or something else, the multiplication sign here is not going to work. It's not going to multiply the string. It's going to trigger what I know from experience to be a type error. So I'm going to go ahead and proactively say in my own documentation that this function technically, if you use it wrong, could raise a type error, even though I'm hinting up here with this annotation that you should pass in an int. Again, Python doesn't enforce that. So if you pass in a float, this might in fact raise this function a type error. And so that might happen if n is not an int. And then lastly, I might say, for clarity's sake, for other programmers, this function returns a string of n meows, 1 per line. And the return type of that value, our type, is going to be stir. Now, all of this syntax here, as I've used it, is not Python per se. This is a convention known as restructured text, which is a form of markdown-like language that's used for documentation, for websites, for blogs, and even more. But it's one of the popular conventions within the world of Python to document your own functions. So this does not have anything to do fundamentally with type hints. Type hints are a feature of Python. What I'm doing here is just adhering to a third-party convention of putting in between a Python docstring from the start to the end, a certain standard format so that these third-party tools can analyze my code for me, top to bottom, left to right, and ideally generate documentation for me. It can generate a PDF, a web page, or something else so that I or my colleagues don't need to not just only write code, but also manually create documentation for our code. We can keep everything together and use tools to generate the same for us. Any questions now on these doc strings, which again are a convention of documenting your own code, often following some standard syntax?
Yeah, so when you say like you would document it and put it in a PDF, is the purpose of doing this to kind of like publish it and share your function so other users can use it?
Absolutely. In the past, when we have installed some third-party libraries, for instance, Cowsay a few weeks back, recall that I showed you what functions it had. But if you read the documentation, you might actually see that it was documented for us by the author of that program. Now, I don't believe they were using this particular syntax, but it was definitely useful for you and me to be able to read some web page or PDF telling us how to use the library, rather than wasting time reading through someone else's code and trying to infer what functions exist and how to use them. It just tends to be much more developer friendly to have proper documentation for our own code or libraries as well. Other questions?
Yeah, when with docstrings, when it's used to generate like a PDF or whatever, does it include any of the code? So if you're referencing in your comment, if you're referencing the code and the comment itself might not make sense without seeing the code, do these include it?
Short answer, you can do that. Not in the convention I'm using here, but there's actually a clever way to write in your doc strings sample inputs to your functions and sample outputs for your functions. And if you use a different tool that we've not discussed, that tool will run your code using those sample inputs. It will check that your outputs match your sample outputs. And if not, the program will yell at you saying you've got a bug somewhere. So this is just another way where you can use doc strings to not only document, but even catch errors in your code. This has been a lot, and there's a bit more to go. Why don't we go ahead here and take a 5-minute break, and when we resume, we'll take a look at yet another feature of Python, yet another library to write code faster. All right, suppose we want to modify this meows program to actually take its input not from the input function in the blinking prompt, but from the command line. Recall in our discussion of libraries that you could use something like sys.argv to get at command line arguments that a human has provided when you're running your program. So why don't we whip up a version of meow that uses command line arguments instead of, again, input. So I'm going to go ahead and delete what we've done here thus far. And let me propose that we import sys, as we've done in the past. And let's do this. How about if the user does not type any command line arguments, then my program will just meow once, just so that it does something visually interesting. Otherwise, let's also give the user an option to specify how many times I want the cat to meow. So let's start simple. Let's first of all go ahead and do this. If the length of sys.argv equals 1, that is, the user only typed the name of the program and nothing else after the in their command, then let's go ahead and just print out one meow like this. Else, for now, let's go ahead and print out something like this. Else, go ahead and print out, let's say, usage for the program, which will be usage of meows.py, just so that the user knows that the program itself is called meows.py. All right, now let me go down to my terminal window and start to type Python of meows.py. And at this point, notice that the length of sys.argv should indeed be 1. Why? Well, Python, the name, doesn't end up in sys.argv at all, ever. But meows.py, the name of the file, does. And it's going to go in sys.argv 0. But that's only one element, so the length of this thing is 1. There's nothing more to the right. So when I hit enter now, we should see indeed 1 meow. If I don't cooperate, suppose I do something like meows3, enter, then I'm going to see a reminder that this is how you use the program. And this is a common convention to literally print out the word usage, a colon, then the name of the program, and maybe some explanation of how to use it. So I'm keeping it very simple. But let's be a little fancier. What if I really wanted the user to type in, maybe not 3, but something more sophisticated? And in fact, when controlling programs from the command line, it's very common to provide what are often called switches or flags, whereby you pass in something like -n which semantically means this number of times, then often a space, and then something like the number 3. This still allows me to do other things at the command line if I want, but the fact that I've standardized on how I'm providing command line arguments to this program with -n3 is just a more reliable way now of my program knowing what does the 3 mean. It's a little less obvious. If I just do meows.py space 3, well, what does the 3 mean? At least with syntax like -n3, especially if you've read the documentation for this program, ultimately, oh, -n means number of times, got it. It's a way of passing in 2 additional arguments, but that have some relationship between them. So how do I modify my program to understand -n3? Well, if I'm using sys like this, I could do this. Elif the length of sys.argv equals this time 3. Because notice there's 1, 2, 3 things at my prompt. So sys.argv 0, 1, and 2, 3 things total separated by spaces. If it equals 3, and let's be safe, and sys.argv bracket 1 equals -n, then let's go ahead and do this. Let's go ahead and convert sys.argv of 2 to an integer and assign it to a variable, for instance, called n. And then let's go ahead and do this. For underscore in the range of n, let's go ahead and print out some of these meows. Now, there's still an opportunity maybe to consolidate my print lines with meow, but for now, I'm going to keep these ideas separate. So I'm going to handle the default case with no arguments up here as before. And now, more interestingly, I'm going to do this to be clear. I'm going to check if the user gave me 3 command line arguments, the name of the program, -n, and a number. If indeed the second thing they gave me in sys.argv of 1 equals -n, then I'm going to assume that the next thing, sys.argv of 2, is going to be an integer, and I'll convert it to such and store it in this variable n. And now, just using a loop, I'm going to print out meow that many times. All right, so it's kind of a combination of our earlier focus on loops, our earlier focus on command line arguments, just creating a program that, allow me to claim, is representative of how a lot of command line programs work, even though we've typically not used many like this. But it's very common to configure a program, one, you're about to run it at the command line, with something like these command line arguments like -n or something else. Now, I'm going to go ahead and hit enter. And I think I should see, indeed, 3 meows. By contrast, if I do 2 at the end, I should see 2 meows. If I do 1, I should see 1 meow. And frankly, if I just omit this altogether, I should see 1 meow as well, because that was my default case earlier. And now let me allow us to assume that this program eventually gets more complicated, right? Let's imagine a world where I don't want to support just -n. Maybe I want to support -a and -b and -c and -d and a whole lot of others. Or heck, at that point, I should maybe give them words. So maybe it's --number. It's indeed a convention in computing typically to use single dashes with a single letter, like n, but use double dashes if you're actually using a whole word like number. So the command line argument might be -n, or maybe it's --number. But you can imagine just how complicated the code gets if now you want to support -n, -a, -b, -c, and so forth. You're going to have to be checking all over the place. And what if they come in a different order? You're going to have to check, is -n first, or is it second, or is it third, or is it fourth? I mean, this just becomes very painful very quickly just to do something relatively simple like allow the user to pass command line arguments into your program. Well, this is why, as always, there exist libraries. And another library that comes with Python that's probably worth knowing something about is this one here called argparse. In fact, with a lot of the tools I myself or CS50's team writes in Python, we very frequently use argparse whenever they are more complicated than a lot of our class demos and a little more similar to this one where we want to allow the user to pass in configuration options at the command line. And by supporting things like -n or -a or -b or -c, argparse is a library that, per its documentation, just handles all of this parsing, so to speak, this analysis of command line arguments for you automatically, so you can focus on writing the interesting parts of your program, not the command line arguments part. So how might we use this? Well, let me go back to VS Code here. Let me clear my terminal window. And let me propose that I rewrite this using not sys, but actually using argparse. And I'm going to start a little simple and then build back up. So let me throw all of this away for now and instead import argparse. Argparse stands for argument parser. To parse something means to read it, kind of pick it apart, to analyze it. So this is indeed going to do just that for me. Now let me go ahead and do this. And for this library, it's helpful to know a little object-oriented programming like we all now do. I'm going to create a variable called parser. I could call it anything I want. I'm going to set it equal to the return value of argparse dot argument parser with a capital A and a capital P, a constructor for a class called argument parser that comes with Python itself within this library here. Now, I'm going to configure this argument parser to know about the specific command line arguments that I myself want to support in my program. So I'm going to do this. Parser.add_argument. So that's apparently a method in the parser object. I'm going to add an argument of -n. Easy enough. Now I'm going to go ahead and actually parse the command line arguments. I'm going to do args, or I could call the variable anything I want, parser.parse args. And by default, parse args is going to automatically look at sys.argv for me. I don't need to import sys myself. I can leave the argument parser its code to import sys, look at sys.argv, and figure out where -n or anything else actually is. And what's nice now, because this line of code here results in the parser having parsed all of the command line arguments, I now have this object in this variable called args, inside of which are all of the values of those command line arguments, no matter what order they appeared in. Not such a big deal when I've only got one, because it's only going to go in one place at the end. But if I've got -n, -a, -b, -c, you could imagine them being in all different orders. They definitely don't have to be alphabetical. The user should be able to type them in any order they want. That's better for usability. Argparser is going to figure all of that out for me. And all I have to do now is this. If I want to iterate over that many numbers of arguments, and that many meows, rather, I can do this. For underscore in the range of the int conversion of args.n. So dot is the syntax we kept using to access things like properties inside of an object. And that's what args is. It's an object returned by the parseargs function for me. I'm going to go ahead now and print out, quote unquote, meow this many times. So it's not super simple. Like, these are 3 new lines of code I need to write and rather understand. But it's already a little simpler and more compact than my if and my elif and my ors and my ands and all of that Boolean logic. It's handling a lot of this for me. So if I didn't make any mistakes, let me run Python now of meows.py, enter. And I did make a mistake here. I did make a mistake. What's wrong here now? What's wrong? Well, I definitely didn't run it the way I intend. So -n3, enter. So it does work. But if I don't cooperate, this actually seems to be a worse version. If I don't pass in -n and a number, it just errors with a type error. Int must be a string. None is what came back. So there's clearly an error here. But the library is more flexible. I can actually provide some documentation on how to use this thing. So how do I know how to use this? Well, typically, it's conventional in Python and in a lot of programming environments to run a program with a special argument, -h or --help. And almost always, I will claim, you'll then see some kind of usage information. Indeed, that's what I'm looking at now. I just ran Python of meows.py space -h. I'll do it again. Let me clear my screen and this time do --help in English. Enter. And I see the same thing. It's not very useful at the moment. It just shows me what the usage is up here. And this is kind of interesting. This is a standard syntax in computing, and we've kind of seen it in Python's documentation before. This just means that the program's name is, of course, meows.py. Square brackets, as almost always in documentation, means it's optional. So I don't have to type -h, but I can. I don't have to type -n and another value, but I can. And then down here is some explanation of these options, and more verbosely showing me that I can also do --help and not just -h. But this is so generic. This has nothing to do with my program. This is not going to help my users when I actually release this software for the world. So let me go ahead and improve it. Let me add a description to my argument parser that the humans will see. Meow like a cat, quote unquote, is going to be the value of this named parameter called description. And let me also add a help parameter to my -n argument that just explains what -n means. Number of times to meow, quote unquote. I'm not going to change anything else, but I am going to go back to my terminal window and run Python of meow. I'm going to run Python of meows.py -h, or equivalently --help. And now notice that this is a little more user-friendly. If I scroll up, we still see the same usage, but there's a quick sentence in English of explanation that this program meows like a cat. And if I look at the options now, oh, that's what n means. It's the number of times to meow. And this capital N, a meta variable, if you will, is just indicating to me that I need to type a number by convention after the lowercase -n. So it would be nice, though, all that said, if my program still didn't just break when I run it without any command line arguments, right? Ideally, my program would handle this just like my manual version did when I used sys.argv myself. So we just need to add a little more functionality to this library. And if I read the documentation, I'll see that add argument takes yet another named argument if you want. You can specify a default value for -n, for instance, 1. And I'll do that there. And you can further specify that it's got to be an int. And what this will additionally allow me to do is if I tell argparser to make sure that the value of -n is an int, I don't need to do the conversion manually. I can just trust down on line 7 that when I access the property called n inside of my args object, it's going to be automatically an int for me. And again, this is the value of a library. Let it do all of the work for you so you can get back to focusing on the interesting project at hand, whatever problem it is you're trying to solve. Like in this case, granted not that interesting, but meowing like a cat. Let me go ahead now and run Python of meows.py and hit enter this time. No arguments. And now it meows. Why? Because I specified that if I don't, as a user, specify -n, it's going to have a default value of 1, apparently. And I don't have to convert that value from a str to an int because I told argparser, please just make this an int for me. Any questions now on argparse, or really this principle of just outsourcing the commodity stuff, the stuff that everyone's program eventually needs to do so that you can focus on the juicy part yourself?
What does args.n contain?
What does args.n contain? It contains the integer that the human typed after a space after -n. A good question. Other questions?
Yeah, did when you specify the type for the argument, what happens if, does that basically handle the exception if the user inputs a string in this case?
A really good question. Suppose that the human does not type a number and therefore not an int. Well, let's see what happens. So Python of meows.py -n dog, where dog is obviously not a number. Enter. And voila, we see an automatically generated error message. A little cryptic, admittedly, but I'm seeing a reminder of what the usage is and a minor explanation of what is invalid about this. And again, this is what allows you, this is what allows me to focus on writing the actual code we care about and just letting the library automate some of this stuff for us. All right. Well, allow me to propose now that we take a look at one other feature of Python that we've seen before, but it turns out we can use it even more powerfully as our programs become more sophisticated and the problems we're trying to solve themselves become more involved. Let me go ahead and return to VS Code, closing out meows.py and creating a new file, for instance, called unpack.py. So code of unpack.py. And let me just remind us what we mean by unpacking, because this is actually a feature of Python that we've seen before. For instance, suppose that I write a program that prompts the user for their name, like David space Malin. Wouldn't it be nice if we could sort of split the user's name into 2 separate variables? And when we've done this in the past, we've done it in a few different ways, but one of them involved unpacking a single value that comes back from that, like a list or some other data structure, and putting it immediately into 2 variables. So let's do this here. Let me go ahead and call the input function, asking someone, what's your name, ? Then let me go ahead and just split a little naively on a single space. So I'm assuming that the only users at the moment are people like me, David space Malin, no middle names, no multiple names. It's just 1 and 2, which itself could be buggy for other users. But for now, I'm keeping it simple just to remind us that I can now unpack that return value with something like first underscore last equals the return value of input. And now I can go ahead and do something like this, like printing out with an F string, hello, comma, and then in curly braces first, if I just want to greet myself or any other user as hello, David, without the last name. And frankly, if I'm not using the last name, recall that a Python convention is just to name it underscore to make clear that you know you're not using that value. But it does need to be there because you're unpacking two values at once. So if I run this, it won't be all that unfamiliar. I'm just going to run now Python of unpack.py. I'll type in David Malin, which has a single space, and there we have it, hello, comma, David. Well, it turns out that there's other ways to unpack values, and there's other features that Python offers, especially when it comes to defining and using functions. And this is slightly more intermediate functionality, if you will, that's useful because you can start to write even more elegant and powerful code once you get comfortable with syntax like this. So let me go ahead and propose that we not just play with hello names anymore, but instead do something maybe involving some coinage again. So maybe not dollars and cents, but maybe again, as in the past, some galleons and sickles and knuts, among which there's a mathematical relationship as to how many of those in the wizarding world equal each other. And let me go ahead and do this. Let me define a simple function called total that just tells me the total value of someone's vault in Gringotts, the wizarding bank, based on how many galleons, sickles, and knuts that they have, which again are currencies from the wizarding world as opposed to our actual human world. So this total function might take a variable like galleons and sickles and knuts like this, and then it's going to return the formula, which I admittedly had to look up myself. And it turns out that the formula for converting galleons and sickles to knuts would be this: galleons times 17 plus sickles, then times all of that by 29, and then add in the individual knuts. Not sure in what detail this came up in the books or movies, but here we have it, the official formula. All right, now let's go ahead and do this. Let me go ahead and call the total function with just some sample inputs. Suppose that someone like Harry has 100 galleons, 50 sickles, and 25 knuts. Let me go ahead and print that out on the screen. All right, well, if total returns an integer, which I think this arithmetic expression will do, let me go ahead and pass the return value of total to print. And then just for clarity, let me write knuts at the end so I know that the unit of measure here is indeed knuts in total. All right, now let me go ahead in my terminal window and run Python of unpack.py and hit enter. And it turns out, mathematically, that if I got my math correct, 100 galleons plus 50 sickles plus 25 knuts equals in total 50,775 knuts. Just avoiding having to use our own human currency here. But I'm not doing anything along the lines of unpacking, at least just yet. Let me propose now that I do this. Just for the sake of discussion, let me propose that I leave the total function as is, but let me go ahead and just store all of my coins in a list. So coins in order from left to right, 100, 50, 25. Just because for whatever purposes in this story, I have all of my coinage in a list in this order. Kind of a purse or wallet of sorts. Well, how can I pass this in? Well, I'm not going to hard code the same values twice. Just for the sake of discussion, how could I pass in the individual elements of a list to my total function? Well, of course, I could treat this list, as I always do, using numeric indices by doing coins bracket 0, coins bracket 1, coins bracket 2. So this is old school stuff with lists. If I've got a list called coins and there's 3 elements, the indices or indexes of those elements are 0, 1, and 2, respectively, from left to right. So all I'm doing here now is passing in the first element from that list as galleons, the second element of that list as sickles, and the third element of this list as my knuts. And that lines up with, of course, the signature of this function, which, as total, expects that I've passed in those 3 things in that order, left to right. All right, let me go ahead and run, just to make sure I haven't broken anything, unpack.py and hit enter, and the math still checks out. But this is getting a little verbose, and wouldn't it be nice if I could just pass the list of coins to this total function? Wouldn't it be nice if I could just say something like this, coins? But let me pause and ask the group, why would this not actually work as is? It technically is passing in all 3, but why would I get some kind of error when I run this? Eric?
Because you are passing a list to galleons.
Yeah, I'm passing a list to galleons and nothing for sickles and knuts. And notice those don't have default values. There's no equal signs on that first line of code, which means Python's not going to know what value should be assumed there. So it just seems like it's not going to work. Plus, it's the wrong type, as Eric notes. It's a list, and it's not an integer as it was before. So let's actually run this incorrect version, Python of unpack.py, enter, type error. And that is probably what you might expect. Like I'm messing up with the types here, and I'm required to pass in 2 positional arguments, sickles and knuts, that were not even passed. So I've definitely erred here. But it certainly seems unfortunate if the only solution to this is to do what I previously did, which is index into the first element, index into the second element, index into the third. Like you can imagine, with bigger, fancier functions that take even more arguments, this is going to get very verbose and honestly very vulnerable potentially to just mistakes, typos on my part. But here too is where you can do what's known again as unpacking a value in Python. Right now a list is kind of packed with multiple values. My current list has these 3 values, 100, 50, and 25 respectively. But they're all packed up in this one list. Wouldn't it be nice if I could unpack that list just like I previously unpacked the return value of the stir class's split function into multiple things too? And indeed, I can do just that. Python actually allows me to pass in not coins, but star coins. So if you use a single asterisk at the beginning of your variable, that will unpack it. And it will take one sequence, in this case, coins of size 3, and explode it, if you will, unpack it into 3 individual arguments. No commas are needed. Python just handles this for you. But the effect of passing in star coins is to pass in the individual members of that list, which in this case are going to be 100, 50, and 25 respectively, which is perfect because now it's going to line up with galleons, sickles, knuts respectively. So now when I run Python of unpack.py, we're back in business. And the math checks out, but I've kind of cleaned up my code by just introducing this new symbol, which we've used, of course, in other contexts for multiplication and the like. But now it's also used for unpacking in this way. Questions on what we've just done? It's a single operator, but it's already quite powerful because it allows us to take a data structure and unpack it and pass it in individually.
Does that work for tuples, sets, dictionaries as well?
Tuples, yes. Sets, I don't know. Rungshin, I don't know if order is preserved. No. Oh, is that no, it does not? Or you know you're checking? Order's not preserved. So it wouldn't work with set? Does not work with set. Does not work with set. Sorry, I'm verbally Googling here just to save us some keystrokes. So it would work for enumerations where order is indeed preserved. And we'll see another example in a moment where it actually can be used in a different way for dictionaries, which nowadays do preserve order. Other questions on unpacking in this way?
Yes. Hi.
Hello.
Can you use unpacking to get the value, for example, 10 plus 50 plus 25 instead of a for loop and then result plus?
Short answer, no. If you want the individual values, you should be just indexing, in this case, into those specific locations. This is returning multiple values, the equivalent of a comma-separated list. So you would use the earlier approach if you cared about the individual locations. How about one other question on unpacking?
What if we have declared, we declare some default values, and if you use this asterisk coins, will it overwrite or will it skip it?
Good question. If I heard you right, what if, for instance, the list has 4 values, like this here, and you're still unpacking it when it's only 3 that's expected? Well, let's try it. Python of unpack.py, enter, another type error. This time it takes 3 positional arguments, but 4 were given. So the onus is on us as the programmer not to do that in this case. So potentially fragile, but avoidable if I'm controlling the contents of this list. In fact, let me propose now that we take a look at another variant of this, whereby we use not just positional arguments, whereby we trust that the first is galleons, the second is sickles, the third is knuts. Suppose that we actually passed in the names, as we're allowed to do in Python, and then technically we could pass them in any order, and Python would figure it out using named parameters instead. Well, how might I do this? Well, it's going to be a bit of a regression at first, so let me get rid of this list here. Let me change this now to just manually pass in the values I care about. Galleons, I want to still equal 100. Sickles, I want to equal 50. And knuts, I want to equal 25. So this is old school parameter passing. It's no longer positional. I'm explicitly specifying the names of these arguments, but that's just going to work because that's exactly what the names of these parameters are in my total function as before. Let's make sure I nonetheless did not break anything. Let's run Python of unpack.py, enter, and there we have it, still 50,775 knuts. Well, once you start giving things names and values, that probably should bring to mind one of our most versatile data structures in Python and even other languages, that of a dictionary. Remember that a dictionary is just a collection of key value pairs, names and their respective values. So this kind of opens up an opportunity. What if I did this? What if I actually had, for some reason in my program, a variable as before called coins, but instead of making it a list of 3 values like before, what if it's a proper dictionary? So what if it's galleons, quote unquote, colon 100 for 100 of those, sickles, quote unquote, and 50 of those, and knuts, quote unquote, 25 of those, each of those separated by colons. And let me fix my square brackets to this time be curly braces, which recall is the symbol we use for dictionaries or dict objects in Python. So now I have a dictionary called coins, not a list. It's a collection of keys and values, 3 keys, galleons, sickles, knuts, and 3 values, 100, 50, 25 respectively. If I were to now pass these individual values into my total function, I could do it as always with my dictionary. So I'm doing it old school now. Coins is the name of my dictionary. I index into it not with numbers like with lists, but with words. So galleons, strings like this, coins, quote unquote, sickles in square brackets there. And then lastly, coins, square brackets, quote unquote, knuts. So it's verbose again. Like this is not maybe the best road to go down, but we'll backpedal in a moment. This is just how, if you happen to have all of your coins stored in a dictionary, you could pass the galleons, sickles, and knuts into your function respectively. Let's make sure I didn't break anything. Let's rerun Python of unpack.py, and we're still good. Now, how could we get to a situation like this? Well, as always, imagine this program's a little longer than this one here, and somehow you're using a dictionary, maybe just to keep track of someone's purse or wallet, like how many coins of each type that they have, and as such, it's perfectly reasonable to use a dictionary. But then you want to print out the total, and darn it, if that total function does not expect a dictionary, so you cannot just do something nice and simple like pass in coins for reasons we saw earlier. That would be a type error. Total expects 3 arguments, 3 integers. You can't just pass in a dictionary. But if that's the data structure you're using to store the person's purse or wallet, well, it's kind of unfortunate that we have this clash between these data types. Well, here's what we can do. We can't pass in coins because watch, if I try doing that and run Python of unpack.py, we're getting another type error. Missing 2 required positional arguments, sickles and knuts. I have to pass in 3 things. But wonderfully, Python allows you to unpack dictionaries as well. For a dictionary, you don't use a single asterisk, you use 2. And what this syntax has the effect of doing is passing in 3 values with names. It has the effect of passing in galleons equals 100, comma, sickles equals 50, comma, knuts equals 25. And so it has the similar effect to the list unpacking, but that just passed in the values, 100, 50, 25, separated by commas in effect. When unpacking a dictionary, it passes in the keys and the values, separated conceptually with equal signs, just like our function expects. So if I now run Python of unpack.py again, we're still good, but we've tightened our code up again. And now I'm giving myself yet another option. I can either store a wizard's purse or wallets in a list, as we did earlier, or I can store it a little more with even more specificity using a dictionary instead. And so to be clear, let me rewind. Star coins is the same thing, if I rewind a little bit, to our first example of named arguments is equivalent to what I've highlighted here. When you unpack a dictionary, it passes in all of the keys and all of the values, much like this syntax here. But let me tighten it up and go to where we left off. Questions now on unpacking.
Can we have in this dictionary, can we have, instead of having a constant name value pair, can we have a variable number of, name value pairs?
Short answer, yes. You can have more than 3 key value pairs as I have here. But it's not going to work unpacking it if the total function is expecting only 3. So if I were to add something here, like let me introduce pennies to the wizarding world, and suppose I have 1 penny, for instance, and now I run this same code, Python of unpack.py, we're back to a type error again, whereby I got an unexpected keyword argument, pennies, because that is not expected by the total function. We will see in just a moment, wonderfully, a solution, though, to that. But for now, it does not work. Other questions on unpacking with dictionaries or lists?
In list values, we gave the same number of arguments, and we declared a default value in the function. Now, if you use this asterisk, will it override that value, or will it skip the default value?
A good question. If we did have default values up here, for instance, equals 0, equals 0, equals 0. The upside of that, recall from our discussion of arguments to functions a while back, is that now you don't have to pass in all of those values. They will default to those zeros. Therefore, you could pass in fewer than 3 values, either using a list or a dictionary that's unpacked in this scenario. I deliberately did not do that because I wanted us to encounter this specific error in this case, but you could absolutely go back and add those defaults. So it turns out that this single asterisk or this double asterisk is not only used in the context of unpacking, that same syntax is actually used as a visual indicator in Python when a function itself might very well take a variable number of arguments. That is to say, a function can be variadic, which means that it doesn't necessarily have to take, say, 3 arguments specifically. Even if they do or don't have default values, it can take maybe 0 or 1 or 2 or 3. And it turns out the syntax for implementing the same idea is quite similar in spirit. In fact, let me go back to VS Code here, and let me propose that we start over with this code and get rid of our notion of galleons and sickles and canuts and do something just a little more generic, just so that we've seen the syntax for this. Suppose that I define a function as follows. Define a function, let's call it f, and that function is not going to take a specific number of arguments, but a variable one. And so I'm going to go ahead and use this syntax here, star args, which indicates that this function is indeed variadic. It takes some variable number of positional arguments. Positional in the sense that they go typically from left to right. But I don't know how many just yet I want to support. Suppose that I additionally want to support some number of keyword arguments, that is, named parameters that can be called optionally and individually by their own name. Well, the convention syntactically here would be to use 2 stars and then kw args. I could call args or kw args anything else that I want, but a convention you'll frequently see in Python's own documentation is that when you have placeholders like this for some number of arguments and some number of keyword arguments, the world tends to use args and kw args. Well, inside of this function, let's do something super simple just for now. Let me go ahead and print out literally, quote unquote, positional, just to indicate to myself while wrapping my mind around what's going on here, what the positional arguments are. And let me quite simply print out those args. This is not something you would typically do. You don't typically just take in these arguments and print them, no matter how many there are. I'm just doing this diagnostically for now to show you how the syntax works. Now, let me go ahead at the bottom of my file, and I won't bother with the main function this time, so we can focus only on this function f. Let me go ahead and just call f with 3 arguments. I'll use the same arguments as before, but I didn't bother giving them names just yet, like galleons and sickles and canuts and the like. So what do I have? A program that no matter what calls this function f, but it first defines f at the top of the file as taking some number of positional arguments, some number of named arguments, and for the moment, I'm just printing out the positional ones. Let me go ahead and in my terminal window run Python of unpack.py and hit enter. And you'll see that the positional arguments passed in are apparently this, a sequence, 100, 50, 25. But notice this. If I clear my terminal window there and pass in something else like 5, a fourth argument, previously, if I tried to change the number of arguments I'm passing in to my total function, which was only defined as taking 3, I would have gotten a type error, some visual indication that no, you can't pass in more or fewer arguments than is actually in the function's definition. But now watch. If I run Python of unpack.py, this time passing in 100, 50, 25, and 5, a fourth argument, all 4 of those went through just fine. I can get rid of all of those but one, for instance, now, rerun my program after clearing my screen, and now I'll see just one argument here. And even though there's a comma and nothing after it, this is actually the syntax when seeing a tuple, in effect, whereby the comma just indicates this is indeed a list, but there's only one element therein. Well, let's get a little more curious, too. Let me go ahead and rewind here to where we started with just those 3 values. And this time, let me go ahead and print out my named argument, so to speak, which is an args, but kw args. Again, the positional args in this syntax come first. The named arguments, kw args, come second. That's what Python prescribes. So now let me go ahead and not pass in just these numbers. Let me go ahead and pass in actually named arguments. So let me do something now, more specifically, like galleons equals 100, and sickles equals 50, and knuts equals 25. I'm not going to bother doing any math with total. I just want to poke around right now at this functionality of having a variable number of arguments. And what's neat now is if I run Python of unpack.py and hit enter, no problem. What kwargs is automatically a dictionary that contains all of the named arguments that were passed to my function. Which is to say, when designing your own functions, if you want to support more than one argument, maybe more than 2 or 3 or 4, maybe a variable number of arguments indeed, you can support both. A variable number of positional arguments that are just value, comma, value, comma, value, or any number of named arguments where you actually put the name of the parameter equals the value and then maybe a comma and some more of the same. So now it turns out we have seen this before in some of the functions we've used to date. We didn't necessarily see it called args or necessarily see it called kwargs, but we have seen at least one example of this in the wild. Recall our old friend print, which we've been using now for weeks. And when we first looked at the documentation for print way back when, it looked a little something like this. The first argument to print was objects, and I waved my hand at the time at the asterisk that was at the start of that variable name. But then we had sep for separator, the default value of which was a space. We had n, the default value of which was a new line, and then some other named arguments that we waved our hands at then and I'll again do now. But what you can now perhaps infer from our emphasis on these asterisks today, the single stars or the double stars, is that, you know what? This is the convention in Python's documentation to indicate that print takes a variable number of arguments. So if we were to look at the actual implementation of the print function implemented by Python's own authors, it might very well look something like this. Def print, and then the first argument would be star objects, thereby indicating that print takes a variable number of arguments, the next one of which might be sep equals quote unquote, either using double quotes or, as in the documentation, single quotes too. The next one of which might be n, the default value of which is a new line, and then some of those other named arguments that we've not looked at as well. And then maybe inside of the print function implemented by the authors of Python, maybe there's a for loop like for object in objects that allows them to iterate over each of those variable number of objects and print each of them. And this is why in programs past, you and I have been able to do just print, open parenthesis, close parenthesis, with nothing inside. Or you and I have been able to print out something like hello world, a single string inside of those parentheses. Or you and I have been able to do a single string hello and then another string, quote unquote, world, thereby passing in 2 arguments or even more. So we've long had this ability to use variadic functions whereby you can pass in a variable number of arguments. What you now have via this args and kwarg syntax, but again, they do not need to be called that, is the ability, using that star or 2 stars, to implement those kinds of functions yourself. My own f function a moment ago did not do anything all that interesting, but it hints at how you could, if in the future you have a use case for taking 0 or 1 or more of either type of argument. Any questions now on these types of arguments?
What will happen if we print quarks and the argument is like a list?
So what would happen if you print the argument like it's a list? So I think we saw that. If I roll back in my history here to when I had that f function, which I called f just to be very generic, just so we could play around with the syntax, this is what I had here. So this is I passed in 100, 50, 25. That gets automatically stored in args. And when I run it, you can actually see that sequence of values by running python of unpack.py. There is that sequence, all in the form of one single variable. I'm printing it just for diagnostic purposes. This is not really a useful or pretty program, but it hints at how we can access that whole sequence of values. Other questions on this approach here?
Can we pass KW args from one function to another function?
Absolutely. You can pass either of those to another function, which you might want to do if you want to wrap another function, provide some additional functionality, but still pass in all of the supported arguments to the underlying function as well. All right. How about this next? It turns out that a few other tools we can add to your toolkit relate to the types of programming models that Python supports. We started out quite some time ago focusing really on procedural programming in Python, whereby we wrote code top to bottom, left to right, defining some functions, or if you will, procedures along the way, defining variables and having side effects and assigning values as needed. But we then eventually introduced, or really revealed, that Python is also very much object-oriented. And a lot of those variables, a lot of those types that we were using all that time were in fact objects that were came from certain classes. And those classes were templates of sorts, blueprints, via which you could encapsulate both data and functionality therein. Well, we also saw along the way some hints of a third paradigm of programming that Python also to some extent it supports, which is known as functional programming, whereby functions are ever more powerful in that they tend not to have side effects, no printing or changing of state globally, but rather they're completely self-contained and might take as inputs and return values. And that's generally a paradigm we saw when we started sorting things, particularly with functions like our sort function or lambda function, when we passed in the function we wanted to use to sort a list way back when. Well, it turns out Python has other functionality that is reminiscent of functional programming and indeed is a powerful way to solve problems a little more differently still. Let me propose this. Let me propose that I whip up a new program here in VS Code by closing our unpack.py and this time creating another program called yell. Suppose the goal at hand is to implement some program that allows the user to pass in input, and then it yells the response by forcing everything to uppercase. My apologies to those with headphones there. I'll modulate. So let me go ahead and run code of yell.py. And within yell.py, let's go ahead and implement a program that really does just that. Let's go ahead and define a main function up here. And let's assume for the moment that this yell function already exists and yell something like this is CS50, properly capitalized, not in all caps. Now let's go ahead and implement this yell function with def yell. It's going to take for now a single word or phrase. And let's go ahead and I'll call it phrase here. And I'm going to go ahead and just print out the phrase.upper. So phrase.upper is going to force the whole thing to uppercase. And as usual down here, if the name of this file equals quote unquote main, then let's go ahead, as always, and call main. So let's just run this. But for the most part, it should be fairly straightforward. When I run python of yell.py, this is CS50 is yelled on the screen. All right, that's nice, but it's not great that yell only expects a single phrase. Wouldn't it be nice, like print, if I could pass in one phrase or two or three or really multiple words more generally, but as individual words themselves? So let me retool this a little bit and change yell to take in not a phrase, but how about something like a list of words, so that ultimately I can call yell like this, quote unquote this inside of a list, quote unquote this inside of a list, and quote unquote CS50 inside of a list. I'm not going to bother with type hints or annotations for now, but I'll just assume that yell has been defined now as taking a list of words as defined here. But now I want to force them all to lowercase. So I don't quite want to do something as simple as this. Like for word in words, I could, for instance, print that given word and maybe end the line with nothing right now. But I think if I do this, Python of yell.py, no, that's not right. I haven't forced anything to uppercase. So let's fix this. Well, let's go ahead and do the following. Let me go ahead and accumulate the uppercase words as follows. Let me create a variable called uppercased and initialize it to an empty list using square brackets or our more verbose list syntax. And now let me go ahead and iterate over each of those words in words. And for each of them, let's go into our uppercased list, append to it the current word's uppercase version. So this is a way of creating a new list called uppercased that is just appending to that list each of the current words in the loop, but uppercased instead. And now just let me go ahead and print out the uppercased list. This isn't quite right. Let's see what happens here. Python of yell.py. OK, it's not quite right because I don't think I want those quotes or those square brackets. What am I seeing? I'm actually printing a list. But here's where some of our unpacking syntax now can be useful. I don't have to change my approach to this problem. I can just unpack uppercase by adding a single star. And now let me go ahead and rerun Python of yell.py. And now it's actually just English. There's no remnants of Python syntax like the quotes and the commas and the square brackets. I've now unpacked. This is CS50 as 3 separate arguments to print. So already now this unpacking technique would seem to be useful. Well, it's a little unfortunate that I now need to call yell, though, with a list of values in this way. This is just not the norm, or at least it's not nearly as user-friendly as something like the print function, where I can pass in 0 or 1 or 2 or 3 or any number of arguments. Why are you making me, for your yell function, pass in only a list? Well, we can do better. Let's adopt some of the new conventions we've learned, and let's go ahead and get rid of the list by removing the square brackets, and let's just pass yell 3 arguments. Now, I don't want to do something like change the definition of words to take in like word 1, word 2. Like that's not going to scale, and it's not going to handle different number of words. But we have a technique now. We can say star args, which will allow the yell function to accept any number of arguments. And just for specificity, let's not call it generically args. Let's name it something a little more self-explanatory, like star words. This just means I have a variable number of words being passed in. Now I think I've made a marginal improvement. Let me run this again, Python of yell.py. This is CS50, is in all caps, but it's just a little better, right? Because now I can treat yell just like I've long treated print. Pass in as many things as you want, and print will deal with it. Now, my yell function is just as powerful, it would seem. And better still, it also forces everything to uppercase. Well, it turns out Python comes with this function called map, whose purpose in life is to allow you to map, that is, apply some function to every element of some sequence, like a list. So for instance, if we want to force to uppercase each of the words, this is CS50 in the list of words that's been passed in, well, we essentially want to map the uppercase function to each of those values. So using map in Python, can I do just that? Let me go back here to VS Code, and let me propose now that I re-implement this as follows. I get rid of all 3 of these lines here, getting rid of that loop in particular. Let me still declare a variable called uppercased, but let me set it equal to the return value of this new function called map. Map takes 2 arguments here in this case, the name of a function that I want to map onto a sequence of values. Well, what function do I want to apply to every word that's been passed in? Well, it turns out, thanks to my knowledge now of object-oriented programming, I know that in the stir class, there is a function called upper. We've usually called it by using the name of a string variable dot upper, open paren, close paren. But if you read the documentation for the stir class, you'll see that the function is described indeed as stir.upper. I'm not using parentheses, open and close, at the end of stir.upper because I don't want to call it now. I want to pass this function to the map function so that map can somehow add those parentheses, so to speak, and call it on every one of these words. And this is what map does quite powerfully, and is an instance indeed of functional programming whereby I'm passing to this map function another function, not calling it. I'm just passing it in by a reference of sorts. And what map is going to do for me is iterate over each of those words, call stir.upper on each of those words, and return to me a brand new list containing all of those results together in one list. It completely obviates the need for me to do this more manually using that list. I'm still going to print the whole thing using star uppercase so that if I get back a list of 3 uppercase words, I'm going to unpack them and print them all out. So let's run this again. Python of yell.py, enter, and voila, it's still working. But the code now is even tighter than before. So it turns out there's another way we can solve this problem in a way that's even more Pythonic, or at least quite common, and that's using a feature known as a list comprehension. And it's a big phrase, if you will, but it refers to the ability in Python for you to very easily construct a list on the fly without using a loop, without calling append and append, but to do everything in one, dare say, elegant one-liner. So how can I go about using this notion of a list comprehension? Well, let me go ahead and do this. In yell.py, in VS Code here, let me go ahead and change my approach as follows. Instead of using map, which is perfectly fine and correct in this way, let me just show you this other way as well. A list comprehension is the opportunity to create a list like this, using square brackets like this, but inside of those square brackets to write a Python expression that in effect is going to dynamically generate a brand new list for you using some logic you've written. And the approach I might take here is this. If I want to store in this list the uppercase version of every word in that words list, I can do this. Word.upper for word in words. Now, this is a mouthful, but I dare say Python programmers love this capability of being able to define on the fly a list inside of which is any number of values that you would ordinarily, at least as we've done it, construct with a loop, and again, calling append and append and append, but that usually takes 2, 3, 4 or more lines. This list comprehension that I've highlighted here is now an alternative way to create the exact same thing, a list inside of which are a whole bunch of uppercased words. Which words? For each word in the words list that was passed into yell is what ends up in this list. Questions on this syntax here? It definitely takes a little bit of getting used to, because you've got like this value on the left, this function call here. You've got this loop inside of the square brackets. But if you become accustomed to reading the code in this way from left to right, this means give me the uppercase version of the word for each word in my words list. Questions here on list comprehensions?
Hi. Can you do conditionals also like if, else, or combine? If, else?
Indeed you can. And let me come back to that where we'll see an opportunity to do things conditionally. But for now, I'm just uppercasing every word in the list. A good question. Other questions?
Yeah. Is this functional programming, or I mean this particular thing where you're saying words.upper for word in words?
Not necessarily. This is more of a feature of Python, I would say. Okay. Yeah, map was one very specific incarnation thereof. Our use of lambda and passing it in as a key attribute to the sorted function a while back was an example, and we're about to see one other. So we can even use these list comprehensions to filter values in or out of our resulting list. So in fact, in VS Code here, let me close yell.py and close my terminal window. And let me create a new program here whose purpose in life maybe is to take our same list of students as before with a shorter version thereof and just filter out all of the students in Gryffindor. So let me go ahead and create a file called Gryffindors.py. I'm going to go ahead and copy paste from before really my list of students, at least Hermione, Harry, Ron, and Draco from the start here, just so that I can focus on one student who happens not to be from Slytherin. And what I'm going to do here now, if I want to filter out only the Gryffindor students, let me go ahead and do this. Let me create another variable called Gryffindors, which is going to equal the following list. And this is going to be a bit of a longer line, so I'm going to proactively move my square brackets onto 2 separate lines. And I'm going to create now a list comprehension. I want to do this. I want this new list called Gryffindors to contain every student's name for each student in the students list, but if the student's house equals quote unquote Gryffindor. So this is nearly identical in spirit to what I just did earlier to create a list comprehension out of each of the words passed to my yell function. But here, I'm doing so conditionally. And so I'm borrowing inspiration from our focus on loops, borrowing some inspiration from our focus on conditionals, combining that into this same square bracket notation so that what Gryffindors ultimately is 0 or more students' names, and the names that are included are the result of iterating over each of those students and only including in the final result the students whose house happens to be Gryffindor. So when I go ahead and run this with Python of gryffindors.py and hit enter, you'll see, nothing actually happened here. Well, that's because I didn't finish the program. Let me go ahead and actually finish the program with this. How about for each Gryffindor in Gryffindors plural, and better yet, so that it's sensible that I did all of this work in advance, let me go ahead and sort all of those names with our familiar sorted function. Let's go ahead now and print out each of these Gryffindors. So now notice, if familiar with the books and the movies, you'll know that only 3 of these 4 students are actually in Gryffindor. And if I run Python of gryffindor.py, there we see Harry, Hermione, and Ron, but now in sorted order as well. So that's just one way we can solve this same problem using not just a list comprehension, but a list comprehension that has this conditional therein. But there's yet other ways to solve this same problem too, and we come back to some functional features of Python. In addition to functions like map, there's also this one called filter that can be used to achieve the same effect, but with a more functional approach, if you will. Let me go back to VS Code here, and with the same example, let me do this. Let me leave the original list up above as before, including Draco, who's not, in fact, from Gryffindor. And let me temporarily define a function called isGryffindor that takes in as value something like a student s. And then let's do this. Let's go ahead and say if s, quote unquote, house equals Gryffindor, then go ahead and return true. Otherwise, go ahead and return false. Now, we've seen before conditionals like this that are a bit unnecessarily verbose. I don't need to have a conditional if I'm already asking a Boolean question up here. So I can actually tighten this up as we've done in the past and just return, does the student's house equal Gryffindor? Either it does and it's true, or it doesn't and it's false. I don't need to explicitly return true or false. I can just return the value of that Boolean. Let's go ahead now and do this. I'm going to create, as before, a variable called Gryffindors, a list for all of my Gryffindor students that equals to, this time, the result of calling filter. Filter takes at least 2 arguments here, one of which is the name of a function to call isGryffindor, and I'm going to apply that function to each of the elements of this sequence here. So similar in spirit to map, I'm passing in a function that's going to be applied to each of the elements in the sequence. But map returns 1 value for each element in the sequence. That's how we forced all of the words to uppercase. But if I want to conditionally include a student in my resulting Gryffindors list, I can use filter instead. Filter expects its first function to be not something like stir.upper, but a function that returns true or false. Tell me whether or not I should include or not include the current student from the final list. And the question being asked is, do they live in Gryffindor? We're checking the dictionary's house key for that answer. And so ultimately, I think we'll be left with something quite similar. For Gryffindor in the sorted let's do for Gryffindor in Gryffindors, let's go ahead then and print out the current student's Gryffindor name. It's not going to be sorted just yet. But when I run this version here, Python of gryffindors.py, and hit enter, we're back in business. It's unsorted, but we have Hermione, Harry, and Ron, but not Draco. And if you recall from a few weeks back, if we want to sort even a list of dictionaries, we can still do that too. I can call sorted on Gryffindors, plural, and I can pass in a key. And that key can have a anonymous function, aka a lambda function, that takes in a student as input, call it s, and then returns the value s quote unquote name if my goal is to sort by, indeed, students' own names. If I go ahead now and run Python of gryffindors.py, I see the same list of students, but this time it's sorted. So here we've seen 2 approaches to this particular problem of Gryffindor students, whereby we can either use something like a list comprehension, and inside of that list comprehension do a bit of filtration, including an if conditional as I did, Or we can take a more functional approach by just using this filter function, passing into it the function that I want to make these decisions for me, and then include only those for whom true is returned. Any questions on either of these two approaches?
Yeah, I just had a question that if we write the code like in the previous version where everything is stuffed into one line, if we check for the style of the code, then don't it have a problem with it because it's less readable?
So would a formatter like black have a problem with the style of some of this code?
The previous one where everything was stuffed into one line.
Oh, a good question. Would something like black have a problem with this code? Well, let me rewind to that version, which was using the somewhat longer list comprehension, which looked like, if we go far enough back, give me a few more undos, which looked like this ultimately. Let me go ahead and run black on Gryffindors.py, and you'll see that it reformatted ever so slightly, but I proactively fixed this myself. Had I done this and done it on just one line, but I knew that black might not like that, it would have fixed it for me. So I just proactively fixed it before writing the code myself. How about time for one other question on Gryffindors.py and this approach of using a list comprehension or filter?
Yeah, when using filter, instead of calling the function is Gryffindor, can you use it right there inside filter?
Can you use the function is Gryffindor? So you don't want to call it like this, because you don't want to call it then. You want filter to call the function for you, if that's what you mean. So I pass it in only by its name instead.
No, I meant if you can write the return as house equals Gryffindor inside filter.
Yes. Indeed. In fact, so recall that we indeed used these lambda functions way back when we wanted to pass in a quick and dirty function anonymously to allow sorted to filter by a different key of a dictionary. We can do that here. I can actually take the essence of this isGryffindor function. I can change the name of this function in my filter call to be another lambda function, passing in an argument like s and returning exactly that. I can now delete my isGryffindor function altogether. And now when I run Python of Gryffindors.py, I still get the same answer. And I've not bothered defining a function only to then use it in one and only one place. Well, let me propose, too, that we equip you with one other tool for your toolkit, namely dictionary comprehensions as well. And admittedly, the syntax is starting to get even weirder, but as you get more comfortable with all of these primitives and others, these are just tools that you can optionally, but perhaps powerfully use to solve future problems down the road. And with a dictionary comprehension, we have the ability to create on the fly a dictionary with keys and some values without having to do it sort of old school by creating an empty dictionary and creating a for loop and iterating over that loop and inserting more and more keys and values into the dictionary. We can rather do it all at once. So in fact, let me go back to VS Code here and let me propose now that I do this. Let me go ahead and initially do it the old-fashioned way here as follows. Let me go ahead and simplify and get rid of the houses altogether so that we can focus for now just on a list of students' names. I'm going to go ahead and run students. I'm going to go ahead and write students equals quote unquote Hermione, quote unquote Harry, and we'll keep it even shorter this time, quote unquote Ron. Only those three students in Gryffindor. I'm going to now proactively, as we've done in the past, give myself an empty list so that I have something to accumulate some answers to this problem in. And now I'm going to do something like this. For student in students, so I can iterate over each of them, let's go ahead and with the Gryffindors list, append to it the name of the student, so quote unquote name and then student, which is indeed their name from that list. And now let's go ahead and just put these students all in Gryffindor. I know these three students are in Gryffindor, so suppose that the problem at hand is that I want to build up a list of dictionaries that only contains the Gryffindor students. So it's sort of a step back from the previous version where I already had the names and the houses. For now, just assume that the problem is I have all of their names, but I don't yet have the student dictionaries themselves. So I'm rebuilding that same structure that I previously took for granted. Now let's go ahead and just for the sake of discussion, just print out these Gryffindors so we can see what we've built. If I run Python of Gryffindors.py in my prompt, I see a bit of a cryptic syntax, but again, look for our little hints. I've got a square bracket at the end and a square bracket at the beginning, and that indicates, as always, this is a list. I have a whole bunch of curly braces with a whole bunch of quoted keys. They happen to be single quotes by convention when using print on a dictionary, but that's just a visual indicator that that is my key, and the first value thereof is Hermione. Second key is a house. This value thereof is Gryffindor. Then there's a comma, which separates one dict object from the next. And if we look past Harry and Gryffindor, there's a second comma, which separates Harry and Gryffindor from Ron and Gryffindor as well. So in short, here is some code whereby I fairly manually built up with a for loop in an otherwise initially empty list the same data structure as before, minus Draco, just for Gryffindor students. But here's where, again, with dictionary comprehensions or really list comprehensions first, can we do this a little more succinctly? Let me clear my terminal window. Let's get rid of this initially empty list and this for loop that appends to it. And let's just do this. A Gryffindor's variable will equal the following list comprehension. Inside of that list, I want a dictionary structured with someone's name and their name, someone's house, and only for now Gryffindor. And that's it. But I want one of these dict objects here in these curly braces for each student in students. So here too, inside of my list comprehension with my square brackets, I want an object as I want a dictionary as indicated by the curly braces. I want each of those dictionaries to have two keys, name and house respectively. The values thereof are the student's name from earlier here and Gryffindor only. Which students do I want to create those dict objects from? Well, for student in students. So again, on the left, I have what I want in the final list. And on the right, I have a loop. And this time, no conditional. I want all of these students in Gryffindor as their house. Now, let's print this again. Python of Gryffindors.py and hit Enter. And now we have the exact same output. So instead of 3 lines, it's just 1. It's a little more cryptic to read at first glance, but once familiar with list comprehensions and this sort of syntax, it's just another way of solving that same problem. What if I want to change this and simplify? What if I don't want a list of dictionaries, which I now have? Again, per the square brackets, I have a list of 3 dict objects here. What if I just want one bigger dictionary inside of which is a key like Hermione, Gryffindor, Harry, Gryffindor, Ron, Gryffindor. I don't need a list. I don't need separate objects per student. I just want instead one big dictionary where the keys are the students' names and the values are their house. And I'm assuming for now no one's going to have the same first name in this world. Well, I can do this. Let me get rid of this here and not create a list comprehension, but again, this thing known as a dictionary comprehension. And the visual indicator or difference here is that instead of it being square brackets on the very outside, this time it's going to be curly braces instead. So inside of these curly braces, what do I want every key to be? I want every key to be the student's name. I want every value for now to be Gryffindor. And I want to do this for each student in students. And now things are getting really interesting. And this is another manifestation of Python, in some views, being very readable from left to right. Absolutely takes practice and comfort, but this is creating a variable called Gryffindor, which is going to be a dictionary per these curly braces. Every key is going to be the name of some student. Every value is going to be Gryffindor. What names of what students? Well, this dictionary comprehension will be constructed from the list of students one at a time. So when I print this now, the syntax will look a little different because it's not a list of dictionary objects. It's just one bigger dictionary object itself. But now printing Gryffindors gives me Hermione, Gryffindor, Harry, Gryffindor, and Ron, Gryffindor as well. Any questions now on what we've called dictionary comprehensions as well? Any questions on here? No? Well, let's introduce one other function from Python's toolkit, followed by one final feature and flourish. And then you're off on your way. Well, let's go ahead and think back to this. Recall some time ago that we had just a simple list of students as we have here, Hermione, Harry, and Ron. And for instance, way back when, we wanted to print out, for instance, their ranking from 1 to 2 to 3. Unfortunately, when you do something like this, for student in students, you can print out the student's name quite easily. Of course, if I do Python of Gryffindors.py, I get Hermione, Harry, Ron in that same order. But I don't see any numerical rank. I see no number 1, 2, or 3. So I could maybe do this with maybe a different type of for loop. Instead of this, why don't I try this? So maybe I could do for I in the range of the length of the student's list. And we've done something like this before. And then I could print out I, and I could print out the student's name by indexing into that list at location I. Well, what does this look like? If I run Python of Gryffindors.py, it's close. But, you know, these aren't programmers. They don't necessarily think of themselves as 0 indexed. Hermione probably wants to be first, not 0. So how can we fix this? Well, just a little bit of arithmetic. I could print out I plus 1, of course, and then the student's name. So if I clear my terminal window and run Python of Gryffindors.py once more, now we have this enumeration, 1, 2, 3, of each of these students. But it turns out that Python actually has had all this time another built-in function that you might now find useful. That is, namely, enumerate. And enumerate allows you to solve this kind of problem much more simply by iterating over some sequence, but finding out not each value one at a time, but both the value one at a time and the index thereof. It gives you back 2 answers at once. So if I go back to VS Code here now and take this approach, I don't need to do this complicated range and length and then I all over the place. I can more succinctly do this. I can say for I, comma, student in the enumerate return value passing in students. So this gives me back an enumeration, if you will. And now I can go about printing I plus 1 as before, and I can print out the student. So I don't need to index into the list with bracket I notation. I don't need to call range. I don't need to call length. Again, enumerate takes a sequence of values like these students, and it allows me to get back the current index, 0, 1, 2, and the current value, Hermione, Harry, Ron, respectively. So now it just tightened things up further. And indeed, that's been our theme here. Can we solve the same problems as we've been solving for weeks, but tighten things up using just more of this toolkit? Allow us to equip you with one final tool for your toolkit, namely this ability to generate values in Python from functions. This is not a problem that we've necessarily encountered before, but it turns out if you're writing a function that reads or generates lots of data, your function, your program, your computer might very well run out of memory and your program might not be able to run any further. But it turns out there's a solution to this problem that's something you might have in your back pocket, particularly if after this course you start crunching quite a few numbers and analyzing all the more data. In fact, let's go back to VS Code here, and let's go ahead and create a program that's perhaps timely at this time of day, particularly depending on your time zone. You might be feeling all the more sleepy. But here in the US, it's quite common to be lulled to sleep when you're struggling otherwise by counting sheep in your head. And typically, as depicted in cartoons, you might see in your mind's eye 1 sheep jumping over a fence and then 2, and then 3 sheep and then 4. And then eventually you presumably get so bored counting these sheep, you actually do fall asleep. So in VS Code here, let's create a program called sleep.py that allows me to print out some number of sheep as though I'm counting them in my mind's eye. And via this program, let's do this. Let's prompt the user for a variable n, setting it equal to the integer conversion of the return value of input, asking the user, what's n, for how many sheep do they want to try counting. And then let's do a familiar for loop here, and we'll start counting from 0 as always. So we'll first have 0 sheep, then 1 sheep, then 2 sheep, and so on. For I, in the range of that value n, go ahead and print out, and I'll paste here an emoji representing a sheep times I. So the first iteration, I'll see 0 sheep. The second iteration, I'll see 1 and then 2, and then however many specified by n ultimately minus 1. All right, let's go down into my terminal window here and run Python of sleep.py, and I should see indeed, after typing in, say, 3 for my value of n, 0 sheep, then 1 sheep, then 2 sheep, and so forth. And if I make my terminal window even bigger here, we can, of course, do many more than this, typing in, for instance, 10, and you'll see that we get more and more sheep as time passes, presumably becoming all the more tedious to envision in my mind's eye. So let's now go ahead and practice what we've been preaching when it comes to the design of this program and see if and when we actually run into a problem. Let me go ahead here now and put all of this in a main function by defining main up here as always. Let me go ahead and indent all of this code here, and then let me just do this conditionally as always. If the name of this file equals quote unquote main, let's go ahead and call main. Let's make sure I didn't break anything just yet, even though functionally this should be nearly the same. And if I type in 3, I still have 0, then 1, then 2 sheep on the screen. But we've been in the habit, of course, of creating helper functions for ourselves. That is, factoring our code in a way that allows us to abstract away certain functionality, like generating some number of sheep, into separate functions so that, one, they're indeed abstracted and we no longer have to think about how they're implemented, and we can even reuse them in projects as in libraries. But we've also been in the habit, too, of now testing those functions, as with unit tests. So I probably shouldn't keep all of my logic anyway in main, and let's factor some of this out. Wouldn't it be nice if I could, for instance, just call a sheep function as by taking this line of code here, and instead of just printing it here, let's print out the return value of a new function called sheep that tells the function how many sheep to print, I in this case. Let's go down as always and create another function here called sheep. The sheep function now will take a parameter n that specifies how many sheep do you want to return. And so that we can test this as with a unit test, though we won't do that here, let me go ahead and not print the number of sheep as via a side effect, but let me go ahead and return one of those sheep times n so that the user gets back a whole string of sheep that's the appropriate number to print. So here too, functionally, I don't think we've changed anything too fundamentally. Python of sleep.py typing 3 still gives us 0, then 1, and then 2 sheep. But now we at least have a framework for focusing on the implementation of this sheep function. But it's a little inelegant now that it's still up to the main function to do this iteration. We've seen in the past, way back in week 0, wouldn't it be nice to define a function that actually handles the process of returning the entire string that we want rather than just one row of sheep at a time? Well, I think we can do this. Why don't I go ahead and change sheep as follows? Let me go ahead here and first create a flock of sheep that's initially empty using an empty list. Then for I in the range of n, let's go ahead and append to that flock, for instance, 1 sheep times I, so that I keep adding to this list 0 sheep, then 1 sheep, then 2 sheep, then 3, and so forth. And then ultimately, I'm going to return the whole flock of sheep at once. So this is going to return the equivalent of all of those strings of sheep so that main can handle the printing thereof. So back up here in main, let's do this. How about for each sheep, I'll call it s, since sheep is both singular and plural. For s in sheep of n, which again returns to me a list of all of the sheep, the whole flock, let's just print out each sheep s one at a time. All right, so far so good here, I think. Let me go ahead and run Python of sleep.py and hit enter. What's n? 3. And that still seems to work just fine. But let me get a little creative here and see not just 3 sheep on my screen, but maybe 10 rows of sheep. And that too seems to work fine. Let me get a little more adventurous and type in maybe 100 sheep. And it's starting to look ugly, to be fair, but they're all printing out pretty fast. Let me go ahead and try again with maybe 1,000 sheep on the screen. And they flew by pretty fast. It's still pretty messy, but they're all there. We could count them all up. How about not just 1,000, but 10,000 sheep? Well, that too seems OK. It's taking like 10 times as long, and that's why you see this flickering on the screen. All of the sheep are still printing, but, it's a lot of data being printed. If I hang in there a little longer, hopefully we'll see all 10,000 sheep coming to pass. This is here in the video where we will speed up time a la a reel online. Oh my God, this is a lot of sheep. There we go. OK, and now all of my sheep have been printed. So it seems to be working just fine. Well, let me just be even more adventurous and OK, let me try my luck. Let me try like, how about 1 million sheep this time and hit enter. Something's no longer working. While we wait for a spoiler here, does anyone have any intuition for why my program suddenly stopped printing sheep? What is going wrong in this version wherein I'm generating this really big flock of sheep.
We might have run out of memory or computation power.
Yeah, so maybe we're actually pushing the limits of my Mac, my PCs, my cloud servers, memory, or CPU, the brains of the computer's capabilities, because it's just trying to generate massive, massive, massive lists of sheep. 1 million of those rows of sheep, each of which has a huge number of sheep. And it seems that my computer here is honestly just really struggling. And this is really unfortunate now, because it would seem that even though this program clearly works pretty well for 1,000 sheep, 10,000 sheep, once you cross some threshold, it just stops working altogether, or it just takes way too long for the program to be useful anymore. But this seems a little silly, right? Because theoretically, I should absolutely be able to print all of these same sheep if I just printed 1 right away, then print 2 right away, then print 3, then 4, then 5. It seems that the essence of this problem, if I go back to my code, is that per my best practices, that I'm trying to practice what I'm preaching, it seems that the fundamental problem is that I've modularized my code by creating this helper function called sheep, whose purpose in life is to do all of the generation of sheep and then return all of them at once. Wouldn't it be better, and I can actually hear my fan turning on now even, just trying to generate these sheep, wouldn't it be better then to just print the sheep 1, 2, 3, 4 at a time? Well, we could do that, but that's really a step backwards. That rather contradicts all of the lessons learned of the past few weeks, where generally not putting everything in main is a good thing. Generally having an additional function that you can then test separately with unit tests is a good thing. Do we really need to give up all of those best practices just to print out some sheep and here fall asleep? Well, it turns out there's a solution to this problem, and namely in the form of these generators in Python. You can define a function as a generator whereby it can still generate a massive amount of data for your users, but you can have it return just a little bit of that data at a time. And you yourself can implement the code in almost the same way, but you don't have to worry about too much getting returned all at once. These two, like all features of Python, are documented in the official documentation therein. But what you'll find ultimately that it all boils down to this keyword here, yield. Up until now, when we've been making functions, we have been defining functions that return values, if at all, using the keyword return. And indeed, if we go back to our code here, that's exactly what I've been waiting for. I've been waiting to return the whole flock at once. Unfortunately, if you wait too long, and here we have it, my program was quote unquote killed. That is to say, my computer got so fed up with how much memory and CPU it was trying to use, it just said, nope, you're not going to run at all. And that's unfortunate. Now my program no longer works for large numbers of sheep, which is not good if I'm really having trouble falling asleep some night. So how can I use yield to solve this problem instead? Well, let me do this. Instead of building up this massive list of sheep in this big list called flock, let's just do this instead. Let me go ahead and simplify this whole function as follows, whereby I iterate for I in the range of n, and then on each iteration, in the past, I might have been inclined to use return and return something like 1 sheep times I, but this won't work here, right? Because if you want 1,000,000 sheep and you start a for loop saying for I in the range of 1,000,000, you're going to return accidentally 0 sheep right away. And then this function is essentially useless. You shouldn't return a value in the middle of a loop like this, because you're not going to get to any of these subsequent iterations of the loop. It's going to iterate once, and boom, you return. But thanks to this other keyword in Python called yield, you can tell Python to effectively return just 1 value at a time from this loop. So if I go back to this version of my code here, and I say not return, but yield, this is like saying return 1 value at a time. Return 1 value at a time. Return 1 value at a time. The for loop will keep working, and I will keep counting from 0 to 1 to 2 all the way up toward 1,000,000, but each time, the function is just going to hand you back a little piece of data. It's going to generate, so to speak, just a little bit of that data, not all of the data at once. And that's good, because my computer has a decent amount of RAM, certainly enough to fit 1 row of sheep. It just doesn't have enough memory to fit, apparently, 1,000,000 rows of so many sheep. So now, if I go to my terminal window and run Python of sleep.py and hit enter, what's n? 3 would still work. 0, then 1, and then 2. Let me go ahead and increase the size of this here and run Python of sleep.py. Let's try 1 million as before and hit enter. And now I immediately see results. I don't think we'll wait for all of these sheep to be printed, because then we will literally all be asleep. But what you'll notice happening now is the program is not hanging, so to speak. It's not waiting and waiting and thinking and trying to generate the entire flock at once. It's just generating one row of sheep at a time, and it's flickering on the screen because there's so many of them, and that's all thanks to yield. It's generating a little bit of data at a time, not all at once. Any questions now on this feature called generators? Any questions at all? To add one more piece of terminology to the mix, just so you've heard it, this same feature here is returning what we'll technically now call an iterator. Yield is returning an iterator that allows your own code, your own for loop in main, to iterate over these generated values one at a time.
How does this yield actually works under the hood? I mean, is it using multi-threading?
You can think of the implementation as being asynchronous in this sense, whereby the function is returning a value immediately and then subsequently giving you back another one as well. Underneath the hood, what's really happening is the generator is just retaining state for you. It is not going to run the entire loop from top to bottom and then return a value. It's going to do one iteration and yield a result. And the Python for you is going to suspend the function, if you will, but remember on what iteration it was. So the next time you iterate over it, as is going to happen again and again in this for loop in main, you get back another value again and again. So yield returns indeed this thing called an iterator, and that iterator can be stepped over as in a loop, one element at a time. But the language Python handles all of that for you so that you don't need to do all of the underlying plumbing yourself. How about time for one other question on these generators and iterators as our sheep continue to fly by?
So in every iteration, the program will return the memory to the system, so the program will not crash?
Correct. On each iteration, it's only returning the one string of sheep that's appropriate for the current value of I. It is not trying to return all million rows of the same. And therefore, it uses really 1/1,000,000th the amount of memory, although that's a bit of an oversimplification. All right, as these sheep continue to fly across the screen, let me now go ahead and interrupt this, as you might have had to in the past with infinite loops in your own code. Even though this isn't infinite, it's just really long. Control-C will interrupt with your keyboard that program, giving me back control of my computer. Well, here we are at the end of CS50's introduction to programming with Python. And if today in particular of all days felt like a real escalation real quickly, realize that these are just additional, perhaps optional tools in your toolkit that you can add to all of the past lessons learned, so that as you exit from this course and tackle other courses or projects of your own, you have all the more of a mental model and all the more of a toolbox with which to solve those same problems. If we think back now just a few weeks ago, it was probably in our focus on functions and variables that you first started struggling. But now in retrospect, if you look back at those problems and those same problem sets, odds are those same problems would come all too easily to you now. Conditionals was the next step in the class, wherein we gave you the ability to ask questions and get answers and therefore do things conditionally in your code. We came full circle today, and you can see that you can now use those same kinds of conditionals now to do fancier things with list comprehensions and dictionary comprehensions and the like. Loops, of course, have been omnipresent now for weeks, including today as we built up those same structures. And of course, something can go wrong. And exceptions and exception handling was our mechanism for not only catching errors in code, but also raising your own exceptions, so that if you're laying the foundation to write code for other people, as in the form of libraries, you can do that too. Libraries, of course, are things you can not only use, but now write on your own, be it a small module or whole package of code that you want to share with others around the world. And even better, can you write tests for your own code, for your library, libraries for others' code as well, so that ultimately you can be all the more confident that not only your code is correct today, but if you make a change to your code tomorrow, you haven't broken anything, at least according to your tests, if they continue to pass. File I/O, though, meanwhile, was a way of now storing data not just in the computer's memory like all of these sheep, but actually storing things persistently, longer term to disk, be it in a CSV or something more like a binary file like an image. With regular expressions, you then had the ability to express patterns and actually validate data or extract data from information, all the more of a useful technique nowadays when so much of the world is trying to analyze and process data at scale, some of which might in fact be quite messy from the get-go. And then, of course, most recently, object-oriented programming, an opportunity to solve the same kinds of problems, but with a slightly different perspective, a way to encapsulate and to represent real-world entities, this time in code. And today, of course, etc., was so many other tools that you can add that didn't necessarily fall under any of those earlier umbrellas, but are useful functions and data types and techniques just to have, again, in your back pocket as yet other mechanisms for solving problems as well. Not just putting everyone to sleep, but I thought another way to end might be a little more vocally to try writing one final program together, this one using a library we've seen in the past, as well as one other. I've taken the liberty of installing a text-to-speech library on my computer here. And I'm going to go ahead perhaps and open a new file here called say.py in VS Code. And I'm going to go ahead here and first import our own friend, import cowsay. And I'm going to import this new library here, import pyttsx3, the Python text-to-speech library. And now, per its documentation, which I read in advance, I'm going to go ahead and create a variable for myself here, engine, equals pyttsx3.init to initialize that library for text-to-speech. I'm going to then ask the user, well, what do I want to hear spoken? And I might do something like this. A variable called this equals the return value of input. What's this shall be my simple question, and I'm going to keep it this time as a string. We've seen how to use cowsay. We can do cowsay.cow of this. Turns out this new library can allow me to use its own engine to say this as well. But then ultimately, I'm going to have to run the engine.run and wait, just in case it's a long phrase or sentence to be said. But that's it. In just 8 lines of code, not only am I apparently going to have a cow appear on the screen to close us out now, but also some synthesized text. Ultimately, then, we hope with this course that you've not only learned Python, that you've not only learned programming, but you've really learned how to solve problems and ultimately how to teach yourself new languages. Funny enough, I myself only learned Python just a few years ago. And even though I certainly went through some formal documentation and resources online, I mostly learned what I know now and even what I had to learn again for today by just asking lots of questions, be it of Google or friends who are more versed in this language than I. And so having that instinct, having that vocabulary by which to ask questions of others, to search for answers to questions, you absolutely now have enough of a foundation in Python and programming to go off and stand on your own. So you can certainly, and you're welcome and encouraged to go on and take other courses in Python and programming specifically, but better still, as quickly as you can, is to find some project that's personally of interest that uses Python or some other language, because at least from my own experience, I tend to learn best, and I hope you might too, by actually applying these skills, not to problems in the classroom, but really, truly, to problems in the real world. Allow me, with all that said, to look at my full screen terminal window here, run Python of say.py, crossing my fingers one final time in hopes that I've not made any mistakes or bugs. And here we go, Python of say.py, prompting me, what's this? How about we end on this note here?
This was CS50.